Hello everyone, good morning and good afternoon. We're going to start the workshop soon. And I would like to say thank you for joining with us this early, and thank you for staying with us since the first day of the workshop until today. So before we start, I would like to read some of the rules in this workshop. One, participants are required to rename their ID in the Zoom platform using their clear names and institutions. Two, participants are expected to mute their sound during the workshop, except when requested. Three, certificates will be given to participants who take part from the beginning until the end of the workshop. And four, the link to the attendance list will be given 15 minutes before the workshop ends. Okay, we're going to start the workshop in a few minutes, so please wait a few more minutes. Thank you. Honorable speakers, moderators, and participants, Assalamualaikum warahmatullahi wabarakatuh. Good morning and good evening, ladies and gentlemen. Welcome back to the third day of the 16th Annual Indonesia-US BMKG-NOAA Partnership Workshop, Subseasonal to Seasonal Forecast, Detecting Extreme Weather Events at Climate Scale. On the first and second day of the workshop, we had listened to numerous lectures about different topics, not only about weather and climate, but also about oceans and tsunamis, and we also had some fruitful discussion afterwards. On this last day of the workshop, we're still going to hear some more interesting presentations, and we hope you will enjoy this last day of the workshop. Ladies and gentlemen, before listening to the lectures, I would like to invite the NOAA International Coordinator, Dr. Sydney Thurston, to deliver the daily objectives and review from yesterday's event. Pak Sydney, the time is yours.
Terima kasih, Yesi. Welcome. Selamat pagi, dear BMKG colleagues. On behalf of your friends and colleagues at NOAA and in the USA, greetings from Washington, D.C., and welcome to the final day of the 16th Annual Indonesia-NOAA Ocean Climate Observations, Analysis, and Maritime Applications Partnership Workshop. I am Dr. Sydney Thurston, NOAA's Indian Ocean Rama Program Manager and Vice Chair of the World Meteorological Organization Standing Committee for Earth Observing Systems. I'm honored to co-chair this workshop organizing committee with my esteemed colleagues, Dr. Nelly Florida and Dr. Dodo Gunawan. Thank you very much, Bu Nelly and Pa Dodo. As Yesi said, yesterday, day 2, we had a very, very fruitful session with lots of information on tsunami, lots of information on drought and climate extremes. I'd really like to thank Mike Angove, Chip McCrary, Laura Kong, Diego Argas, and Bruce Howe for delivering the latest information on tsunami forecasting from the US and from NOAA. These presentations will be made available for your review after the workshop, as all presentations, on the BMKG website. please stay tuned for that. Tonight is our final night, and we have another very good agenda in line for you. We will be looking at equatorial atmospheric waves. We brought excellent presenters again tonight to discuss this topic. I'm really excited. Chidong Zhang will be with us from NOAA's Pacific Marine Environmental Laboratory, one of the foremost leaders in MJO, and he'll be presenting the latest results from the years of the maritime continent, the MJO over the maritime continent. We'll start off with Chidong. We had a last minute change in the agenda. Sandra Lubis will not be with us tonight. So after Chidong presents MJO and the maritime continent, we'll move directly to hear from AJ Rice. AJ is the director of NOAA's Ocean Prediction Center, OPC, and I know BMKG has a lot of interest in that with your Ocean Forecast System, OFS. So perhaps we'll have a few more minutes for Chidong to present MJ over the maritime continent, a few more minutes for AJ to bring us up to speed on the NOAA Ocean Prediction Center. We'll have a few minutes for discussion. We'll take a break. Then we'll move into our final session, number 7, hands-on training, practical session. And we're really, really pleased and grateful to Professor Carl Schreck from North Carolina State University. He's with us again this year. He'll be talking about predicting the MJO, equatorial waves, and extreme rainfall. And North Carolina State has interactive mapping tool, which is great interest to BMKG. And then we'll wrap it up for the night. We'll get a brief on NOAA Rama buoy rescue operation, and NOAA is grateful for that. We'll hear about that. So with that, let's get going. Let's open it up. And again, these presentations will be made available to you. After this busy week, you'll have time to go over them at your leisure and digest them. So with that, I'll pass it back. Yesi, terima kasih.
Thank you very much, Pak Sydney. Ladies and gentlemen, as Pak Sydney said, we're going to continue to the 6th session of the workshop, which is the general lectures with the topic of equatorial atmospheric waves. This session will be chaired by Dr. Carl Schreck as the moderator of the discussions. Dr. Carl Schreck currently serves as a research scholar in the North Carolina Institute for Climate Study, and he also serves as an adjunct assistant professor with the Department of Marine Earth and Atmospheric Sciences, North Carolina State University. Without further ado, I would like to invite Dr. Carl Schreck to lead the next session.
Thank you very much. It's a pleasure to be chairing this session, and we'll be starting off right away with Dr. Chidong Zhang from NOAA's PMEL. He's, again, one of the foremost experts on the MJO, and very excited to hear what he'll be speaking about with looking at the MJO in the maritime continent. Is Chidong on, actually?
Schreck, it seems like Dr. Chidong is not here yet. So maybe we can continue to the next presentation first.
AJ, is that okay with you?
Yes. We should continue to the next presentation, I think.
Okay. So then that event will skip right ahead to AJ Rice from the director of the NOAA Ocean Prediction Center, who will be talking about the current and future activities plans at the OPC. AJ, are you available to take it away? Oh, it sounds like we may not have either speaker just yet.
Um, okay, it's
This is Sydney. Yeah, let's just wait a few minutes. I've contacted AJ. AJ said he was planning to arrive at 9 p.m. EDT, which it is now. So he will be here any minute. And I just sent a message to Chidong also. So if we could just relax for a minute, please, colleagues, and we'll get started in a few minutes. We should be on schedule because Sandro Lubis is not with us.
Yeah.
So let's just relax and just take
We
a
can
couple
watch the
minute break.
video.
We can watch the video one more. I love that video.
Yes.
Yeah, let's roll the video.
Yeah.
Terima kasih, Nelly. Yeah. Okay, I just Chidong and I were just emailing. He will be on any second now. So let's
I'm here.
excellent, excellent. Please, Yessi, please proceed.
Pass it for waiting. Hello. Um, Earlier we were informed that Dr. Sandro Lubis from Rice University will not be able to present today, but it turns out that he's able to make it today and he's already in the Zoom. So is it okay if he presents something first today? Is that okay? Okay, so back to you then, Dr. Sprague.
All right, so I guess in that case, we'll kick right off with Sandra Lubas, who'll be speaking about tropical waves. Very interested to see some very interesting research focused on Indonesia.
Okay. Okay, give me a second, Carl.
Yeah. I apologize, I didn't have a chance to look up your full bio to share with the group.
No worry. Okay, I'm not able to share my screen, so.
And this is Chidong's presentation.
All right, now I can do it.
There we go.
Oh, wait, give me a second. Okay, can you guys see my screen?
Yes, looks good.
Okay, hey everyone, thank you. Good morning, selamat pagi. My name is Sandro Lubis. I'm a postdoctoral researcher at Rice University in Houston, Texas. Today, I'm going to talk about my recent research collaboration with IPB University Indonesia on understanding the regional scale influence of tropical wave on extreme rainfall in Indonesia. Okay, so the background, the variability of tropical precipitation over the maritime continents is significantly modulated by equatorial wave on a shorter time scales.
Sorry to interrupt. I think we're seeing we're not seeing your shared screen. We're still seeing the first slide.
Okay, so.
Okay.
Can you see it now?
We're not seeing the full screen mode. We're seeing just the window. You may have to share your desktop. Or...
Okay. And now?
Yes, that's perfect.
Okay, sorry for that. Okay, so the variability of tropical precipitation over the maritime continents has been found to be significantly influenced by equatorial wave on the shorter time scales. So Lubis and Jacobi, for instance, in 2015, found that about 16 to 20% of total rainfall variability can be explained by the equatorial wave. So recent study also shown that the frequency and the intensity of daily and diurnal extreme rainfall are significantly influenced by the equatorial wave. For example, the recent study by Brownowski in 2020 over the Sumatra Islands, they found that the extreme rainfall events and the flooding events are linked to the Kelvin wave activity. In fact, they found about 95% of the flooding events over Sumatra Islands is preceded by the Kelvin wave activity. However, the attribution of the equatorial wave on extreme rainfalls in general for this island remain unclear. So another study, for instance, by Ferret et al. 2020 found that over Southeast Asia, the variability of tropical rainfall are also can be explained by the equatorial wave. However, if you look at clearly on the composite analysis they did, so it turns out the significance over the land regions, so for Java Islands, are less significant compared over the ocean, which most likely due to the biases in the satellite data set. So I just straight to the objective of my studies to understand or to quantify the regional scale influence of tropical wave on extreme rainfall over two big islands in Indonesia, Sumatra and Java, and to understand the dynamics of the extreme rainfall modulated by different types of equatorial wave. And I would also like to understand the concurrent occurrence of different type of equatorial wave on precipitation extreme over these two different islands. Okay, so we employ the same technique as proposed early by Wheeler and Kylaides 1999 by using the 2D FFT analysis, focusing on 4 different types of equatorial waves. So it's for inertial gravity wave, equatorial Rossby wave, the first mode, Kelvin wave, and also mixed Rossby gravity wave. So we also use 2 different observed rainfall data sets. The first one is from the Upper Red project. It's high resolution grid rainfall data, merging between observation and radar and other measurements. And the second data set we use is rain gauge from the local station from the BMKG for different periods. So we focus our analysis over the boreal winter periods, which is from November to April. So in order to understand the influence of different phases of equatorial wave, we reconstruct the local phase diagram by calculating the normalized outgoing long wave radiation and its tendency. The local phase diagram is divided into 8 phases, which represent the dry phases, wet phases, and transition phases. Since we focus on the 2 different islands, so we use 2 different reference longitude over Sumatra, we choose 102 degrees east, and over Java Island, we choose 110 degrees east. We also calculate the changing in extreme probability by calculating the ratio of probability exceeding extreme rainfall for particular wave. We define the threshold 95% in this case with respect to the climatology, and all the composite analysis are calculated based on the bootstrap technique by randomly choosing 1,000 subsample data set. So this is an example of graphical representation of local phase diagram. So this is a case study for the early January 2020, where there is a major flood. So the left-hand side, you can clearly see the different type of modulation of different wave on ongoing wave radiation anomalies. There are MGO is there, Kelvin, ER, you name it. And the right-hand side is a different local phase diagram, which represent the evolution of the wave, different type of the wave for these periods. So you can clearly see that different wave propagate from the dry phase to the wet phase to the transition and so on. Okay, so as I mentioned earlier, that the phase 1 indicate the peak of the dry phase of the wave, and the phase 5 indicate the peak of the wet phase of the wave, right? And the transition are between phase 7 and phase 3. So this is the first result we found that over Sumatra. So as you can see on the left-hand side, it's really consistent with the phase diagram where there is increasing of extreme rainfall probability over Sumatra 100% based on the upper data set and about 95% based on the local station data set. And during the dry phase of the Kelvin wave, the probability decreased by 70% in upper right and 65% on the station data set. You can also see on the right on this figure that there is a clear eastward modulations of extreme rainfall following the eastward propagation of the Kelvin wave induced local wave activity. And all this, the hatching on the figure are indicated a significant value based on the bootstrap method. We also quantify for the other different type of the wave. Like example here on the left-hand side is equal to Rossby wave. But it turns out by calculating all different contributions of different waves, we found that the Kelvin wave has a major influence on the extreme rainfall for Sumatra Island by explaining almost above 100% of extreme probability rainfall events over this region during the wet phase and decreasing about 70% during the dry phase. Well, the other contribution from the ER and MRG are the secondary rule, and AIG is only little contribution on these extreme rainfall events. We also repeat the same calculation for the Java Islands using the rain gauge local data station and also the upper right data set. And we also clearly see here the consistent with the result that I found for Sumatra. There is increasing of the extreme rainfall probability by 60% using the upper right, and or about 45% using the station during the wet phase. And during the dry phase, the precipitation decreased by 50% in upper right, 45% in station data set. Also consistent with the result in Sumatra Islands, we can also see there is a clear eastward propagation of the rainfall modulation by this wave during different phase of this wave. Again, we repeat also the same analysis for the equatorial Rossby wave, and we found slightly weaker signals compared to Kelvin wave. So First, it reduced precipitations during the dry phase and increased during the wet phase, consistent with the other waves. And also we can clearly see there is a clear westward modulation of extreme rainfall follow the equatorial wave induced local convective activity of its regions. And as I compare with the Kelvin wave in previous slide, that the relation between this wave and the extreme rainfall is less homogeneous and is much weaker compared to Kelvin wave, which is due to the weaker amplitude of this wave over this region compared to the Kelvin wave. All right, so we also calculate the concurrent occurrence of the wave. So what's happened if the wave occur at the same time during the same phase, for instance. So we quantify for different type of the equatorial wave, also with the MGO, and we found that the positive interferences of the equatorial wave can lead to an amplifications of the extreme rainfall probability. In contrast, the negative interferences, for instance, like dry phase of the Kelvin wave occur at the same time when there is a wet phase of the MGO, and then it's gonna lead to the suppression of the extreme rainfall probability. We also found that the superpositions among different types of the wave is approximately linear when the two waves are in phase each other, like with interaction. However, the relationship seems to be nonlinear when different type of the waves occur at the same time, different phase. I mean, so for instance, the dry phase occur during the same time with the dry phase of the MGO, so the relationship is nonlinear. In order to understand the modulation of the extreme rainfall by this wave, we also calculate the moisture budget analysis. So in this case, we decompose the local tendency of the moisture with the different terms to be the vertically integrated moisture flux conversion on the left-hand side, the vertical flux conversion and storage change. By assuming the local tendency and the vertical flux conversion are negligible, then the net precipitation will be equal to the vertically integrated moisture flux convergence. The vertically moisture flux convergence can be also decomposed into the effective terms and the convergent terms. In this way, we know what's the main driver of this via MVC. So these figures show the composite life cycle of the vertically integrated moisture flux convergence during the different phase of the Kelvin wave based on the cases of the extreme rainfall in Java. Okay, as you can see, compared to theory, first thing first, that the structure of the Kelvin waves really resemble a linear wave theory. And interestingly, that the increase in the vertical integrated moisture flux convergence anomalies occur in the regions where the mass flux convergence converges, consistent with the theoretical horizontal structure or the linear wave theory. And in the region where we have decreased extreme rainfall probability, you can see there is the divergence of the mass flux of the moisture, and this is also consistent with the linear wave theory. This is also the vertical structure of the Kelvin wave based on the specific humidity. And you can see that it is expected that there is increasing extreme rainfall during the wet phase of the Kelvin wave, and there is decreasing during the wet phase of the Kelvin wave. We also do the same thing for the Sumatra Islands. This is another composite for Sumatra Islands. It's the same conclusion we found as a Java Island. There is clear eastward propagations of the vertically integrated moisture flux convergence induced by the Kelvin wave during the extreme rainfall over Sumatra. This is the dry phase, and this is the wet phase, and this is the dry phase. And it's also consistent that the convergence of the vertical integrated moisture flux are related to the increasing the net precipitation of this region, and the divergence of the moisture flux is consistent with decreasing of the precipitation over this region. We also do the same for the equatorial Rossby wave. As you can see on the left-hand side, there is a clear westward propagations of the signals of the moisture flux convergence, and it can be seen that the convergence anomaly are collocated with twin cyclonic mass fluxes, which provide a favorable condition for the organization of the convections and therefore increase likelihood or probability of extreme rainfall during the wet phase. The same thing true also for the dry phase. However, during the dry phase, as you can see here on the right-hand side, that the region of negative moisture flux convergence is consistent with decreasing of extreme rainfall due to separation of the local convections. And this is the vertical structure, also the same as the one that I showed for the Kelvin wave. And we do also the same composite for a Sumatra cases. And this is the composite of the vertical integrated moisture flux convergence induced by the equatorial Rossby wave. And you can see that this is clear pattern consistent with the linear theory of the wave, Rossby wave. And there is a modulation of the moisture flux convergence to the west, consistent with the increasing of the extreme rainfall probability during the wet phase and decreasing during the dry phase. And finally, we also calculate each flux terms separately for different cases for the Kelvin and ER and MRG. And we found that on average, the convergent terms is larger than the efficient terms. And it is a dominant contributor to the VIMVC fluxes. And for the Kelvin wave, we found that the zonal convergence is the dominant term in the moisture convergence. And for the more rotational equatorial wave, such as ER and MRG, the meridional convergence is dominant terms in the moisture convergence, but they are mostly compensated by the zonal convergence. That's why it's not that huge compared to Kelvin wave, especially over the Java Islands. All right, so to conclude, we found that there is a robust regional scale influence of equatorial wave on extreme rainfall over Sumatra and Java during rainy seasons. So we found also compared to the other tropical type waves, the Kelvin wave has a greater percentage modulation on extreme rainfall over Java and Sumatra, and consistent with the dynamics that the positive equatorial wave interferences lead to amplification and the negative interferences lead to suppression of extreme rainfall probability over these islands. But the most important thing that I want to highlight here is that this result suggests that the equatorial wave can provide an important source of the predictability of extreme rainfall over Java and Sumatra Islands. Okay, thank you. That's it.
Thank you. It's an excellent presentation. Do we want to open this up for questions briefly before we go on to the next speaker?
This is Sid Carl. Yes, I would recommend 3 or 4 minutes of Q&A, please. Thank you.
Sounds good. Let's see, we've got a question from Chidong. Do you have any information of total precipitation related to the different types of waves in a year?
So, okay, so far what I calculated is based on the composite analysis, like more different cases of the events over only the boreal winter. So I do not really quantify like how much they are contributing for like the whole year. But yeah, but my previous studies show that over in general for the maritime continents, I mean the Kelvin wave mostly contribute about 16-20% of total rainfall variance over these islands. Yeah.
I had a quick question. So I know you've shown a couple islands. So do you have plans to do kind of a broader overall of Indonesia using satellite-based precipitation?
So what is your question anyway?
Sorry, so I think you focused mostly on individual islands so far.
All right. Yes. Yeah. Because if there is a bunch of recent studies, right? I mean, if you look at the Ferret et al., for instance, Baranowski and also Simon Pittman, they have already shown like the general, contribution of equatorial waves on the tropics, so like on the land and also over the oceans. But the problem that why we are interested over the land regions, because first, we want to validate if there is like significant influence or not, because we know that the satellite has a strong bias over the land regions, especially for the extreme events. And secondly, since we have like a lot of rain gauge localization data set, so we can calculate and prove that like how much is it exactly the amount of rainfall they are modulated by a different type of equatorial wave and how much they contribute to the extreme events. That is the main idea why we focus over the land regions, because I believe that Samantha Ferret already did that over Southeast Asia in general, include also the ocean and also over the land regions using the 3mm dataset, satellite dataset.
And then Mike McFadden asks, do sea surface temperature variations help organize or modulate the atmospheric wave intensity?
Yeah, we haven't looked at that surface, like the influence of the air-sea interaction on these coupling mechanisms. I don't have clear answer for that. So far, we just do based on the local phase diagram analysis by choosing the location where we have a stronger variance over the land regions. And then we just do a like composite or like probability calculation based on that. So we haven't really explored in more detail, like what is the role of the different ocean, like Indian Ocean or Pacific Ocean, which I believe they can affect the modulation. So for instance, the El Nino, for instance, has strong influence on the Kelvin wave for maritime continents, and the La Nina has strong influence over of the MRG wave for the maritime continents. So I believe they can have different, different processes that can affect the modulation impact on the extreme rainfall. But we haven't investigated that part yet.
Sounds good. Very, very great work. Very interesting talk. Looking forward to seeing some of these more other papers that are in preparation and review.
Thank you.
So with that, we'll move on to Chidong Zhang's presentation. Chidong's the leader of the Ocean Climate Research Division at NOAA's Pacific Marine Environmental Laboratory, and currently co-leading the International Years of the Maritime Continent, which he'll be talking about. Before that, he was a professor at University of Miami, where he was chief scientist for the dynamics of the MJO field campaign back in 2011, 2012. Hard to believe it's been 10 years already. So with that, Chidong, let's see if you can share your screen. And
okay, I'll give it a try. Share the screen. Screen number 2, let me see. Screen number 2, share. Okay, do you see the presentation?
it's very small, but we can see it.
Okay, let me put into display. How about this?
Perfect.
Okay. Well, thank you for the opportunity to give this presentation. I apologize for being late. I hope I didn't delay the workshop too much. NOAA has developed sail drones in the Atlantic Ocean to observe hurricanes. And today we measured a major Category 4 hurricane. So there's a lot of news media materials that need to be prepared. But I'm glad I'm here, give this presentation. So it is very nice to hear Dr. Sandra Lubis to talk about the local impact of the MJO and associated equatorial waves over the maritime continent. So in my presentation, I'm going to focus on one issue that is critical to the remote impact of the MJO over the maritime continent. And that is what we know as the barrier effect of the maritime continent. As some of you may be familiar with, the barrier effect reflect the fact that some MJO events can propagate through the maritime continent into the Pacific and others cannot. So the maritime continent sometimes act as a barrier to MJO propagation eastward. And this is what my talk will be focused on. So this on the top panel, what you're seeing is a emanation of anomalies in precipitation that is in color and in 850 hectopascal wind. You see the wind vectors. Only so the wind vectors only plotted when it's significant at the 95% confidence level, and the small dots, the stipples, represent the significance of the rain anomalies. What you see here is positive anomaly of the rain start from the Indian Ocean, that's the blue color, then gradually propagate eastward, as you see here, and then propagate over the maritime continent. It's happening now, and then gradually propagated through the maritime continent into the Pacific Ocean. That's the upper panel. Now, if you look at the lower panel, it is the composite of a different type of MJO event. And those MGO events also start over the equatorial Indian Ocean, as you see in a moment. Now it starts forming, so the blue colors start appearing over the Indian Ocean. And then it moves eastward toward the Maritime continent and gradually over the Maritime continent. But then it starts to be weakened and disappeared. It does not show up in the Western Pacific as you see in the upper panel. So we term the MGO events that can cross the Maritime continent as MGO-C, and the upper panel, and the lower panel, the MGO events that are blocked by the Maritime continent, we call it MGO-B. And this barrier effect, it naturally happened in reality, but it is often exaggerated by numerical models. And this figure shows one example in terms of the RMM index of the MGO. So for those who are familiar with this, you have 8 phases that represent the MGO locations, as Dr. Sandro Lubas mentioned. The green circle in the middle represents the amplitude. If the line is inside the green circle, that means the MGO is too weak. And when the line is outside the green circle, that represents strong MGO. So observations show 2 types of MGO. One is a black line on the left panel, and one is represented by the red line. That is the MGO-C. So one is MGO-B, MGO-C. You can see the MGO-B does not propagate through the Maritime continent, or if you can see my cursor. And these 2 phases, phases 4 and 5, represent the Maritime continent. So the MGO-B propagate over the Maritime continent and become very, very weak. The MGO-C, in contrast, propagate through the MGO and maintain its strength into the Pacific Ocean. That's in these 2 phases. And the other 2 panels shows similar RMM phase for MGO-B in black, MGO-C in red. One is called ASS-S1, the other is POMA. Both are Australian Bureau of Meteorology operational model. And you can see in either of these 2 models, both the MGO-B and MGO-C is much weaker than in the observations. And so especially in this middle panel, you can see even for MGO-C that's supposed to propagate across the Maritime continent into the Pacific, it does not. It becomes much, much weaker. So this is what we call exaggeration of the barrier effect by numerical models. And in numerical model prediction scale, you can see on the right-hand side, measure the prediction scale for strong and weak MGO. Strong MGO in solid lines, weak MGO in dashed line. The different color represent the 2 models. So for weak MGO, the scale is useful up to about 11 days here. And for strong MGO, the useful prediction can last to about 30 days. But over the Maritime continent, the prediction scale is much, much weaker. That is showing to the right panel. So on the bottom is the lead time from 0 to 30 days, and the vertical is the MGO phase. The color represent the forecast scale. So if it is red, that means the forecast has a useful higher scale, and if it is blue or white, that means as a very low or no scale. So you can see over the Maritime continent, again, that is a phase 4 and 5, up to lead time 18 and 30, there's no scale at all. Well, over the Pacific Ocean or Indian Ocean, they have some higher scale. So again, predicting MGO propagating over the Maritime continent currently is a big challenge. And this just showing you in these 2 models, the MGO-C, the MGO that propagated through the Maritime continent, actually has higher prediction scale, and the MGO-B has much lower prediction scale in both these models. Why I cannot? Okay, so there are several possible reasons for the barrier effect in reality. One is topography that may interfere with the MGO low-level circulation. The second one is the land block the surface evaporation from the ocean, which is important source of MGO energy. And the diurnal cycle is another one, which I will talk a little bit more. And the last one is regional and larger scale circulation patterns. So let's go ahead and say, no matter what the mechanism for the barrier effect, you have to have a counter mechanism to overcome the barrier effect. And it can be Ayres interaction, and it can be the MGO structure and strength. We'll see what do we know at this moment. So those slides showing you a series of coupled model simulation of a one MGO event. And to the left is observations. You can see the precipitation anomaly, the color systematically propagated eastward into from the Indian Ocean to the Pacific. The x-axis represents the longitude. And this is the simulation control run. And it shows some eastward propagation, but weaker than the observations. And very interestingly, when you take away the topography and replace the maritime continent with a flat land, so you have land cover, but no topography, no height, the simulation does not change much. But if you completely remove the land and replace them with water, and you can see the simulated MGO propagation becomes much, much stronger than the control run and more similar to the observations. So this simulation tells us topography probably does not play a big role, but the existence of land does. And this is another simulation showing you the possible effect of the diurnal cycle. So again, this is for one MGO event in observations. This is the rain, and it's starting from the Indian Ocean propagated eastward. So horizontal is the longitude, vertical is the time. So you can see this eastward propagation of this MGO event. In this particular control run, the MGO event is much, much weaker than observations. And then what did here, the next one is to artificially remove the diurnal cycle of rainfall from the simulation. Everything else is the same, and you can see the propagation signal is much stronger than in the control run. So this set of simulation suggests that the diurnal cycle over land might be a barrier effect for the MGO. But why? Let's take a look of this. This is a emanation of the observed convective cloud cluster from satellite. Each dot represents a single cloud cluster. The circle size represents the size of the cloud cluster. The upper panel represents the period of MGO suppressed cases, phases, and the lower panel represent the MGO active phases. And you can see there is strong diurnal cycle over land, right? And this represent the on the upper right represent the local time, and you can see during the noontime there is very strong afternoon, very strong convection over land, and then during the night the convection propagate into the ocean. But what most interesting difference, if you compare these two, the suppressed phase and active phase, is that over water, the convection is much stronger and larger during the active phase than during the suppressed phase. So the MGO signal propagating through the maritime continent mostly are over water, and that's why Ayres interaction might play an important role here. Okay, so another next issue I want to discuss with you is related to land sea breezes. I'm sorry about this. This is a more complicated issue than the diurnal cycle in rainfall because of the background mean wind direction relative to the orientation of the coastline. These slides show some examples at selected surface stations. In each panel, the red curve is surface temperature, The green curve is wind speed with wind vectors attached to it. The convention is that upward pointing vectors are winds from the south. The lower middle panel is from a station near the northern coast of Java. Here you have a typical textbook style land breeze at night from south over the land north over to the ocean, and a sea breeze from the north over the ocean southward to the land during the day. The sea breeze is much stronger than the land breeze. A switch from land to sea breezes occurs at about the same time as surface temperature starts to increase, as shown by the red curve. These typical land sea breezes can be found at many locations. For example, at the west coast of Sumatra, showing in the panel to the left at the bottom. In the right panel at the bottom, you have a case in which the land to sea breeze switch is delayed in comparison to the Dyno cycle in surface temperature. You can also find some wacky situations where there's no obvious peak in land sea breezes, showing in the upper right panel, or land breezes persist almost until surface temperature reaches its Dyno maximum, as shown in the upper left panel. We're still in the process to sort out these different patterns of land sea breezes. The last result I want to discuss with you is how the Dyno cycle in different variables may be related to each other. The top figure on this slide is a composite of the Dyno cycle repeating once in surface temperature in red, rainfall in green, and dew point in blue. The shades marks their one standard deviations. In this composite, the Dyno minimum in rain lags that in temperature by 2 hours, but their Dyno maxima are about at the same time. It is interesting to see a dip in surface humidity at the time of the Dyno minimum of temperature. Otherwise, there is no obvious Dyno fluctuation in humidity. Please notice that the Dyno cycle in surface temperature is non-sinusoidal, as I mentioned before. Composites of land sea breezes have to be made with care because of the orientation of different coastlines. The figure at the bottoms are composites of temperature, rainfall, humidity, and the wind vectors at the stations on from the left to right, north, east, south, and the west coasts. Without going into the details, you can see the relative timing of the Dyno cycle in these variables can be very different depending on which side of the island you are. We need to dig into this and see how we can make the best sense out of this data. So in summary, I would say in the current study of the MJO, the barrier effect is a major issue that we have to address, because it is related to how MJO may influence globally. The second one is I want to emphasize that the numerical models does not handle the barrier effect very well. It exaggerated the barrier effect. I spent some time talking about the Dyno cycle over the area. And the current thinking is if the land Dyno cycle is very strong, it may interfere or compete with the convection over ocean. And convection over ocean carry the major signal of the MJO propagating over the maritime continent. The last thing I want to mention is the BMKG observations from many coastal stations provide very valuable information to address the Dyno cycle in the maritime continent and its potential impact on the barrier effect. That's all I have. Thank you very much.
All right, thank you, Shilong. That was a great talk. Reminder to everyone to go ahead and put any questions you might have into the chat. And while we're waiting for questions, I had a quick one. I should know this, but do the models have a known bias for over amplifying the diurnal cycle over the maritime continent? I would think that would be consistent if they do, that would be consistent with what you're finding, that if the diurnal cycle in the model is too strong, maybe that's why the barrier is too strong as well.
Well, it's not only the amplitude, the timing is also wrong. Yeah.
Let's see. Also have a question from Mike McFadden. Nice talk. It looked like some of the RMM plots you showed that the MJOB cases were weaker upstream of the maritime continent. Are MJOB events generally weaker, and could preconditioning in terms of intensity over the Indian Ocean be a factor?
Yeah, good question, Mike. This is something that a little bit controversial. Depends on how you measure the MGO strength. If you use the RMM to measure MGO strength, that's indeed the case. But you use precipitation to measure the MGO strength, then the difference is not statistically significant. So the current thinking is, because RMM index heavily weighted on circulation, the wind, so maybe it is not the precipitation, it's the circulation pattern that set up the MGO or distinguish the MGOB and the MGOC. But we don't have the convincing evidence at this moment yet.
And that would kind of go along with the other question I was going to ask, of like maybe the difference between these events are exactly like how the wind directions within these within the events align with the land sea breezes. That, you know, if you have one event that is more constructively interfering with that diurnal cycle versus one that doesn't, that could be a role.
Yes.
Question from Donaldi from BMKG. Do you think the MJO influenced the diurnal cycle or the other way around in the MC?
Yeah, so there have been many studies on the MGO influence on diurnal cycle. So how diurnal cycle change when MGO propagated through. But the reverse, the how potentially the diurnal cycle may influence the MGO, that has been an issue that just started to be addressed. So I think in terms of the interaction between diurnal cycle and the MJO, probably more emphasis should be on the second, the potential influence of the diurnal cycle to the MJO.
Well, thank you again, Chidong. Don't see any other questions at the moment. So I guess we can move along to our third speaker. And
can you tell me how to stop the sharing?
There should be a, oh, there we go. Okay. And okay.
Already stopped. But you don't, it's already stopped. So please continue again, Dr. Schreck.
Okay, excellent. So we'll move on to our third speaker, AJ Rice, who's the director of the NOAA's Ocean Prediction Center, previously a meteorology and oceanography officer at the U.S. Naval Oceanographic Office. And today he'll be talking about NOAA's Ocean Prediction Center, current activities and future plans. AJ, are you able to share your screen?
Thanks, Carl. Can you hear me okay first?
Yes, definitely.
Okay, great. Yeah, I think the team there is going to be sharing my slides, and I'll wait for them to come up. But as they, oh, well, there they are. I just wanted to say thanks. And this is the most fun I've had at work at 10 o'clock at night in a while. So it is really really fun. My day started actually with a little bit of a meeting with the European Center, so that was early, and then I get to finish the day on the other side of the world. So it's amazing what we can do today. And so certainly, though, I'm looking forward to hopefully being present someday and meeting all of you. I'll probably say that again. Okay, so since you can hear me well, I'll just kind of kick off and say greetings, colleagues, partners, and friends. I enjoyed the video on the first day. And instead of saying BMKG, I'll try BMKG. I think I heard it pronounced. And so I'm really happy to be here. I am AJ Rice, and I'm the director of NOAA's Ocean Prediction Center, or OPC. I'll be referring to it throughout this presentation. And just a little quick note on where we're at. OPC is, it falls in the NOAA line office of the National Weather Service. You've heard some other of our colleagues here from National Weather Service speaking. OPC is one of 9 national centers, and many of you, I'm sure, are familiar with all these, but I wanted to just point out, for example, sister centers would be the Climate Prediction Center or the United States National Hurricane Center. So OPC is a sister agency to them, along with 6 others. So under the National Weather Service, the Ocean Prediction Center, I think is best described as a marine weather prediction center for parameters like marine winds, waves, sea ice, and sea fog, even for some reaches of our areas of responsibility. Freezing spray would be another marine hazard. Basically any kind of extreme marine hazard. If you'll go ahead and go to my next slide, it's the outline. And I was asked to talk to you about really the bottom 2 items, that is current activities at Ocean Prediction Center, and also future plans, and including some initiatives and perhaps opportunities that we can discuss together. But first, I wanted to set some context. So slide 3, please. In June of 2021, yep, just this year, a comprehensive assessment, and technically the second one, of the United States marine economy was released, and looking back at the year 2019. So this is just before the pandemic. The data showed a total marine economy that grew faster than the US economy as a whole, and contributed nearly $397 billion to the nation's GDP. It supported over 2.4 million jobs collectively. Our acting NOAA administrator at the time said these statistics show how powerful the blue economy is as a driver of jobs and innovation and economic growth. So today, that little chart on the left, hard to see, just a big yellow arrow going up to the right, but it reflects that the global marine economy is valued at approximately $2 trillion annually, and it's projected to grow to $3 trillion by 2030. And I alluded to the pandemic. These numbers were before pandemic, but there's no signs that it not only is surviving during the pandemic, but thriving. In the case of the United States, there's a new phenomenon called cargo surge. It's still occurring in many US ports. In fact, our largest West Coast port, the complex of Los Angeles, Long Beach, California, surpassed Hong Kong as the world's 9th largest container port, just based on port volumes in the first half of this year. So it's no surprise to maritime nations like ours, Indonesia and the United States, when the IMO says that water remains the leading transportation mode for international freight. So in the US, waterborne vessels move 42% of the value and 71% of the weight of our international trade. So the bottom line of all this context is it's a busy ocean, busy ports, and it's only getting busier. And therefore, we have to stay busy to try to understand our marine environment better and predict it at better time scales and longer lead times. Extreme maritime weather, too, is changing with the changing climate, and it remains a threat to the global marine economy's viability. So if you go to slide 4. So I'm going to cover current activities and basically start out by saying this is why national meteorological services like the Ocean Prediction Center exist. So I'll switch gears and talk about OPC. Next slide, and it's just going to lay out our mission really quickly. Basically, our mission is, as it says, to provide life and cargo saving marine forecasts and warnings and enhance the viability of the nation's marine economy through those services. So next slide. I'll tell you a little bit about our mission area. It basically conforms to the WMO's meteorological service areas, or MET areas for short. I know you're familiar with those. Basically OPC, and there's more details in this, but with some of our own internal partners, we're responsible for MET areas 12 and 4, and you can see those depicted on the left and right-hand side of the graphic. Next slide, please. So in the grand scheme of things, at least in my opinion, MET areas 12 and 4 are rough neighborhoods when it comes to extreme marine weather. In fact, OPC issues over 12,000 hazardous marine weather warnings each year. It doesn't average out to 33 warnings a day. Of course, Northern Hemisphere winter is our busiest season, but roughly it's 33 warnings a day throughout the whole year. Those are for things like gales, storms, and hurricane force wind events, as well as those other hazards that I mentioned. So in regards to hurricane force wind events, a graphic on the left, both showing geographic coverage as well as the vertical bars showing numbers. Hard to see, but I'll spell it out. Basically, OPC warns on approximately 40 or more hurricane force wind events each year in each of our ocean basins. So that's Pacific as well as the Atlantic. For comparison, a typical year of tropical cyclone activity in the Atlantic, covered by our National Hurricane Center, they'll see 13 to 20 named storms, and of which 6 to 10 could become hurricane force. Sustained winds of 74 miles an hour, 119 kilometers an hour. So that's not to minimize or disparage the important and critical mission of the National Hurricane Center, but it's just to highlight that there's another beast out there over the horizon, and that's extratropical hurricane force activity. So the other point on the far right, and this is really rough sketch on my part, but it's just to show that when you do get hurricane force wind event over the ocean, previous slide, please, I'm sorry. Previous slide, please. It's not critical, but the point I wanted to make is that the hurricane force wind events are much more expansive geographically. Thousands of square kilometers of ocean can be impacted by hurricane force wind events. And so that's why we have to be on top of our game. Now, next slide, please. Thank you very much. So I'll try to be fairly quick on this one. It's kind of the block and tackling basics of weather prediction, but in the upper left, I'll start there and move clockwise to the lower right. So I like to say it's safe to say that it all starts and even sometimes ends with observations, and then some more observations, and then if you can, even more observations of the ocean and the marine environment. So observations, of course, are needed to drive the numerical weather prediction, weather, ocean, wave prediction models like our own and the National Weather Service, as well as your own, as well as near and dear to your hearts, the Ocean Forecast System. But they're also very important for surface observations to be able to present them to the forecaster on their forecaster toolkit, so on their glass. So they're often used to adjust warning timing or warning area coverage, even as they look at the guidance. There's kind of like acting like their virtual porthole. Since they're not at sea on the vessels, it's their virtual porthole to see how the conditions are in the area in which they're actually providing marine services. So that's a big, big ocean, as you well know, and there are always data gaps. You know, as you can see coming around the circle, plenty of observations, satellite observations included, traditional, I call them traditional marine observations. You heard my colleague Tom Cuff, who was also on the line tonight, speak, I believe it was yesterday or the day before, about the National Weather Service observations portfolio. All of those are very important, but it's a big ocean and there's always room for more air-sea interaction observations. And I'll speak about some of those in our future plans and discussion. Okay, next slide. Despite the complexity of the science that goes into making a marine weather prediction, the actual products are fairly simple. Here you can see depicted text bulletins on the left-hand side and marine weather charts on the right-hand side. So on any given day, there are about, this is my rough estimate looking at AIS data, 200,000 vessels at sea on the world's oceans, not just in met areas 12 and 4, but on the world's oceans. But for many of those vessels, and I think you are well aware of this, especially those far offshore or even not very far offshore, but not very sophisticated, text bulletins and weather facsimile charts might be the only marine services they'll receive if they're fortunate, right? So they're out of cell phone range and they're not going to be paying for expensive satellite communications or services. So these particular products come over the airways, medium frequency and high frequency. So except for the improved model guidance and skill that goes into making these products and some incremental improvements in communication methods over the previous decades, their format hasn't changed for several decades. So even so, it still meets the internationally agreed upon requirements of the Global Maritime Distress and Safety System, GMDSS. Also meets the requirements of the Safety of Life at Sea or SOLAS Convention and Treaty. But while it meets the minimum requirement, it may not always meet the actual need of the mariner, more advanced needs. So I'll speak to that as well too when I talk about future plans. Just one short slide there. Okay, next slide, please. I also wanted to point out that our services include gridded data sets. These are, you can see the area depicted there. We're working on filling in the voids over time. But these are grids that are approved for release by a professional marine forecaster, not just straight computer model, coordinated grids with other marine forecast service centers, including our colleagues in Alaska and Hawaii, as well as Miami. So what's nice about the National Digital Forecast Database is what we call it. What's very effective about that is that's useful for other users to pull in the data and then make their own applications of that particular official forecast gridded information. It also helps us to automate some processes. So from these grids, we can automate some of those text bulletins. We can also automate some chart production as well. Okay, next slide, please. I think this is the one where the proverbial rubber meets the road. Does any of that matter? All what I've spoken of so far, and how do we even know, right? So lately, we've been employing the use of Automatic Identification System, or AIS, vessel track data to see if our customer, the mariner, is receiving, and then if they are receiving, are they acting upon our warnings? In particular, when it comes to the case of AIS data, we can at least see behavior, and again, we don't get to communicate with them, but we can at least see behavior that's anomalous, something unusual for a vessel to do that's trying to make it quickly across a transoceanic route. So I've just chosen one recent example. Many examples I can choose from, but it's a recent one. It clearly communicates the positive impact. Very hard to see the AIS track data on here, so please forgive me for that, but I'll talk through this slide carefully. What you see depicted is the large cloud pattern there, Hurricane Larry, just from September earlier this month. It was a major Category 3 hurricane at the time. This particular satellite image and AIS data is from September 8th of 2021. And it's moving northwest through the North Atlantic along off the eastern shore of the United States, recurving out at sea. The particular trajectory, though, even though it's over the horizon from the continental United States, it actually intersects all three major shipping lanes from Europe and the Mediterranean to the major ports on the East Coast of the United States. So this is potentially a big and dangerous interruption to the nation's marine commerce. So again, I apologize, it's difficult to see the AIS tracks on this presentation, but if you can, you'll see that there are no vessels within about 450 nautical miles in the vicinity of Larry's position and along the near-term track. That's the red polygon, if you can make that out. There's no AIS track data within there. That's an area that would normally be filled with numerous vessels on the transatlantic sea routes. That's far enough offshore that that's not, there's no access to cell phone coverage or the free Wi-Fi of the ocean, which doesn't exist, right? So only vessels that are receiving products either by satellite or the over radio signal are able to get products at that point. So the fact that it's void area is the first indication that vessels are receiving our warnings and staying out of harm's way of the most dangerous area. But even more encouraging to us, and farther off to the right of Larry, you'll see three red letters, A, B, and C. And each one of these letters corresponds to a significant course change that we identified in an AIS data of a vessel's track. So in other words, it's a significant change that doesn't really make sense other than in the context of a hazardous weather avoidance. So you can see there's a strong indication here that these vessels are receiving our warnings and taking avoidance action well in advance of the storm. For vessel A and C, it was 3 days in advance that you see the bend in their track. So they took evasive action 3 days in advance. For vessel B, it was a remarkable 5 days in advance. What this indicates to us is that all that hard work, when we press send on our product and it goes out over the airwaves and over the oceans, that vessels are receiving them, masters are evaluating them based upon their intended plan of track, and they're taking evasive action to avoid any loss of life or cargo on the high seas. Very encouraging to us. So next slide. However, it's not all good news, even still. So I call it the yet slide. So yet there's still significant marine accidents at sea. Here are 3 recent examples of where vessels either did not receive the warnings or they didn't know how to respond properly to them. The first example on the left-hand side is from February 2016. A cruise liner, Anthem of the Seas, was carrying nearly 5,000 passengers and crew aboard, was caught in hurricane force. Again, it's not a hurricane, but hurricane force, a storm in the vicinity of the Gulf Stream, our western boundary current off the east coast of the United States. So the heaving and rolling was so bad on this cruise ship that their screws actually came out of the water, accelerated, and burned up clutches. And when the clutches burned up, they shut down the propulsion. The vessel ended up beamed to the seas. And if any of you are mariners or have an appreciation for life on the ocean, I can't imagine this audience doesn't. Beamed to the seas and heavy seas is not a good place to be. So that picture just doesn't do it. But on the lower left side, that's the picture out of a first deck porthole. That's a customer's cabin window. And if you could play the animation, which is not available in these PDF slides, but the waves are actually slapping up against the window at times. So buoy nearby, actually about 480 kilometers away, buoy had 30 feet or just over 9 meters. And the winds were even stronger at the location of the ship. We don't know if the ship's anemometer was calibrated, but it registered about 106 knots of wind before it broke. That's equivalent to 122 miles per hour, 196 kilometers an hour. That's being caught in very dangerous conditions. So the next one I'll draw your attention to is on the lower right side. I'll go quickly through the next 2. This was September 2020, just last year, a cargo vessel, Gulf Livestock 1, carrying 43 crew and 5,800 head of cattle, capsized in the East China Sea. It was in the vicinity of a powerful typhoon, Maysak. The sole surviving crew member basically said the vessel was caught in high waves and it tilted so far that the vessel actually, the engine stopped. Of course, that means beams to the seas. And if the vessel loading can't support high rolls, it's going to flip. And so that's what happened. Only one survivor, sadly. And then on the upper right, recently, just December of 2020, and maybe you've heard about this one, it set a world record in the bad kind of way. The ultra large container vessel MV1 Apis, it carries over 14,000 TEUs. Those are 20-foot equivalent units. That's a standard shipping container. They were coming from Asian to American markets, and they encountered actually minimum gale force winds, barely in gale force winds, but they were in an area of significant, large and long period swell driven by a hurricane force low pressure system well off to their north. So we don't know what caused all those containers to break free. And unofficial, the accident investigation is ongoing. And so makes no sense to comment on it. But a hypothesis we are waiting to see is if it wasn't high seas interacting with the vessel's characteristics that caused excessive rolling and maybe strain the cargo lashings and cause that kind of loss at sea. Well, the bottom line is we can't rest on our laurels just because we have some vessels, even most vessels, avoiding the most hazardous weather. So we have work to do. So that brings me, go ahead, next slide real quick. It's back to the outline. Get a fix on where we're at here. And we're just going to round the bend here and finish up with future plans, initiatives, and opportunities. So there's many things across NOAA that I could highlight. I'm sure, and I know many of them have been highlighted here in this engagement already. I'm just going to focus on National Weather Service and Ocean Prediction Center interest area items. So please, this is a very limited viewpoint, but I'll go to the next slide. Yes, please. And again, my colleague Tom Koff spoke about the Voluntary Observing Ship Program. But I just want to say again that observations are critical to accurate marine and ocean models like ours and BMKGs, and therefore they're critical for effective marine forecast services. So the first three initiatives I'm going to address are going to be all about observations, specifically in situ observations and subsurface observations. So again, advancing, I call it advancing and even automating WMO's Voluntary Observing Ship Program through the provision of onboard automated weather observing equipment to vessels. Now, our government can't provide every vessel that wants one an automated weather observing system, but there is a great, strong campaign, if you will, to engage the vessel companies, the owners, the operators, ship operators, to invest in these themselves, to do themselves a favor, because with better observations come better marine services, and better marine services leads to better life and cargo saving operations by us, which improves their own viability. So advancing WMO's voluntary observation program is one of them. You know, the at sea, taking an observation, as you see on the left-hand side, it's manually and labor-intensive process. That costs money for ships at sea, especially in this era of minimally crewed vessels, right? There's not enough time in the allotment of hours for the humans on board to spend that much time just taking a weather observation. They have probably other more important things to do. Nice thing about automating is it not only saves the companies those costs, so there's a return on their investment in automated equipment, but it also reduces errors, which is really helpful for us. So automated weather stations on board solve both these problems. And it appears, we believe, have dramatically increased and improved the quantity and the quality of observations. On the right there, well, first of all, in the middle, you see a ship operator, a vessel officer proudly displaying his automated weather station. And then on the right-hand side, you'll see that the observations in the last 2 years are growing dramatically. The blue is the total number of observations, red being the number of programs. So without a drastic increase, the number of programs out there, there's only about 25 active VOS programs globally, about 4,200 vessels or stations within them. Half of those do the bulk of the reporting. But you can see the numbers have really grown by orders of magnitude. Already there's been 3 million OBS reported in 2021. In 2020, it was 2.5 million. Previous years, it was almost half those numbers. So the VOS program is doing very well thanks to the campaign and the introduction of automated weather observing systems. Okay, please, I guess I would say that I'll end this slide by saying, 4,200 stations may seem like a lot, but that's really only about 1% of all vessels, maybe 2% of all vessels on the high seas that could be reporting weather observations. So that leads me to my next initiative. Yes, please, the next slide. And that is leveraging the automatic identification system to do what? To send weather observations. So this next initiative isn't about advancing or automating an existing observation system. It's rather about opening up the options by which weather observations can be transmitted. There's many vessels on the high seas today that don't have access to satellite communications, or will never have significant bandwidth, even if they did. But there are very few commercial vessels on the seas today that do not have an AIS transceiver. So that is actively on board and reporting their position. Many of those same vessels have some kind of automated weather apparatus on board as well. So a little known feature of AIS code is that it contains provisions for the inclusion of weather data in its standard message data format. So a schematic of the concept is depicted on the left-hand side of this chart. And weather from vessels at seas can be automatically embedded in the AI signal. And they ride the usual AI signal along with the ship's position and other information, ship to shore and via AIS base stations or GPS constellation of satellites or other navigation satellites. And both the position and the weather information are then made available to the usual AIS shore network. But from the shore network, we can pull those observations either onto the GTS and then into OPC or even straight from into OPC. So we're working with a partner at the United States Maritime Administration and some partners at the Army Corps of Engineers of all places, but their research arm is supporting a demonstration called Marine Weather via AIS. As of today, there are over a dozen vessels in the pilot program routinely transmitting their weather observations via automated systems over AIS. And so we think this is another potential opportunity to expand marine surface observations. Of course, these are from vessels, so this is about surface weather, planetary boundary layer kind of conditions. Okay, let's go to the next slide. And I wanted to say that that demonstration proves successful. It'll have a positive impact on observations. It'll go from, you know, the few thousands we received today to many thousands of observations. So this next slide kind of puts those two things together: automated systems, reporting via AIS, but throws in a new kind of interesting capability, and that is autonomous vessels. So there's wonderful autonomous vessels on the high seas today. In fact, we just saw some video that's going to probably be in the press tomorrow, taken by a sail drone, uncrewed vessel that went through the eye of Hurricane Sam that was recently in the Atlantic Ocean in the U.S. area. But one of the other ones I wanted to highlight was this particular one. And again, the next two initiatives are really about expanding marine observational data in data sparse regions, okay? Not just the usual shipping lanes where we're going to get a lot of observations, you know, from ships transiting those lanes most of the time. But now I'm trying to reach into data sparse regions, areas where there's not a lot of reporting, despite some robust national federal systems out there. So this first one, onboard automated weather observing systems and AIS working together. What you see depicted here, those are working together in the Mayflower Autonomous Ship, or MAS for short. That's a joint venture between IBM, International Business Machines, and a nonprofit maritime technology outfit from the UK named Promar. So without captain or crew on board, the Mayflower uses IBM's artificial intelligence captain, they call it AI Captain, and other autonomous technologies to navigate the ship safely in numerous challenging environments on the high seas, and the point being, including data sparse areas, and persistently in data sparse areas, being able to recharge and store energy on board to operate automated systems and communication systems and propulsion. So Mayflower itself will carry many more sensors, but the marine surface observational data being evaluated for persistent real-time data collection, sea level pressure, air and water temperature, wind speed, and direction. And again here, the novelty is automated systems reporting from an autonomous vessel via AIS directly to the global telecommunication system. This demonstration is about to get underway. We've been working the technical aspects with IBM and Promar, and it's Mayflower set to sail again in the spring of 2022 from Plymouth, England. And at least interesting from the United States historical perspective, it's going to sail from Plymouth, England, eventually make its way to Plymouth, Massachusetts, and that's going to retrace the original Mayflower's route in 1620, the year 1620, which was retracing one of the first successful immigrations from settlers from Europe to North America. Okay, enough on that one. Let's move to the next one.
So, just heads up, I think we just have a few more minutes.
You bet. I'm on pretty much the last one. I'll go quick on these. So to add to the strong arsenal of ocean observations I mentioned earlier, for example, global programs like Global Ocean Monitoring and Observing, GOMO program, and my colleague Tom Cuff's Marine Observation Program, OPC is working to ensure that non-traditional sensor data, namely from the growing number of commercial ocean observing systems that are being deployed, and all of us, I think, hope will continue to be deployed in the future. The term has been coined an ocean of things era. We're working to make sure that data is made as available as free and in an unrestricted manner as possible to national met centers like ours. That's not easy. There's some legal challenges and complications, but we want to engage there at least early and often to see if we can't make the case, the business case, for people to share that observation with the national met centers. What you see depicted here on the left-hand side are those global well-established programs that are doing a great job. On the right is just an example of some SOFAR spotter drifting buoys, and the upper right shows where they're currently deployed throughout the world's oceans, kind of getting to that ocean of things. Okay, next slide, and pretty much the last one. This last one, but last and not least, I'd say is a non-observational related initiative. This one is an effort working through international governing bodies, namely the International Hydrographic Organization, to depict marine weather warnings, data, and overlays in the International S100 data standard. Bottom line message here, we want to get them, instead of in the back room, in the radio room, printing or going slowly across screens on the left there, you can see we want them to appear on the vessel operator's electronic navigation system, which is what they're looking at often as they're looking out the bridge windows. So if we can get weather lays, observational overlays, and some gridded information onto the electronic navigation systems, we think we're really going to transform the way vessels receive, understand, and act on marine hazardous weather warning information. Last slide, next one, and this one's my favorite one. It's just a thank you. So it's been a delight to present to you tonight. Again, it's the most fun I've had in the evening at work. You're always welcome when things allow to visit the Ocean Prediction Center in College Park, Maryland. Be interested in talking about partnerships in that regard. But I do very much hope to see you in Indonesia someday. I was going to say, and I'll say this quickly, I'm probably not the only one on this call from NOAA partners, but I did actually visit Surabaya, East Java once and rode horseback up a beautiful volcanic mountain and overlooked a caldera. And some other time when we're together, I'll tell you the story about the group of horses charged the edge, and thankfully we were rescued by our handlers at the last minute. Long story for another time. Thank you very much. It's been my pleasure. Terima kasih. I'll take any questions you have.
Excellent. Very interesting talk. I just happened to be reading one of the recent issues of the Bulletin of the AMS today and saw some of the, there was an article about the container ships in rough seas losing some of the containers. So it was very timely to see your talk too.
Thanks, Carl. Appreciate that.
Hey, Carl, this is Sid. Could I ask AJ a really quick question or provide a comment?
Yeah.
AJ, that was just awesome presentation. Thank you so much.
My pleasure.
Just a couple, you cast it as looking for opportunities. So I'll put my 2 cents in. Earlier this week, there was some discussion about increasing the volunteer observing ships program across the maritime continent. So that might be something, there may be some common ground there, AJ, with BMKG. The second area that I'm seeing is the ocean forecast system. BMKG has been bringing that up for probably 3 to 5 years now. And it seems like there might be some common ground between OPC and BMKG. Thanks again for an awesome talk, AJ.
Yeah, thank you, Sid. And that first point, Tom Cuff, who presented earlier in our engagement and partnership, he under his purview is the US's VOS program. So as OPC, of course, I'm a huge fan of it, and I try to be a salesman and push it as far as we can go. But yes, we are certainly, that's a win-win for both of us. And to your second point, yes, I think we're all realizing that to get the air-sea interaction, the ocean observed and predicted is going to help an awful lot of Earth systems prediction, the kind of predictions we need to do, not only to get the extreme maritime weather correct, but just to start getting climate weather predicted.
We do have one question from someone from BMKG. Do you have any best practice to implement impact-based forecast for marine weather?
Yes, I that makes me regret I didn't include one more slide. I knew I'd be pushing the time limit. But one thing that, so I'll take for action to share a specific example. What the Weather Service in general is finding, it's an impact decision support services, it's the social science, it's the social, it's the behavior, it's communication. And so, the Mariner is an interesting audience. It has a long-standing traditional way of viewing weather information. And so you really have to, the best practice is to not just broadcast without talking to your customers and understanding exactly what they're going to react to and understand. I used to have, when I was in the Navy, I used to have a boss who would be furious if you just told them the weather. What they wanted to know is, what are they supposed to do about it? They didn't want to see weather charts. They wanted to see where the assets should be placed and where they're supposed to operate so that they can be least impacted by the weather. So sorry, that's a vague and broad answer, but I'd love to share with you an example of how we present our information. One of our main customers is the US Coast Guard when it comes to IDSS. So we'll share a product with that. I'll get that through to Sid or whoever I'm supposed to.
And one last quick question from Mike McFadden that's near to me being here in Nashville. Looks like Tom Cup already addressed it, of data quality being so important, not just for forecasting, but for climate studies. We really need the highest quality data that we can possibly get.
That's true. So the Ocean of Things will present a challenge to all of us, won't it? Because we're gonna want to study the data, and there's going to be a lot of data, a lot of different data types, et cetera. So yeah, it's that'll be a challenge. But people are studying it, so there's we're hoping for peer reviewed, et cetera, et cetera. But yeah, that'll be a challenge. It'll be a challenge. We're gonna have to pick, the ones that have proved to be robust sensors out there, ones that have demonstrated, good calibration, good contribution, skill to the models, and then leverage those. The point is not to just have one national center leverage them. The point is to share it out there amongst all the national Met centers.
All right. Thanks again, AJ, and thank you to all three of our speakers. I think this was a great first session for the evening or the morning. And thank you again.
And thank you again. Thanks, Carl. Well done.
Yessie, are you going to walk us into the break?
Yes.
Okay.
Thank you, Pastor Nick. And thank you, Dr. Shrek, for leading such an informative session. And I would also like to thank our amazing speakers for sharing their excellent research with us today. And before we continue to the next agenda, we're going to have a virtual photo session first. So I would like to invite all of you to, again, turn on your video and show us your beautiful smile. Okay. Please be prepared for slide 1. Okay. Okay, let's start. Slide 1. 1, 2, 3. First, 2, 1, 2, 3. For the last slide. 1, 2, 3. Okay, thank you very much, everyone. Now we are going to have a 5-minute break before the next session. So see you again in 5 minutes. Welcome back, everyone. Now we are going to continue to the seventh session of the workshop, which is a practical session in monitoring equatorial atmospheric waves. The session will be chaired by Dr. Albert Nahas. Dr. Albert Nahas is one of the distinguished researchers in BMKG, and he also serves as the head of subdivision of Greenhouse Gases Information, BMKG. Now I would like to pass the microphone to Pa Albert to continue to the next session. Pa Albert, the floor is yours.
Thank you, Yesi. All right. Selamat pagi, very good morning, good afternoon, and good evening to all participants of the 16th Annual Indonesia-US BMKG-NOAA Partnership Workshop. We are in the session 7, hands-on training practical sessions on monitoring equatorial atmospheric waves. I will be the moderators of these sessions, and in these sessions we have 2 speakers. If the committee can kindly share the slides, yes, thank you. So in the sessions, we have a double talks by Dr. Carl Schreck, and the second speaker will be Mr. Ferdi Gustian Utama. We will start the sessions with the presentations from Dr. Carl Schreck. Carl is a research scholar at NCICS. He is also affiliated with the North Carolina State University. He completed his PhD in atmospheric science at University at Albany in 2010. And right now he is a postdoctoral fellow at North Carolina Institute for Climate Studies, and also adjunct assistant professor at the MES department of NC State. Carl, you have a double duty to present your talks. We're going to start off with the first talk on predicting the MJO equatorial waves and extreme rainfall. With that, I will hand over the next presentations to Carl. Go ahead, Carl.
All right, thank you, and I think I should be able to share my screen, hopefully. Are you able to see that okay?
Yes.
Okay, excellent. So the first of my 2 talks, I'll be talking about kind of an overview predicting the MJO equatorial waves and extreme rainfall. This kind of follows on to some of the discussions we had in the previous session. And so kind of the key points that I'll talk about is, probably not news to anybody, but the seasonal cycle is a strong influencer of when you get heavy rain events. And the MJO in particular primarily modulates those events during December through February. But you can also get equatorial Kelvin waves and Rossby waves that interact with the MJO and modulate the monsoon winds to change the number of those extreme events that you get. So I know we've already talked a little bit about Kelvin waves, but just as a refresher, these are these strong alternating westerlies and easterlies that move eastward pretty rapidly at 10 to 20 meters per second with a period of 3 to 10 days. And these are really fascinating waves to me because they're relatively small in spatial and temporal scale, but they're remarkably long-lived. You can actually, in some cases, track one of these Kelvin waves all the way around the globe over the course of a month or so. So it seems like there should be a strong source of predictability there, but we haven't necessarily figured out a good way to harness that predictability just yet. The other key equatorial wave are the equatorial Rossby waves, or ER waves. And these are alternating pairs of cyclones or anticyclones that straddle the equator. And you tend to get enhanced convection more so in the poleward flow in either hemisphere. And these move westward. They're much larger scale than a Kelvin wave and much slower, but kind of fit in scale-wise, they're kind of in between a Kelvin wave and the MJO, but equatorial Rossby waves go the opposite direction. And they tend to be more focused on their circulation, maybe not as convectively active as the Kelvin waves and the MJO might be. And of course, we've already talked a bit about the MJO, and I'm sure all of you are familiar with the real-time multivariate MJO index, or the RMM, that was developed by Wheeler and Hendon in 2004. But just in case you need a refresher, like, this is an index that has both amplitude and phase for the MJO. So typically the MJO will go counterclockwise around the origin, and the farther outside the circle the event is, the stronger it is. And which phase it is in tells you where you are in the MJO. Obviously, phases 4 and 5 are most relevant for you in Indonesia. And this is a really valuable tool because it's a fairly simple index that can be applied both to observations, forecasts, climate models. But because it is so simple, it also gets things that aren't just the MJO. You see sometimes where it might strongly increase in amplitude. That could be related to mid-latitude circulation sometimes. It might double back at other times in association with some of these equatorial waves interfering with it as well. And the kind of looking, I like to look under the hood at the Wheeler-Hendon index a little bit to try to understand why the index is saying what it's saying, instead of just looking at the index itself. So it's the first two EOFs, empirical orthogonal functions of a combination of outgoing long wave radiation, OLR, so cloud cover, and then U850 and U200, so zonal winds near the surface and near the tropopause. And we generally think of it as tracking the MJO's convective signal, so the OLR, the black line. But really, as Chidong mentioned, it's really driven more so by the wind circulation. And so a lot of times what you're seeing is this zonal wave number 1 pattern in the global winds around the equator, where you're having westerlies for for one hemisphere and easterlies for the other hemisphere, with opposites between the surface and the upper levels. And so that's really what tends to drive the Wheeler-Hendon index. And so understanding why it's behaving the way it is can help you interpret how a particular event is going to evolve. And so this is kind of a pseudo composite that I put together to help me understand what the MJO is doing. So this is not a true composite. These are Hoffmullers, or sort of like a Hoffmuller of OLR, U850, and U200 on the right. And instead of it being time, it's the 8 phases of the MJO. And basically what I did was I took this EOF pattern and just gradually rotated it around the circle to make this composite. And so you can see during, for example, during phase 3, you have really strong convection around 90 east over the Indian Ocean. And that shows up, as this strong peak in EOF2, for example. And so how that shifts around helps to understand what's going on with the MJO index. And so the OLR component, the cloud cover component, it's really pretty much just the Indian Ocean and the West Pacific. There is not a whole lot of signal that it derives from the maritime continent. Where the zonal wind signal is more continuous, especially across the maritime continent. You get more of the signal there at the lower levels, maybe not as much at the upper levels. So it's kind of useful to see, I'll compare this with real-time Hoffmullers of U850 and U200 to try to see where are the observed westerlies and easterlies and how are those projecting onto these typical patterns that we see with the MJO itself. So shifting gears a little bit, this is research that I've just recently had accepted into geophysical research letters, where I've been trying to look at extreme rainfall events as they are modulated by the MJO. And so in this case, I'm talking about extreme rainfall as a 2-year rainfall event. And this is calculated using the NASA iMerge data set. And so that's data that goes back to 1998, daily data, daily 1/10 degree, I believe. And so what I do is I look at the 2-year intensity. So for each of the years since 1998, I calculate the annual maximum at each grid point, and then find the median of those annual maxima. So, for 1998 to present, there's a little more than 20 annual maxima. So the median of those is the 2-year rainfall event. So this is a type of event that you would expect to happen every other year or so. So it's much more rare than like a 95th percentile event. But it's maybe more common and more understandable than say a 100-year event. So for most of your region, it's somewhere on the order of 100 millimeters per day. But of course, that's calculated for the entire year. The frequency of these events does vary pretty strongly in some regions with the time of year. So this is the number of events per 100 days for each season. And one thing to kind of note right off the bat is during the summer, or during June, July, and August, there are regions where these events don't happen at all during that season. So you see the areas of brown there where it just never gets to those 2-year rainfall events, that all the 2-year rainfall events happen during the other seasons. And they're particularly common during December through February, which probably is not surprising that that's when the monsoonal rains are probably the strongest. And then in kind of March, April, May, and September through November, they're somewhere in between. So then what I do is I look at how these events are modulated by the MJO. So I look at different phases of the Wheeler-Hendon RMM index to see how frequent are these events relative to what you would see climatologically. So I'm going to be showing a few of these maps. So I'll walk you through a little bit what you're seeing first. So the shading here is, again, the relative number of these 2-year rainfall events, these extreme rainfall events. And so anywhere that it's brown, there are 0 events during that particular phase. If it's white, it's not significantly different from climatology. So it's within the normal number of events for December, January, February. And then if it's green, depending on the shade of green, is how much it's being enhanced by the MJO. And then the contours I'm showing are velocity potential at 200 millibars, which is one of the preferred ways of tracking the MJO's convective envelope. So one of the really interesting things here is, right off the bat in phases 2, 3 in the upper left, the phases 2, 3 are typically associated with the MJO being over the Indian Ocean. And you can see the darkest green contours are, generally to the west of Indonesia. But this is actually the phase where you get the strongest enhancement of extreme of these 2-year rainfall events. And I would say particularly on the western sides of the islands, particularly Sumatra and Borneo and the Malay Peninsula. And then when in phases 4 and 5, when the MJO's convective center is really right on top of you, you don't actually see as many of the extreme events, and probably even fewer as the MJO moves eastward into the Western Pacific, and relatively few during phases 8 and 1 when it's over on the Western Hemisphere. So this was a really interesting finding to me, that the extreme events are generally out ahead of the MJO's convective envelope. And I think that's probably related to the the enhancement of the monsoon flow by the low level circulation out ahead of the MJO. Similar maps for March, April, and May. The pattern is generally similar if I go back and forth, but a lot weaker, especially the enhancement in phase 2, 3 is weaker during March, April, and May, even though the MJO can be quite strong during that time of year. The modulation of the extreme events is generally a little bit weaker for a lot of regions. And then if we move to June, July, and August, again, this was a period where the 2-year rainfall events were generally less common. And again, we're seeing generally similar pattern where they're probably most prevalent during phases 2 and 3, especially on the western sides of islands. But these are rare events in very high resolution data, so the patterns are pretty disorganized. Did see an interesting enhancement over southern Sumatra during phases 6 and 7. And then if we move on to September, October, November, it's back to more the same pattern that we saw in December, January, February, but again, weaker. So shifting gears, I know Dr. Lubis talked a lot about equatorial waves already, so I didn't want to replicate too much of what he was going to talk about, but certainly some very interesting studies in recent years about equatorial waves and their effect on extreme rainfall events over Indonesia. So I was not a part of this particular study by Bernovsky at all in 2020, but this is just a really fascinating study to me, where they used a variety of social media, Twitter, and newspaper reports to look at, to identify floods over Sumatra, and then examine the relative drivers of those events, and really drove home the importance of Kelvin waves for these events, even more so than the MJO. So this is a Hoffmuller of a particular event. I think it was the maybe 2019 flood. And so time is going up in these diagrams, longitude on the x-axis, and the bars are the flooding events identified through different media. And so if you look at rainfall, you can see these rapidly eastward moving signals associated with the Kelvin waves that seem to line up with some of these flooding events, especially when you look at kind of the 5-day, if you average the precipitation out over 5 days, you see that the effects a little more clearly. But I really want to draw your attention to the diagram on the right, the zonal wind, where you really see these strong variations in the low-level winds associated with these Kelvin waves. And obviously that's probably a driving factor of some of these flooding events when you have enhanced westerlies impinging upon some of the higher higher mountain terrain. And so this was the Dr. Lubis showed this plot already, but this was kind of a schematic that came out of the Baranovsky paper, where looking at the flooding events on Sumatra, seasonal cycle was, a major driver, as I mentioned earlier. If it's a relatively dry time of year, it's going to be a lot harder to get an extreme rainfall event. But even larger than that was the impact of Kelvin waves, and the MJO was a relatively smaller subset of that, and the MJO wasn't really responsible for any extreme rainfall or flooding events by itself. It was always in conjunction with enhanced seasonal cycle with the monsoon, and or enhancement with Kelvin waves. So this is something I'm really interested in looking more into, is kind of repeating the work that I've done with the MJO, but applying it to Kelvin waves as well. And really interested if any of you are interested in collaborating on that type of research. I'd be very keen to do that. And then there was another recent study by Latos looking at interactions between different waves. And again, Dr. Lubis touched on this a little bit as well, that you can get really complex interactions between different waves. So these are kind of schematic weather maps from a strong 2019 flood over Sulawesi. The seas on these maps are the convergent areas of the Kelvin waves. So you can see in this phase, you can see the westerlies enhanced over the Eastern Indian Ocean, and then kind of weaker with the easterly anomalies from the Kelvin wave over Indonesia. So they're converging here over the seas. Then you also have there was also an equatorial Rossby wave that again was producing these twin cyclonic circulations that were gradually moving westward with time. You see the Kelvin wave was moving eastward. And then as the Kelvin wave westerlies impinged upon Sumatra, you get the Sumatra vortices spinning up as well. And so all of these features are interacting to kind of dictate the wind flow through in and around the islands. And in this particular study, they found that the interaction of the equatorial Rossby wave and the Kelvin wave, when they lined up with one another, enhancing each other's winds, produced this pretty strong low-level jet that impinged upon Sulawesi and produced this extreme rainfall event. So key points from this presentation, seasonal cycle is a big part of when you get heavy rain. The MJO primarily plays a role during December, January, February, which is also when those rainfall events are most frequent over Indonesia. And Kelvin waves and equatorial Rossby waves can have some complex interactions with each other and with the MJO and with the background monsoon that particularly play a role on changing the wind structure that leads to these events. And the Kelvin waves in particular, as I mentioned, that seems like a really ripe area for future research, both to understand how they interact with these extreme events, but also to identify ways of better predicting them. So really excited if there's chances to collaborate with some of you guys on how to examine those. So that was it for this presentation. I'll pause for any questions before we shift gears to the other one.
All right, thank you, Carl. I would like to invite the participants, if you have any questions, you can drop the questions through the chat box, or you can directly ask Carl with your questions. While we are waiting, I'm gonna ask you one. Oh, there's one actually now. What the impact? Not sure what that is.
Yeah.
Oh, what the impact is so different from west and east of the. Do you get the questions?
I'm not sure I understand.
Right, Pak Doni, if you can ask the questions in Bahasa, maybe I can help you with the. It's probably what the impact of the, if we have the MJO and Kelvin waves, what the difference between the impact, the difference between the impact between the west part of the maritime continent and eastern part of the maritime continent. I think that's what the question means.
Yeah, and that is something that was interesting to me, and I haven't studied this region as closely, obviously, certainly not as much as you guys do. But it is interesting to me how much stronger the signals are in the Western maritime continent. I think that's because you have that stronger fetch. You know, as the MJO or the Kelvin waves approach Sumatra, you know, the enhanced westerlies can pretty much go all the way across the Indian Ocean, leading into Sumatra, you know, unobstructed to that point. Where I think when it gets to the western or the eastern maritime continent, you don't have that as much. And I think the enhancement of the trade easterlies over the West Pacific isn't as strong as that enhancement of the westerlies of the Indian Ocean. But that's definitely a something that's very interesting to continue looking at.
Yeah. And to follow up that questions, and there's another questions, the impact of Indian Ocean dipole, especially probably for the western side of the maritime continent.
Yeah, that's something that I haven't looked at myself, but that's something that would definitely be very interesting to look at, to see, you know, how much difference you get with changes in the sea surface temperatures there. So that's definitely something I should go back and look at.
Do you also have a chance to look at the impact or the coupling impacts of ENSO to these events that you have studied or reviewed from these literatures?
Yeah, that's a good point too. Most of the studies that I was looking at really focused on the subseasonal scale and didn't really talk as much about the ENSO and IOD drivers. So I'm sure there would be obviously very strong effects that, you know, I'm sure you get a lot more of them during La Nina years, such as we're having right now.
All right. Do we have more questions? If we don't have any, then we can go ahead and start the second part of your presentations, or this is more like an interactive presentations, because you will show the mapping tools from the NCICS website.
Yeah.
Please go ahead.
So sounds good. So let me pull that up. Actually, so I had presentations planned, but it's probably more interesting, like you said, just to pull up the website. So let me.
You can go either way. You can show the presentation first, and then do the interactive sessions later.
Okay, so here's the presentation on what the website looks like, nkix.org/mjo. You're welcome to go ahead and take a look at that, and feel free to click around through it and look at what's available on there. And I'm going to describe a few of the things. Some of the key points. I think this website has a really unique filtering mechanism where I take a combination of what's recently happened along with CFS version 2 forecast in order to track the different waves. I talked a little bit in the previous talk about the Wheeler-Hendon RMM diagnostics, and on my website I've got some ways of looking under the hood at what's going on with the MJO index. And then in terms of skill, CFS gets a lot of its skill from just persisting the signals from ENSO and other SST factors, but we'll look a little bit more at that. So I know in the US, the website that I put together is used on a variety of different timescales and users. The National Hurricane Center uses it as part of their 5-day outlook, where the Climate Prediction Center uses it for their week 1 and 2 forecasts of where it's going to be wet or dry, or where tropical cyclone activity is going to be enhanced. And then the US Air Force is working on a weeks 3 and 4 forecast that's also using some of the tools on this website. So really, it can be used for a variety of different scales, both temporally and spatially as well. But then, so the real crux of the website is trying to identify these different wave modes. And so, the tool that I look at the most frequently are these Hoffmullers of the different variables where time is going down. And then there's this horizontal line in the middle where it says begin forecast. Below that are CFS forecasts of OLR in this case. And above the line are observations. And you can see that the filtering, the contours, go seamlessly across that. So I'm running my filter to identify the waves, both in the observations and in the future. And there's 4 main wave types that I really focus on. The low frequency, which is the magenta contours, which is more or less just kind of stationary signals. So this is a recent one from a couple days ago. And so the OLR signal is really picking up on that stationary ENSO signal where you have a dry pattern over the date line and a wet pattern near 120 east, so near you guys in Indonesia. And that's been very persistent, at least since mid-August, and possibly going back farther. But you do see, the MJO, the black contours, has tried to move things around a little bit, but without very much success. But then you also see things like this Kelvin wave that went through just a couple weeks ago. So as I mentioned, the main part of my website is using a combination of observations and CFS forecasts, but Wheeler and Weichmann back in 2001 had a similar methodology where they proposed, instead of using model forecast data, they were just using climatology to extrapolate where the wave was going to go. So they would see where has the wave been recently, and then use the filter to extrapolate into the future. So like the low frequency, it's really easy to extrapolate. If it's been in place at 120 east, it's probably going to stay there going into the future. And it tries to do that with the other wave modes as well, but those are a little bit harder to extrapolate in some cases. So that's why the real focus is on this CFS forecast, because I think you're going to get CFS isn't necessarily the greatest model in the world, but it has to be better than climatology for most applications. So presumably that's going to be a more skillful representation of what's going to be happening in the coming weeks. And I'll go through all the available things later with it. But I will go ahead and point out that, the main thing that I tend to look at is the 200 millibar velocity potential, because it's a lot smoother than what you see with OLR. So I think it's a lot easier to pick out the large scale patterns with the MJO and the Kelvin waves in particular, using the 200 millibar velocity potential, or the chi field. And then I was also mentioning in the previous talk about the importance of the low-level zonal winds. And so that's another one of the fields that I really focus in on a lot. And so, recently there's been a really strong trade surge over the Central Pacific that's been enhancing the trend back towards La Nina. And so we can see that that's got, both a low frequency component, but also the MJO and a little bit of a Kelvin wave has been contributing to it as well. Excuse me. And so the other thing, in addition to the Hoffmore, is I've got maps on there. And in response to this workshop a year ago, I've added Indonesia as one of the regions you can zoom in on and see the recent OLR data values and the upcoming forecasts, with the unfiltered anomalies in the shading, and then the filter using the contours. So in this particular example, showing that it's been, obviously looks like it's been fairly wet over a good portion of the region in recent weeks, although maybe drying out a little bit recently over the western side of Indonesia, as the dry phase of the MJO, this dashed contour, has started to move in. The CFS predicts that dry area is going to continue moving eastward, but may see some slight drying over maybe the northern part of the region, but not as much over central Indonesia. And then here's the zonal wind maps as well. Oops. And can see this enhancement of the westerlies coming in, westerly anomalies associated with that MJO event that are going to be coming in the coming weeks as it moves eastward. And as I mentioned, I tend to zoom out and look at the velocity potential. One thing that we look at a lot is trying to see whether it's a wave 1 or wave 2 signal. So for example, back in early September, there was kind of a wave 2 signal where you had velocity potential was divergent over Indonesia and South America, but convergent, so sinking motion over the Eastern Pacific, and to a lesser degree, the Western Indian Ocean. And that's transitioned to a little bit more wave number 1 right now. The black contours here are, again, the MJO signal that the model is predicting will kind of move back over the Western Hemisphere in the coming weeks. And then, you can look at different wave modes on here as well. And I'll look at more of that later when we get to the actual website. But switching to, let me skip forward. So I'm going to skip forward to the verification that I've done with some of these products, and then I'll go to the actual interactive part. So I've gone back and compared some of the products on this website with TRMM rainfall estimates from 1999 to 2010. And I've been trying to look at the Heidecke skill scores. So how well can it predict above, below, or normal precipitation? And so it's a the filter is giving you a categorical forecast and then comparing that to what is observed. And this is an example of what you might see if you had a perfect model. So this is, just from the filter, because the filter anomalies aren't going to capture all of the structure that we see in real observed rainfall anomalies. The skill is not going to be perfect, but we see that the low frequency filter obviously has pretty strong potential over the Pacific, where things are very strongly dictated by the phase of benzo, where over the maritime continent and even more so over the Indian Ocean, the MJO has a really strong potential to dictate the skill there. And equatorial Rossby waves tend to be most skillful kind of on either side of Indonesia, not so much right over Indonesia. But if we look at what happens in the actual model forecasts, the picture is not quite as good, of course. In fact, it looks like a lot of the model skill for rainfall is just coming out of this low frequency filter. So those magenta contours on the website. So the model is pretty good at persisting the current pattern, but it's not necessarily getting very much skill out of propagating the MJO or the equatorial Rossby waves. But when you add these different modes together, the skill does get a little bit better. So if you look at the low frequency plus the MJO, and then low frequency plus MJO plus the Rossby waves, the skill progressively tends to get better each time. And can generally make fairly long range forecasts out to a couple weeks in a lot of regions. Although obviously, as I'm looking at these plots, I'm realizing a lot of the skill is, of course, over the oceanic regions for Indonesia and elsewhere as well. That the skill, the impact of these modes isn't as strong over the land areas, which is obviously more societally relevant. And so we can look at the skill at, this is focusing in on the maritime continent and the contribution of the different modes to that skill as a function of lead time. And so the low frequency, the red line here has the is the weakest skill, but we're actually so the unfiltered, raw unfiltered model is actually the most skillful option. They kind of converge out around 2 or 3 weeks. If you look at the low frequency by itself, that's the least skillful. When you add the MJO, that gives you a lot of the signal that was missing. And then maybe you get a little bit of extra benefit from adding the equatorial Rossby waves. But over the Indonesian region, you're getting most of your bang for your buck out of the low frequency and adding the MJO. And then this is a plot just showing that there are different times of the year and different leads where the MJO is giving you more benefit than others. So anywhere that it's blue, you're better off just using persistence. Essentially, the low frequency is going to drive the forecast. Anywhere that it's red, the MJO is actually contributing favorably to the forecast. And so, for week 1, it's red across the board, no matter what season you're in, no matter what phase you're in. But as you get to other leads, the MJO tends to provide the most beneficial skill during March, April, and May, the least during June, July, and August. Again, the most at the relatively shorter lead times. So with that, I'm going to switch over to sharing a different screen. Let me see. And we'll do a little bit more interactive playing around with the website itself. Okay. So this is what the homepage of the website is. And so you scroll down, there's a few things here that can give you details about how the website works, but the main thing you're going to be interested in. Usually first thing I'll look at when I pull up the website is I usually go straight to the velocity potential Hofmöller. Because again, that's the smoothest way of looking at what's been going on recently. And so again, we see this, very persistent enhancement around 120 degrees east, relatively persistent suppression over 120 degrees west. And it has been moved around a little bit by MJO events. There was a really good MJO event back in July and August that really pushed that signal eastward. That had a subsequent dry phase and then another wet phase. And over here in the Western Hemisphere, we watch these a lot for, get a lot of tropical cyclone development along with the enhanced phases of these events. Although certainly you can get them during the dry phases as well. It's been active all over lately. But right now, the MJO has generally been relatively weak over the last couple of weeks. So really it's been relying much more on just this persistent signal over here. And then, as I mentioned, you can look at other variables as well. You can look at the OLR, shows kind of a similar picture. OLR tends to be more noisy and more focused on the Eastern Hemisphere where the convection is strongest. And you'd also tend to get more differences between the latitudes with OLR. So you can see a different pattern. It's a little bit harder to pick out that stationary signal or the MJO in the Northern Hemisphere, but maybe you get more of the Kelvin wave signals there. Switching to the Southern Hemisphere, 15 south to 5 south. Again, not as much of a signal. It's really seasonally dependent on which latitude band is going to be most useful. Right now, the equator tends to be the best of them. As I mentioned, usually you want the CFS forecast version. The original is that Wheeler-Weichmann method where it's just extrapolating the waves without any model forecast data. And then I found that tropical cyclones, because they produce large anomalies in some of these fields, they can really affect the filtered anomalies. So I've got a version of the Wheeler-Weichmann where I remove those signals first before trying to extrapolate the signals. Another thing that I particularly like to look at is the zonal wind. And as I mentioned, I'll try to compare these patterns with those phase composites that I showed in the previous talk for the different RMM phases. But I especially like to look at the 850 zonal wind for looking at how it's going to, how the MJO and these different waves are affecting the Pacific Ocean air-sea interactions. Obviously, this would be relevant for you in Indonesia as well as these changes in the zonal winds are going to affect how the background flow impinges on the different mountain ranges. But one other type of plot that I have on here is the CFS with SSTs. And so the contours are going to be the same as the CFS forecast. So if you look at them, the contours are the same with both of these. But the shading now is showing OI SST, so the NOAA's daily SST product. And the reason I like to look at this is you can kind of see how the different waves interact with the ocean temperatures. So, you know, back in, we were talking about in July and August, there was a pretty good MJO signal that produced westerly wind anomalies. So if we go back to the CFS, you can see that a little bit more clearly that there was a westerly wind burst. And then when we look at the SST anomalies, you can see there was maybe some warming of the Pacific Ocean in response to that westerly wind burst. And certainly there's been more easterly anomalies recently, very strong easterly trade wind surge over the Central Pacific. And the CFS is predicting that to produce a really strong impact on the ocean, where we're going to see more of a transition towards a more firmly La Nina state in the coming weeks. So then after looking at the Hofmüllers, I'll usually transition to looking at the map, the different types of maps. And there's a variety of different variables, but again, velocity potential is where I tend to go first. And you can click on the image to get a zoomed in picture of it, or get a full window view of it. And just like on the Hofmüllers, this has all the different waves with different colors. The MJO in black, the low frequency in magenta, equatorial Rossby waves in red, and Kelvin waves in blue. Sometimes that can be overwhelming. So you can either, on the website, web interface, you can select your waves and say, I just want to look at the MJO. But you can also edit the URL up here. And so right now this is MJO, so it's only showing the contours for MJO. If I wanted to see all, I would change that MJO to all. If you wanted to see Kelvin, you could change it to Kelvin. And so now it's only showing the Kelvin wave contours. But like I said, you can either do that in the URL or by using these pull down menus. Also in the pull downs, I have the MRG TD waves, which you're not going to see. Let's see, let's find something where that will show up a little bit better. So it's going to, 7 days is too long to look for a MRG wave. So you can look down at 1 day waves. And obviously this is zoomed out too far. So thanks to comments from you guys from last time, now we've got Indonesia. And you can see the daily OLR values with the contours identifying the mixed Rossby gravity waves combined with the TD type disturbances. Yeah, so again, I would usually look at the global velocity potential for 7 days to try to see, is it wave number 1, is it wave number 2, and where are those wet and dry areas generally shifting. And then I would transition to looking at OLR, since that's what we care the most about, because that's the closest proxy to precipitation that we're going to see here. And so kind of going back to the verification work that I was looking at. So the low frequency, that's where you're going to have the best skill. So, in the tropics, persistence is surprisingly hard to beat. And especially when you have strong SST forcing like we do right now with the La Nina, if I was doing a long range forecast, I would be hard pressed not to forecast wet over Indonesia just because it's been wet there for so many weeks. But we do see hints again, if we look at the MJO, that maybe there is a transition happening where this drier phase might be coming into the region. So I'll briefly show, I also have some SST diagnostics here as well, where you can see the most recent couple of weeks of SSTs. Let's see. Was this not actually sure if any of these regions, Australia. Sorry that I don't get the Northern Hemisphere for you guys. That's something I could probably adjust pretty easily. But you can look at the total SSTs. You can look at them relative to a daily climatology, or subtracting out the global tropical mean, so you get relative SSTs. And the left-hand column are the 2 most recent weeks of satellite-based SSTs, and then right-hand column is the CFS forecast. And then the other thing on here that I like to point out is the SST tendency. So in the last week, it looks like it's cooled pretty dramatically in the seas around Northern Australia. But then so this is the difference between the SSTs during this week and the previous week. And then this is the difference between the September 15th to 21st and the week before that. Over here, it's showing the difference between the first week of CFS forecasts and the last week of OISST analyses. And so it's showing that probably it looks like that cooling that happened, either it's transitory or the CFS, more likely the CFS didn't know about it. And so the CFS has a lot of biases in its SST forcing. So it may be that that cooling that happened recently, just the model isn't aware that it had happened. So the other kind of subpage I want to show you here is if you click on RMM up here, I have a number of different tools for looking kind of under the hood at what's going on with the RMM. There's different ways. This is kind of a quick score sheet that shows several different versions of the RMM all at once. So a ridge is the original Wheeler-Hendon method, where they subtract a 120-day running mean from it. Total is the total without doing that subtraction. MJO filtered is running an MJO filter on the U850, U200, and OLR, and then projecting that onto the Wheeler-Hendon EOF patterns. And so that's going to propagate much more smoothly. As you can see, like it has it going through phase 5, 6, 7, all the way around the circle, where the 120-day, the original method also goes through that circle. But if you looked at the total, it cuts through the middle of the circle. And that's because that 120-day mean is way out over phase 4, 5, because that's where the convection has been centered for several weeks now. So that 120-day running mean that it's subtracting looks like phase 4 or 5. So when you subtract that off of the total fields, you get something that's centered more on the origin. So like I said, the MJO filter is going to be a much cleaner, smoother pattern, but you can also break it down by its component variables. So this upper left is the whole thing put together. The upper right is OLR, which almost always is a very small contributor to the RMM index. But in this particular case, you can see there's a really strong U850 component, and that's associated with those trade easterly, trade wind surge over the Pacific is likely contributing pretty strongly to this signal. The other thing I'll point you to is we also have an archive of the website. So I launched this website way back in 2011 as part of the Dynamo field campaign. And so you can actually go back and see not only what the website looked like back then, but you can also look at similar diagnostics back then as well. So here, this was, what the waves were looking like back 10 years ago. But, obviously it's usually more interesting to look at it, just a few weeks or months ago, and you can click on one of those and it'll bring you to an interface looks very much like the live website, but now you're looking at what happened, what the website was showing several months ago. And so it's a good way to kind of look back in the past and see what was going on and how well was the model performing at that time. And then you can always click home to get back to the main website. So I've been doing a lot of clicking around, a lot of talking. Happy to take questions. Hopefully you guys have been playing around with the website as well as I've been talking.
All right. Thanks, Carl. We do have some questions already in the chat box. Okay.
Sorry, I hadn't been monitoring it. Okay.
Oh, that's fine. That's actually my job. And the first, I think we are really appreciative with your effort to add Indonesia on the mapping tools, and is really helpful for us to pinpoint what's going on within the region. So we are very thankful for that. And there's a question from Pamsari here. This is related to the verifications. He said that the RMM show MJO in Indian Ocean, but the spatial map show MJO located on several parts of Indonesia. What's your comment on this, and what the forecaster should do to explain the results to the users or public?
Yeah, so that is a real challenge, and in a lot of cases, like, to me, the RMM is really useful for verification and for modeling and for composites. I don't think it's as useful for real-time monitoring and forecasting. So when I'm doing my own forecasts, what I will do is I will take a look at the Hofmullers or the maps to figure out where is the MJO's enhanced convection. And then I say, let's say it's going to be over the maritime continent. Then I'll go back to the literature and say, what's a composite phase 4-5 signal look like? That's where I use the RMM, is I kind of forecast it based on the maps and the Hofmullers, and then compare that with composites that are based on the RMM. I don't necessarily put as much faith into the RMM in real time or in forecast mode, because there's just a lot that goes into it, and it can get confused by changes in the low frequency state in particular.
Right. The second question is related to the the influence of each equatorial wave to the specific regions in the maritime continent, and there's a specific questions regarding to the flood events happening on September 29th in the western part of Sumatra. Do you think that this case or this event was influenced by MGO or equatorial waves? This is a very specific questions. If you have any educated guess whether it's MGO or any equatorial wave.
So was there a flooding event just this week? Is that what you're?
Yeah, just 2 days ago.
Oh wow. That's a good question. I'm pulling back up the website to try to look at it.
So this is a real-time case study for the event.
Yeah, exactly. Great opportunity. So the one thing, zooming in so much on makes it a little bit harder to see all the contours. So I actually, yeah, it seems like maybe there was a Kelvin wave signal there. Yeah, so I would say, probably a good component of this, a combination of this stationary signal along with this kind of hybrid MJO Kelvin wave. Because this projects both onto the MJO phase and onto there's hints of the Kelvin wave signal there too. The lines are kind of blurry sometimes between the two. You said it was on southern Sumatra, so yeah, I can see it really enhanced.
Yep. All right, let's move on to the next questions.
Yeah, sure.
This is from Dr. Lubis. This is the question is about the further developments of the website. Do you think you will add more functions to improve the projections of wave modes for real-time monitorings or forecasts?
I don't have any plans at this point, but if there's ideas, I'm certainly open to them. I'm not familiar with parabolic cylinder functions, so I would definitely be interested in learning more about that, and definitely want to tag up with Sandro after this workshop too, because I'm really interested in. I think there can be some good collaborations there.
Awesome. And you also mentioned during your presentation that the lead times is really critical, and there's a questions about using 3 months in advance to predict the MGO. Do you think it's something feasible to do?
I don't think we could ever forecast it 3 months in advance. I think so. It's kind of two. I'll answer in two parts. I think 4 to 6 weeks is probably the best we could really hope for the MJO. I mean, right now it's 3 to 4 weeks, at least in terms of the RMM index. And I'll point out that the RMM index, again, is really focused on the large scale circulation. If you look at the actual rainfall envelope of the MJO, the forecast window is probably a lot shorter than that. It's probably more like 2 to 3 weeks instead of 3 to 4 weeks right now. The other side of that is something I've been really interested in for a while, and I don't know that anybody has ever done this, is are there ways that we could use the MJO on a seasonal forecast scale? So, are months when the MJO is months or seasons when the MJO is more active, are those different than months or seasons where the MJO is less active? Or if you have a month where the MJO tends to hang out in phases 4 and 5, is that going to be different than a month where it spends, the MJO is going to go around the circle in 1 or 2 months, but over the course of that, it may hang out longer in one part of the diagram than another. And certainly in historical frames, that would be interesting to look at.
All right, the next question is about attributions. If we have phase 4 or 5 active MJO, and at the same time we have tropical cyclone near the equator, do you think which of these phenomenon influence the maritime continent?
Yeah, I mean, I would certainly think that tropical cyclones are almost always going to trump the MJO, but I think that also kind of goes back to part of why I like to look at all these different RMM diagnostics is that the RMM is really sensitive to the circulation. And so if you have tropical cyclones that are, in the Western Pacific or the Atlantic, producing really strong equatorial westerly anomalies, that can really tilt the RMM in one phase or another. That doesn't necessarily reflect what you're actually seeing in convection or the larger scale circulation. And so that's part of why I think it's really useful to look at the velocity potential or OLR to try to see where the MJO is and not just use the RMM.
And you do have the option to filter out either MJO or tropical cyclone on the website. I think we have some time to answer some questions. You have a lot of questions here. All right. There are several options to select days. Which one should be used to explain MJO and other atmospheric waves?
Yeah, so that's interesting. I usually think of that as being more for you guys to tell me. Like if you're making a 7-day forecast, then I should have a 7-day option on there. If you're making a forecast for tomorrow, you need a 1-day. But yeah, I think the 7-day or even 10-day is great for MJO. I mean, MJO, you could use any of them because it's going to it'll show up. It's the Kelvin and the MRG waves that you really need to use those shorter frames, because, like, for example, a Kelvin wave has a period of 3 to 7 days. So if you use a 7-day averaging window, over the course of that 7 days, you're going to have a wet and a dry phase of the Kelvin wave, and they'll cancel out. So I usually use the 1, 2, or 3 day averaging window for the Kelvin waves.
All right. And the last couple questions is actually a suggestion. So if you can add IOD for your SSD maps.
Yes, that's an excellent suggestion. Yeah.
And the last question is related to probably the impact of the sort of dry period during certain periods in Indonesia. If you can add modest hotspots to detect any potential of wildfires in the region.
Yeah, that would be interesting as well, or certainly. Yeah, and that's something I've always, my main focus is MJO and equatorial waves, and so I haven't looked as much at like drought and wildfires, because I assume that if you're dry this week, if the MJO is making you dry this week, it'll make you wet next week and it'll cancel out. But yeah, it would be interesting to to compare those.
Yeah. So there are a lot of opportunities to have further collaborations between colleagues at BMKG and you with this MGO and eco-trail waves and the impact of those events to the maritime continent and for Indonesia specifically. So I think we have all the questions answered. And so I thank you, Carl, for your time with us. And we're looking forward to having another sessions with you in the near future.
Yes, thank you. And I really hope that I can make it out there in person next year. That would be really, really great. And yeah, and also my email was on all the slides, but I very much encourage you to reach out to me. I would love to collaborate. One of my real goals in my research is to work more directly with people that are more directly affected by the MGO and these waves. So I'm really excited to find ways to apply this science as much as I can.
Awesome. Thank you, Carl.
Thank you.
So let's move on to the next speaker, the last speaker of the sessions, Mr. Ferdi Gustian Utama. Pak Ferdi, if you are already here.
Yes, I'm already here.
Okay, you can start your presentation.
Okay, I want to share my presentation. Please, Mr. Albert, give me allow to share my presentation. Okay, thank you for Mr. Albert for the time and for the all honorable invited speaker, guests, and the participants. Good morning and good evening, depends on your place. Today I'm Ferdi. I represent my marine station as a part of the team when we have activity that recover our the Rama buoys in the June 2020. Okay, this this presentation is a short report of our activity that we do in the June 2020. The activity is recovery the Rama buoys that wash out from the point to the seabird island. And this activity is consists of a team. The team member is consists from BMKG, NOAA, and the Indonesian Army as a stakeholder. And this we can see the part of the member is Missionary Florida, our head of the marine station in the Teluk Bayur, and also the Indonesian Army and the represent from the NOAA female. There is Mr. Kenneth Connell and Mr. Michael. And then our activities begin from when get the information from the lighthouse officer in the seabird island in the early April 2020. And the lighthouse officer informed us where there is a tsunami detection device that he found in the north of seabird island. And then when we confirm the buoy, we get the information that is the Rama buoys. That is a Rama buoys with the code of 6A0. There is wash out from their point to the seabird island. And then this the location. Our assumption where the fishermen get or found the buoy. So what are our response? And the first, we make a communication with the stakeholder in the seabird island. And the second, we arrange a recovery plan for the buoy. And the last is the action is we should bring back and make sure all important component and logger are safe. So for the communication and arrange the plan, the schedule is in April to June 2020, and the execution is on 8 to 10 June 2020. So what we're doing when we make a communication with stockholder? We communicate with officer and to secure the buoy. So the first, we make sure the buoy is secure and safe in the place where they found of the fishermen. The second, we arrange a recovery plan for the buoy. We communicate with the stakeholder also, and make a communication, make good planning to the NOAA partners to plan and find the best method and to secure and bring back the buoy. And the execution is on 8 to 10 June. There is the first, what we're doing in the first, we make a communication. We communicate with the Seabird Island Lake officer. We ask to them to make sure the buoy has safe, and we also make a communication with Indonesian Army to help us to maintain the buoy and save the buoy from the vandalism. And then when we get to the recovery plan, consists of two methods. There is a plan consists of the determine effective schedule, assure the buoy placement after recovery, and then assign a team member, and the last is ensure the field condition. And for preparation, we preparing the tools and the equipment that can we use when we recover the buoy, and we arrange the transportation from the Padang to the Seabird Island. And the last, we ensure the weather and wave condition while we go to the Seabird Island and while we go to the point or the area of the buoy placed. And then our main goal is to retrieve the device. It is a data logger and sensor from the Rama buoy is safely bring back home. So we need a best plan and best preparation. We have a talk or discussion with the Mr. Ken Connell from NOAA PML to give the instruction how to we recover the logger and the sensor safely. And we also make a discussion to the BMKG represented by Mrs. Nelly Florida to ensure and arrange when we go to the field to take the sensor and data logger bring back safely. And then is a tool and equipment this direct send from the NOAA PML to help us get the logger and take out from the logger and the sensor from the mainframe of the buoy. And then in the 8th June 2020, we the team team consists of myself, and my friends in the maritime station in the Teluk Bayur. We depart from the Muara in port in the Padang City at 7 p.m. local time and arrive in Seabird Island at 11 p.m. And after we arrive in Seabird Island, we go straight to the buoy to recover the logger and the sensor. And in the 9 June 2020, we also take the other sensors that we at the early that is safely first with the Indonesian Army. And 10 June 2020, the team depart from Pokai in Seabird Island to the Padang in the Bungus Port in Padang City. It's a documentation of our way depart, and this our journey to the point where the buoy have been anchored in the point. So I will to tell you about the buoy is discovered by the local community in the Labuan Bajo in the Seabird Island. So the distance from the Pokai port in the Seabird Island to the point where the buoy was anchored is approximately 20 kilometers. When we use a boat to the place, approximately we need maybe 10 until 15 minutes from the Pelabuhan Pokai or Pokai Port to the Labuan Bajo. So when we arrived in the Labuan Bajo, the condition of the buoy was anchored in the coastal and the beach, anchored in the beach, still in the water, but the distance from the beach to the anchored buoy is approximately 100 meters. So we work in here, and then this documentation when we take out the logger and the other sensor. Maybe we will show the first one. This buoy that was that and found by fishermen in the North Seabird Island. And then when we zoom out the video, it is like this. So in this activity, our main goal is to take out the logger, and the logger is quite heavy, quite weak, and yes, we maybe 1 hour or until 2 hours we work to take out the logger from the mainframe. This condition is Labuan Bajo Beach. Okay, and then in the 9th June 2020, we take the other sensor that the first when in the early when the fishermen found the buoy, the sensor have been taken out from the mainframe there and take a safe with by the Indonesian Army. There is 3 sensor we take from the Indonesian Army. There is a rain gauge, solar radiation, and the air temperature. And in the 10 June, we bring back all the sensor and logger to our office, marine meteorology station in the Teluk Bayu, Padang. And until now, the logger and the other sensor is safely keep safe in our office. And the update condition of the mainframe of buoy in early September 2020 is the mainframe has been placed on the beach and guarded by the local community. Then when we doing this activity, we get interesting fact. There is we found an older buoy without mainframe that suspected has been found long ago before the recent one. Our hypothesis is there is a persistent or periodic ocean circulation system that washed the buoy away from its original place to the northern region of Seabird Island. Thank you.
Thank you, Pak Ferry, for your presentation.
Yes, thank you, Mr. Albert.
Are there any questions for Pak Ferdi? And thank you for for bringing us up to speed with the recovery operations of the buoy. I think sure.
I have
Yeah.
may I speak? Yeah.
Sure.
First of all, so maybe not so much a question, but just a comment. I want to extend congratulations on a very well executed recovery mission. So, on behalf of NOAA, thank you very much for really going out of your way to recover these, the data logger and the instruments, and also the mooring itself, the buoy itself. And that last slide, wow, that's really interesting that there's another buoy on site. So thank you for that. Very interesting. Anyway,
Yes.
Congratulations and kudos. Thank you.
Yeah. Thank you for the very, very useful experience. Thank you, Ken, for your suggestion and your instruction when we do these activities. So we wait for the next instruction. What should we do with the logger and the other sensors?
Perhaps
Sure,
Bunelli.
we
Go ahead,
wait
Kat.
for Ken to pick up the sensor.
Yeah, and the smaller sensors we could discuss. We have some packaging that we can just ship back. The data logger, we'll have to pick that up in person. So, but thank you.
All right. We're running behind the schedule, so I guess we will have a topic for the next sessions, which is the results of the data from the buoy rescued from the colleagues at Teluk Bayur. And with that, I think I can conclude the 7 sessions of this workshop. Thank you for all the speakers and all the participants in these sessions. And on behalf of the committee, I would like to thank you for joining these sessions. We'll hand it over to Yesi. Thank you.
Thank you, Paul Albert, and for leading the session and discussion. And ladies and gentlemen, we still have one more lecture session. But before we listen to the last lectures, we're going to have a closing session. I would like to invite the head of Center for Research and Development BMKG, Dr. Deli Floridariama, the head of Center for Climate Change Information BMKG, Dr. Dodo Gunawan, and Dr. Sydney Thurston to lead the discussion in the closing session and to compose the recommendation from this workshop. To Bu Nelly, Pak Dodo, dan Pak Sydney, the floor is yours.
Nelly, do you want to begin, please?
Pak Dodo, how we move forward?
Just concluding remarks, I think.
Oh, okay.
Yes, please, Bonelli.
Okay, thank you very much. Yeah, I think this is the final session of this morning session. As I know, yeah, we still have a afternoon session after yeah, Pak Dodo, yeah, after this.
Yeah,
so
we have continuing with the Indonesian session.
Okay. Yeah, first, I want to thank you very much for NOAA College. First, of course, to the chair of the workshop, Dr. Sydney Thurston. Thank you for your diligence and your patience to knock our door, to remind us all the deadline that we need to consider to arrange this outstanding agenda. Terima kasih banyak, Pak Sydney. And of course, for this awesome workshop, it cannot be happen without having outstanding resource person from US and Indonesia. We have, I don't know, maybe we still have Tom Kaf here, Mike, Chidong, Pak Sandro, Ejires, Carr, and from tsunami person from NOAA, we also have John here and Ken. And for that this is the first time that we have a tsunami session, and it's very successful. So for me, as since 2014, I have been this workshop. I can feel how this year this workshop is very outstanding. I think it's because finally we may get used to the virtual session and take maximum benefit of it, despite we cannot meet face to face. So I have a long list in my notes right now on the follow up after the meetings. As I remember, as Professor Rita mentioned, especially on Mike's presentation about the tropical cyclone, and of course for other items that we have been discussed during the business session, like the cruise plan for Indonesia Prima, or for YMC cruise, and for like a special tsunami workshop or training. And I also want to appreciate all participants that are being enthusiastic and very loyal to present from day 1 to day 3 right now. And from my experience, usually it is pretty challenging to have a stable number of participants till today. Last but not least, of course, without Pak Dodo Gunawan and the local organizing committee, we have Pak Supari, Pak Aldi, Yesi, and Pak Amsari and others. I would like to express my high gratitude for your outstanding work. Well done, teman-teman. I do apologize. Maybe sometimes I push you all to your limit, especially when we just request to invite our Minister General Luhut to give the keynote speaker. It just decided about 2 weeks from our workshop. So, but we are very fortunate to have Pak Luhut, and also to have Ambassador Kim as well as Craig McLean on our opening session. Finally, I do hope we stay safe and healthy, and next year we will meet in person, I hope, in Lake Toba, my hometown, hopefully. Thank you very much. Terima kasih banyak.
Terima kasih.
Yeah, Pak Sydney, maybe I also have short notice from this closing remarks. The Honorable Pak Sydney and also all colleagues from the US as the NOAA team, I call them the NOAA team, and also the all speaker resource person and all participants. I think holding the workshop during this COVID pandemic 19 situation is really a big challenge. Yeah. During this situation, yeah, of course, we only carry this workshop virtually or online. So, like from far from much more dynamic discussion when we face-to-face meet like real workshop. But anyway, this situation we have held this meeting with repeat tremendous success. Yeah. Like at the business session now, we have a very strategic meeting to discuss the situation, the continuation of BMKG-NOAA cooperation, where the implementation agreement EA will end in 2022. From this executive meeting also, we evaluate the scope of cooperation that has gone well and which scope is less implemented. This is the matter of our next discussion, how the EA will be prolonged and the scope of cooperation will discuss further. I think this also, as Bu Nelly mentioned, we very successful workshop. Like in this, like in the opening session, we also have the important speakers from NOAA side as well as from BMKG, from the embassy. Even we can invite the Ministry of Maritime Affairs and Investment, Bapak Luhut Binsar Panjaitan as the keynote speakers. Also in general lecture, we have Professor Muhammad Marfai from the Indonesia Geospatial Information Agency that explained about this, the role of this institution, which actually support the information for making early warning related to geohydrometeorological disaster. Also, the Dr. Tom Kauf, about the observation. That's really impressed, and even Ibu Director General of BMKG give us the direction to learn about the observation system from NOAA, National Weather Service. That's, I think, we will discuss further in the implementation agreement next. Also, Mike Baden that explaining about the Indian Ocean, described in great detail. Also, of course, we in next time also with Indonesian scientists, Indonesian young scientists can also doing same explaining of the process in the ocean and the atmosphere, which indeed greatly affect climate variability in Indonesia. Therefore, we in this workshop provide a lot of places here in this workshop for young Indonesian scientists from BMKG and other institutions, including universities. So, and then even nationally, for your information, we are currently experiencing structural changes regarding research institutions and including the researchers. However, this situation does not reduce BMKG scientists who are researchers actually, either later joining with new institution, National Agency for Research and Innovation BRIN of Indonesia, or staying at BMKG to continue to take part in conducting studies for BMKG operational needs. The expression of research for operation and operation for research at BMKG or any national meteorological service, including NOAA, is very much felt since we are the science-based information service institutions. Overall, I have to thank NOAA for the cooperation that has existed so far and hope in the future. The NOAA BMKG collaboration led by you, Pak Sidney, has been mutually beneficial, especially for us, BMKG, in an effort to improve the ability of BMKG staff in running BMKG operation, to produce better services. We also have to thank to research person, speakers who are involved in this workshop in the collaboration with NOAA for sharing knowledge, so that we are always updated and upgraded the new knowledge resulted by NOAA researchers and scientists. Finally, I hope that COVID-19 will end soon and that we will be in a new normal condition so that we can carry out the very important workshop activity in face-to-face somewhere next year, maybe in Indonesia. In Buneli have planned to have a venue in October next year. So hope we can do that. Although with this online method now, we can also carry out this workshop, but with the huge time difference between Indonesia and America, we are very troublesome for the NOAA team because they spend time outside the normal working hours. So for that, once again, we thanks and apologize for this inconvenience. That's my closing remark. Thank you.
Thank you,
Terima
Pak
kasih,
Bunda.
Pa. Dear Bu Nelly, dear Pa Dodo, and dear colleagues, terima kasih. Thank you for your sincere and tireless efforts to build our mutually beneficial ocean climate cooperation between BMKG and NOAA. I believe this is consistent with President Jokowi's maritime vision for Indonesia, and it contributes to our bilateral comprehensive partnership. Indonesia sits at the crossroads of the Indian and Pacific Oceans and is truly a shining beacon for Southeast Asia. And it's also a region of tremendous scientific interest. For providing the vital services of meteorology and climatology to the citizens of Indonesia, and for establishing INAPRIMA, BMKG is to be commended for its leadership in the World Meteorological Organization, WMO Regional Association 5. NOAA greatly values our long-term partnership with BMKG. Over the years and day by day, we have established one of the greatest and longest bilateral ocean climate partnerships in the world. In fact, in 16 years I've been working with Indonesia, I've never seen such overwhelming show of support from NOAA scientists and US scientists to participate in our workshop with Indonesia. Thank you all for your time, your energy, and your enthusiasm. BMKG colleagues, thank you for allowing us to use English during this workshop. And for NOAA and USA colleagues, thank you for allowing this workshop to take place during your local very late nights. So thank you all. I think this strong respect, camaraderie, and trust is actually the bond that has sustained our long-term partnership for so many years. I'm always reminded that collaboration allows us to know more than we are capable of knowing by ourselves. And I think that demonstrates our sincere interest in working with each other. Building on many years of collaboration, we will continue to steer a course together into the future on scientific and societal impacts that are vital as humanity strives to overcome the global climate crisis. Let us all please take daily pride in our precious NOAA BMKG partnership, carrying this pride into our next year of collaboration. Over the past 3 days, we've had excellent rapporteurs. They are compiling a draft document. They will circulate this document for your review and revisions towards a final report and list of recommendations, which will include the following recommendations. Of top priority and very important is to conduct the early 2022 INAPRIMA Rama cruise. As we discussed during the week's business session, we will formulate the planning milestones to make the February-March cruise window identified by Professor Michael McFadden. Second, we are reviewing the Memorandum of Understanding. We are reviewing the Rama Implementation Agreement and possibly other implementing arrangements. Third, we do want to be in Lake Toba, Sumatra in September 2022 for our 17th in-person partnership workshop. Next, I'm working very closely with Director Wasila Tao of the Weather Service Climate Prediction Center International Desk. We are monitoring the COVID situation and we want to get BMKG scientists to the international desk as soon as it becomes safe to do so. We are delighted Ezia has arrived in Seattle to begin her University of Washington studies, and our scientists and colleagues are looking forward to working closely with her. We do want to explore shorter topic-specific virtual training workshops. I think there's opportunity intersessionally between our annual workshop to take advantage of this new platform to provide virtual training sessions. And then finally, additional topics such as we've been talking about volunteer observing ship program in the maritime continent, Ocean Prediction Center, perhaps working more closely with BMKG's Ocean Forecast Center. So in conclusion, together we will continue to make our great nations proud and pride of our work by developing the appropriate ocean observing capacity to deliver the climate, ocean, and weather forecast required to support short and long-term decision-making in the context of climate change. Terima kasih, and may God bless you and your families. Thank you all very much, and good day.
Thank you, Sid.
Thank you, Pak Sydney. Thank you all.
Terima kasih, Pa. Terima kasih, Bu
Terima
Nelly.
kasih semua.
Ya,
Thank
terima
you
kasih.
all.
Thank you, Bu Nelly, Pak Dodo, dan Pak Sydney. Ladies and gentlemen, that would be the end of the closing session. On behalf of the organizer, I would like to once again thank our NOAA colleagues and speakers for your cooperation and valuable contribution in the workshop, and we're really looking forward to see all of you again in person in the next BMKG-NOAA Partnership Workshop. For our Indonesian colleagues, we still have one last session that will be conducted in Indonesian, and we're going to see more amazing speakers. So please don't forget to join our afternoon session after the break. We're going to have a break for approximately 2 hours, and we will meet again at 13:30 Jakarta time. Please enjoy your break and see you again this afternoon. Thank you.
Thank you. Have a nice day. Have a nice weekend.
You too, Nelly. Take care.
Take care. Thank you.
Bye-bye.
Bye.
Thank you, Pak Sydney.
Indonesia is the most beautiful land in the universe. The land where we were born. The nation where we grew up. So many colors that live together in peace. With a million timeless treasures. With an abundance of natural wealth. Indonesia is not just wonderful. Indonesia is a wonderland.
Kota baru gunungnya bermegah, bermegah, bermanapun di Salangkara, bermanapun di Salangkara. Katamu lawanlah Adinda, Adinda iman di dadara, Semalayang iman di dadara, Semalayang. Sayang si patokaan matego tego gorokan sayang si patokaan matego tego gorokan sayang sajojo yumadam ko bisa berpari samuna muna keke samuna muna keke Soleram, anak yang manis, janganlah dicium, sayang kalau dicium, merah pipinya. Kampuanan jauh di Mato, Kunwangsan saya baku lilian, takkan ajo kawan-kawanan lamu, sangke basuh yang surya.
Yang terhormat Pelaksana Tugas Deputi Bidang Klimatologi BMKG, Bapak Dr. Urip Haryoko, MSI. Yang terhormat para pejabat di lingkungan Badan Meteorologi, Klimatologi, dan Geofisika, serta para peserta kegiatan workshop internasional kemitraan BMKG-NOAA yang berbahagia. Assalamualaikum warahmatullahi wabarakatuh, selamat siang, salam sejahtera bagi kita semua. Selamat datang kembali dalam kegiatan workshop internasional kemitraan BMKG-NOAA 2021. Acara selanjutnya merupakan sesi terakhir dari rangkaian kegiatan workshop internasional kemitraan BMKG-NOAA 2021 yang mana mengambil tema MGO and Tropical Waves. Sesi ini akan dimoderatori oleh Bapak Siswanto MSc. Bapak Siswanto saat ini menjabat sebagai Koordinator Subbidang Produksi, Informasi Iklim dan Kualitas Udara BMKG. Tanpa menunggu lebih lama lagi, kami persilahkan kepada Bapak Siswanto untuk memimpin kegiatan pada sesi kali ini. Kepada Bapak, kami persilahkan.
Baik, terima kasih Mbak Hasalika atas kesempatan yang diberikan. Selamat siang semuanya, teman-teman peserta workshop NOAA di sesi ke-8 ini. Assalamualaikum warahmatullahi wabarakatuh. Walaupun ini merupakan sesi terakhir di dalam workshop kita ini, saya berharap mudah-mudahan semuanya masih semangat dan dapat mengikuti kegiatan dengan baik. Dan karena ini Indonesia session ya, ini disampaikan dalam bahasa Inggris atau bahasa Indonesia, Mbak Hasalika? And I don't see any foreigner in the participants list.
Bahasa, Pak.
Oke. Ya, baik. Jadi ini akan menjadi sesi yang lebih mudah ya. Ya, saya pikir kalau misalnya, waduh, saya udah terlanjur kursus ya, nggak jadi sesi bahasa Inggris ya. Baik, teman-teman semua, mudah-mudahan tidak pada ngantuk ya. Kita di sesi terakhir ini akan memiliki 3 pembicara yang hebat. Pembicara hebat kita yang pertama adalah Dr. Ida Pramuwardhani. Beliau adalah PMG muda dari Badan Meteorologi, Klimatologi, dan Geofisika. Nanti kita juga akan mendengarkan paparan dari Pak Dr. Rahmat Hidayat dari IPB. Beliau adalah dosen di IPB University. Kemudian juga kita akan mendengarkan paparan MGO and Tropical Wave dari Mas Fadlil Rizky Muhammad yang saat ini sedang menempuh pendidikan master di University of Melbourne. Saya sapa dulu ketiga dari pembicara hebat kita. Apakah semuanya sudah hadir di ruangan?
Waalaikumsalam.
Waalaikumsalam. Selamat datang Pak Rahmat. Mbak Ida sudah hadir. Dan Mas Fadlil, apakah sudah hadir juga? Mas Fadlil mudah-mudahan bisa menyusul ya kalau memang belum hadir nanti. Baik, untuk mempersingkat waktu, kita akan langsung kepada pembicara pertama kita, yaitu Dr. Ida Pramuwardhani. Mbak Ida ini menyelesaikan masternya di Ilmu Kelautan Universitas Indonesia pada tahun 2012, kemudian melanjutkan dan menyelesaikan program doktor di Fakultas Geografi Universitas Gadjah Mada, dan saat ini beliau adalah fungsional PMG muda di subbidang prediksi cuaca di BMKG. Mbak Ida ini pakar dari MGO dan juga gelombang atmosfer lainnya, karena itu merupakan salah satu topik daripada studi beliau. Untuk mempersingkat waktu, kami persilahkan Mbak Ida untuk menyampaikan presentasinya.
Suara saya kedengaran nggak ya, Mas? Oh, deh.
Kedengaran dengan jelas. Ya.
Baik, ini saya langsung, Mas.
Ya, silahkan.
Iya, baik. Terima kasih Pak Siswanto. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang rekan-rekan semua. Ya, alhamdulillah pada kesempatan kali ini saya diberikan kesempatan untuk menyampaikan mungkin seperti pembicara sebelumnya hasil penelitian yang telah kami lakukan. Baik, saya izin share screen, Pak Sis.
Ya, silakan, Mbak.
Sudah terlihat, Pak, presentasinya?
Ya.
Ya, baik. Terima kasih. Baik, jadi judul presentasi saya untuk hari ini adalah ya, karena memang saya kemarin dipesan Pak Sis untuk menyiapkan dalam bahasa Inggris juga, takutnya ada peserta dari luar, jadi saya juga hari ini saya presentasinya dalam bahasa Inggris meskipun saya sampaikan dalam bahasa Indonesia. Jadi mudah-mudahan tetap mudah difahami. Kemudian judul presentasi saya kali ini adalah Variability of Mid-Julian Oscillation atau MGO and Convectively Coupled Equatorial Wave atau disingkat CCEW di Indonesia. Jadi sekilas tentang CCEW mungkin teman-teman atau rekan-rekan semua barangkali juga sudah cukup familiar dengan istilah CCEW ini karena memang pemateri sebelumnya Dr. Kalk dan juga Pak Sandro juga mungkin juga menyampaikan hal yang serupa. Jadi kalau beberapa kesempatan kita sering mendengar istilah gelombang ekuator, dan untuk CCEW ini adalah sebetulnya gelombang ekuator yang kita identifikasi sehari-hari dalam membuat perakiraan cuaca. Baik, saya langsung saja untuk mempersingkat waktu, saya langsung ke slide saya yang pertama. Jadi data yang saya gunakan adalah data 15 tahun dari data TRMM, yaitu dari 3B42 versi 7, kemudian durasinya atau periodenya dari tanggal 1 Januari 2001 sampai dengan 31 Desember. Kemudian alasan mengapa kami gunakan data TRMM karena banyak sekali keuntungan yang didapat, walaupun saat ini sudah tidak beroperasi lagi ya, sudah digantikan oleh generasi selanjutnya, tapi saya rasa juga untuk kelebihannya juga masih tetap lebih banyak daripada data TRMM. Contoh kelebihannya adalah data yang selalu kontinu, kemudian resolusinya pada zaman tersebut TRMM juga sudah cukup tinggi. Kemudian merupakan gabungan dari beberapa satelit jadi multi-satelit dan sudah dikonversi dan dikolektifkan dan dikonversi menjadi beberapa output, dan salah satunya adalah estimasi presipitasi. Kemudian dari data tersebut, jadi sebetulnya kami menggunakan banyak data, hanya saja data yang mostly digunakan dalam penelitian kami adalah data TRMM tadi. Ada yang pertama kali yang dihasilkan dari data TRMM adalah identifikasi dari spektrum data 15 tahun tersebut, khususnya di wilayah globe ya. Kemudian kami juga membagi ke dalam 2 musim, yaitu musim hujan di Indonesia atau DJF, atau kalau misalnya istilah kerennya boreal winter, kemudian juga di boreal summer atau sekitar bulan Juni, Juli, Agustus, dan September. Dan untuk bulan JAS ini kenapa kami gunakan atau kami ambil data di bulan JAS untuk boreal summer, karena dari hasil penelitian kami lainnya menunjukkan bahwa sebetulnya untuk monsun Australia sendiri secara klimatologis itu lebih tinggi atau lebih signifikan terjadi pada 3 bulan itu, bulan Juli, Agustus, dan September, ketimbang bulan Juni, Juli, dan Agustus. Kemudian dari spektrum ini, baik itu dari musim hujan maupun musim kemarau, kita lihat di sini bahwa fenomena yang paling signifikan yang terjadi di ekuator adalah fenomena MGO, khususnya pada bulan DJF. Dari sini juga terlihat bahwa untuk spektrumnya sangat-sangat kuat sekali. Kemudian diikuti dengan Kelvin, terutama pada bulan JAS, meskipun untuk center terbentuknya atau center perturbasi yang optimum untuk Kelvin itu tidak terjadi di Indonesia. Kalau saya tidak salah, dia lebih ke daerah Pasifik Tengah. Kemudian Rossby Equator juga menunjukkan spektrum yang signifikan di wilayah tropis, dan juga mixed Rossby gravity wave, dan yang terakhir adalah westward inertia gravity. Sehingga kami melakukan penelitian yang lebih kontinu terhadap fenomena-fenomena tadi, baik itu MGO, Kelvin, kemudian Rossby equator, mixed Rossby and gravity, dan juga westward inertia gravity. Dan dari sini juga dapat menunjukkan bahwa dari keseluruhan fenomena yang terjadi di atmosfer, MGO memberikan menunjukkan dampak atau impact yang lebih signifikan, terutama terhadap akumulasi curah hujan, karena data yang digunakan adalah data TRMM. Baik, selanjutnya adalah distribusi MGO dan distribusi dari variasi MGO dan convectively coupled equatorial wave atau gelombang ekuator yang berkouple dengan proses konvektif. Dan ini adalah untuk wilayah global. Dari sini juga kita lihat di bagian kiri adalah pada saat bulan DJF, kemudian di bagian kanan adalah pada saat bulan JAS. Dan pada saat bulan DJF, distribusi variasi dari masing-masing fenomena lebih terdistribusi merata ke baik ke arah utara maupun ke arah selatan, meskipun umumnya lebih signifikan ke selatan, ya, terutama untuk MGO. Kemudian untuk JAS sendiri dia lebih terlihat pergeserannya ke arah utara dibandingkan pada saat bulan DJF. Jadi untuk MGO sendiri, kemudian Kelvin, Rossby equator, mixed Rossby gravity, serta inertia gravity sangat terlihat perubahan posisinya lebih ke arah utara pada saat bulan JAS. Selanjutnya adalah distribusi dari MGO dan CCEW untuk variasinya di wilayah Indonesia. Jadi kalau tadi global, kemudian kami mencoba memotongnya atau lebih fokus ke wilayah Indonesia. Dan dari sini kita juga lihat bahwa pada saat untuk MGO dan CCEW akan lebih dominan di wilayah utara atau di belahan bumi utara ketika musim kemarau atau pada bulan Juli, Agustus, dan September seperti beberapa waktu lalu. Jadi ketika masuk ke wilayah Indonesia, untuk MGO sendiri terlihat lebih bergeser ke arah utara. Sementara pada saat bulan DJF, untuk distribusi variasi masing-masing fenomena ini lebih merata, tapi meskipun untuk beberapa gelombang juga atau beberapa fenomena juga terlihat lebih ke arah selatan, seperti misalnya MGO, kemudian juga Rossby, karena Rossby ekuator pada saat bulan JAS dia sangat jauh di arah utara. Kemudian ini adalah evolusi dari fenomena convectively coupled equatorial wave di Indonesia, khususnya untuk gelombang Kelvin. Jadi di sini kami mencoba melihat bagaimana perjalanan atau propagasi gelombang Kelvin yang dilihat dari hari -2 sampai dengan hari +2. Dan untuk menentukan H-2, H0, dan H+2 ini digunakan lag regression. Dan pada H0 ini menunjukkan bahwa pada saat tersebut gangguan atau perturbasinya lebih signifikan dibandingkan waktu lainnya. Dari sini kita lihat bahwa pergerakan Kelvin, gelombang Kelvin pada bulan DJF, dia terlihat terbentuk pertama kali di wilayah Samudra Hindia sebelah barat Sumatera. Kemudian dia bergeser, ini lebih cepat dibandingkan dengan fenomena gelombang ekuator lainnya. Jadi pada 2 hari setelahnya dia jauh bergeser ke arah Sumatera Selatan sekitar Lampung, kemudian juga Jawa, kemudian juga di Kalimantan Selatan, dan pada hari sesudahnya dia sudah sampai di Maluku meskipun intensitasnya sudah atau amplitudenya sudah mulai mengecil. Selanjutnya yang sebelah kiri ini adalah untuk DJF keseluruhan. Kemudian yang bagian kanan ini adalah untuk DJF pada saat monsun Asia ekstrim. Jadi apabila nilai indeks monsunnya lebih tinggi dibandingkan klimatologisnya, dia menunjukkan kondisi seperti ini. Jadi pada saat dia terbentuk di Samudra Hindia, dia sudah menunjukkan amplitude yang tinggi. kemudian dia bergeser ke arah Jawa, kemudian di wilayah Laut Banda dia masih menunjukkan kondisi yang masih cukup signifikan dengan penambahan hujan sekitar hingga mencapai 4 mm per hari. Meskipun pada kenyataannya selama pengalaman saya menjadi forecaster, untuk Kelvin sendiri pergerakannya beberapa kali terlihat lebih cepat dibandingkan dari apa yang ditampilkan di diagram ini. Kemudian yang di sebelah kanan adalah untuk propagasi Kelvin pada saat musim kemarau atau bulan JAS. Dan dari sini juga kita lihat bahwa pada saat bulan JAS ini gelombang Kelvin aktif di wilayah samudra, di wilayah perairan barat Sumatera, kemudian juga bergerak ke arah sekitar Kalimantan dan Sulawesi meskipun intensitasnya sudah mulai berkurang. Dan dari sini kita juga dapat amati bahwa pada saat JAS ekstrim, jadi pada saat monsun Australia ekstrim, menunjukkan bahwa untuk amplitude gangguannya juga lebih tinggi dibandingkan dengan pada saat bulan JS secara umum. Kemudian saya lanjutkan untuk evolusi atau propagasi gelombang reswi ekuator. Di sini kami bagi menjadi 4 bagian dari H-4 sampai dengan H+4. Kita lihat di sini barangkali juga sudah cukup familiar Bapak Ibu sekalian melihat atau sudah pernah melihat gambar semacam ini. Kalau ada gangguan yang cukup kuat dan kembar di utara dan di selatan, maka bisa asumsi pertama adalah kemungkinan dia adalah ada pengaruh dari gangguan dari Rossby ekuator. Dan ini juga terjadi pada saat siklon tropis Roja. Beberapa kali teramati adanya gangguan Rossby ekuator di Samudra Pasifik dan sekitar Laut Arafuru yang bergerak ke arah Laut Timur. Meskipun pada akhirnya yang di sebelah utara akan cenderung lebih melemah dan di sebelah selatan akan menguat karena sebagaimana kita ketahui juga gelombang Rossby ekuator juga memberikan pengaruh yang cukup signifikan atau dia juga cukup berkontribusi pada cyclogenesis. Dari sini kita lihat bahwa pergerakan Rossby ekuator bergerak dari arah timur menuju ke barat dengan kecepatan yang tidak terlalu cepat dibandingkan tadi Kelvin. Pergerakannya 2 hari sudah cukup jauh, sementara untuk Rossby ekuator ini pergerakannya cukup perlahan. Kemudian pada saat bulan JAS, dari sini nampak bahwa pembentukannya lebih signifikan ada di wilayah utara, di belahan bumi utara. Ini juga kalau dari penelitian sebelumnya oleh Pak Sandro Lubis juga menunjukkan bahwa daerah maksimum gangguan gelombang Rossby ekuator pada saat boreal summer adalah di atas 10 atau sekitar 10 sampai dengan 12 lintang utara. Dan ini juga terbukti pada penelitian ini bahwa memang untuk gelombang Rossby ekuator sendiri terutama pada bulan JAS atau pada saat matahari ada di sebelah utara menunjukkan bahwa sangat maksimum untuk gangguan si Rossby ekuator ini sendiri. Kemudian saya lanjutkan untuk mix Rossby gravity wave. Dari sini kita juga melihat gambar yang serupa meskipun lokasi gangguannya berbeda. Jadi kalau misalnya untuk salah satu cara yang mudah untuk mengidentifikasi gelombang itu adalah apabila dia memiliki 2 fase yang berbeda yang saling mengikuti, di mana mungkin ini adalah fase yang puncak di atas dan ini adalah fase lembahnya, bisa jadi sebaliknya, ini adalah fase yang lembah di bawah, ini adalah fase yang puncak di atas, tergantung data yang digunakan. Dan dari sini kita lihat juga pada saat bulan DJF, pergerakan dari mixed Rossby gravity wave ini terbentuk di wilayah, bukan terbentuk ya, dia lebih signifikan terjadi di wilayah Indonesia bagian selatan, kemudian bergerak ke arah barat dengan kecepatan yang ya tidak cepat dan juga tidak lambat. Kemudian diikuti oleh fase negatifnya atau fase keringnya. Kemudian dari sini juga kita lihat pada saat monsun Asia ekstrim, gangguannya lebih signifikan, meskipun tidak menunjukkan kondisi yang terlalu berbeda dibandingkan dengan fenomena sebelumnya, namun beberapa wilayah dia cukup signifikan dibandingkan pada saat bulan DJF secara umum. Dari sini juga kita dapat lihat bahwa pada saat bulan JS, untuk gangguannya sendiri lebih terkonsentrasi di wilayah utara Indonesia atau di belahan bumi utara, dan hampir tidak mendekati wilayah Indonesia kecuali di wilayah perairan. Baik, saya lanjutkan. Yang keempat ini adalah untuk gelombang westward inertia gravity atau atau WIG. Dari sini kita lihat bahwa untuk gelombang WIG sendiri gangguannya tidak terlalu signifikan di wilayah Indonesia, hanya di wilayah timur Indonesia, yaitu di wilayah Papua dan Maluku. Dan pada hari ketiga pun untuk gangguannya sendiri sudah melemah, dan untuk hari selanjutnya kemungkinan besar sudah tidak tampak lagi di wilayah Indonesia. Dan pada saat bulan JS juga menunjukkan kondisi yang tidak jauh berbeda, hanya saja pada bulan JS dia lebih bergeser ke arah utara dibandingkan pada saat bulan DJF.
Mbak Ida, 3 menit lagi.
Oh ya, padahal masih banyak. Baik, saya coba agak cepat, saya rasa ini tidak perlu ya. Ini juga mungkin barangkali sudah pernah. Kemudian kami mencoba melakukan merekonstruksi atau melakukan dekomposisi data TRMM itu yang sudah difilter ke dalam fenomena MJO. Kemudian kami ambil untuk EOF di mode pertama dan kedua saja. Kemudian kami dekomposisi dengan menggunakan persamaan ini, sigma 1 dikalikan PC1 dikali EOF1 dikalikan 1 per EOF1 yang sudah dinormalize, kemudian ditambah dengan mode keduanya. Kemudian dari situ dihasilkan 8 fase propagasi dari MJO. Ini adalah untuk bulan DJF dan ini adalah bulan JS. Dan untuk bulan DJF sendiri, untuk gangguannya terlihat lebih signifikan di wilayah Indonesia pada fase kedua. Kemudian dia mulai meninggalkan Indonesia pada fase ke-6, dan pada fase ke-7 menjauhi, sudah tidak tampak signifikan di sebagian besar wilayah Indonesia. Dan pada bulan JS juga demikian, pada fase kedua teramati di wilayah Sumatera, kemudian pada fase keempat mencapai optimalnya walaupun lebih dominan di wilayah Indonesia bagian utara. Barangkali Bapak, Ibu, atau rekan-rekan sekalian yang juga sering mengamati MJO akhir-akhir ini pada saat musim kemarau beberapa waktu lalu, kita lihat bahwa MJO cukup aktif ketika dia memasuki Sumatera, namun pada saat melewati Kalimantan dan sekitar Sulawesi, baik itu sekitar fase 4 atau fase 5, maka dia akan lebih bergeser ke arah utara. Kalaupun ada di wilayah selatan, dia hanya gangguan yang tidak terlalu kuat. Dan ini adalah salah satu metode atau metode yang digunakan untuk mengidentifikasi atau melakukan monitoring dampak dari MJO untuk musim yang berbeda. Karena MJO tadi memberikan dampak yang signifikan, maka kami mencoba untuk melihat bagaimanakah dampak dari MJO itu di masing-masing fase yang berbeda, dan tujuannya adalah untuk mengurangi resiko. Misalnya saja seperti saat ini, pada saat titiknya ada di wilayah fase 1, maka sebagian besar wilayah Indonesia akan mengalami defisit dari curah hujan. Kemudian pada saat fase 3 dan jauh dari garis hijau, ini adalah garis standar deviasi, pada saat menjauhi dan ini daerah yang terdampak berwarna biru, maka daerahnya tadi sebagian besar wilayah Indonesia akan mengalami surplus hujan. Dan ini juga kami lakukan untuk musim kemarau. Jadi pada saat musim kemarau juga tidak semua wilayah terdampak atau tidak semua fase memberikan dampak pada wilayah Indonesia, misalnya saja untuk fase 1, 2, dan 6. Namun pada saat fase 3, 4, dan 5 memberikan dampak meskipun pada fase 4 dan 5 dampaknya terkonsentrasi di wilayah Indonesia bagian utara. Saya rasa ini juga, tapi ini sepertinya ini perlu. Jadi untuk MJO sendiri memberikan dampak yang signifikan. Jadi dampak MJO itu signifikan di wilayah dengan tipe monsunal pada saat monsun Asia signifikan. Jadi memberikan penambahan hujan pada saat musim hujan dan memberikan pengurangan hujan atau defisit hujan pada saat musim kemarau. Jadi itu adalah dampak atau pengaruh MJO terhadap masing-masing musim yang berbeda. Namun pada wilayah dengan tipe hujan ekuator dia tidak memberikan, dia tidak dia pengaruhnya lebih kuat, baik itu penambahan maupun pengurangannya. Jadi pada saat musim hujan seperti saat ini, pada saat musim hujan maka dia terjadi penambahan hujan di wilayah tersebut. Tapi pada saat musim kemarau di sebagian besar wilayah Indonesia, pada saat musim hujan di sebagian besar wilayah Indonesia, apabila dia ada gangguan negatif, maka dia tetap memberikan pengaruh, jadi terjadi pengurangan. Beda dengan wilayah dengan tipe hujan monsunal, maka dari sini kita dapat simpulkan bahwa MJO mampu memodifikasi cuaca di wilayah dengan tipe hujan ekuatorial. Namun, dia hanya bisa menambahkan hujan pada saat musim hujan di daerah dengan tipe hujan monsunal dan hanya dapat mengurangi hujan pada saat musim kemarau di wilayah dengan tipe hujan monsunal. Jadi ada sedikit perbedaan dampaknya untuk tipe hujan yang berbeda-beda, wilayah dengan tipe hujan yang berbeda-beda. Dan untuk wilayah dengan tipe hujan lokal sendiri dampaknya tidak terlalu terlihat. Dan ini adalah yang tadi saya sepertinya tidak perlu jelaskan. Sedikit saja untuk dampak MJO dan gelombang ekuator atau CCW lainnya di sini menunjukkan bahwa untuk MJO dan CCW memberikan dampak lebih dari 50% terhadap pembentukan cuaca di wilayah Indonesia, khususnya MJO, karena MJO menunjukkan dampak yang lebih tinggi. Sementara untuk MRG dan IG sendiri, dampaknya sendiri kami rasa tidak terlalu valid karena dia lebih berada, posisi gangguannya lebih berada pada wilayah-wilayah yang jauh dari Indonesia, terutama IG1 ya. Dan karena data yang digunakan adalah data observasi, dan data observasi di wilayah timur Indonesia seperti di wilayah Papua dan Maluku juga tidak terlalu rapat, maka untuk MRG dan IG1 sendiri untuk hasilnya juga masih perlu dilakukan penelitian lanjutan lagi. Kemudian dari sini juga kita dapat simpulkan bahwa frekuensi kejadian MJO dan CCEW memiliki relasi yang linier terhadap amplitude gangguannya. Jadi semakin sering suatu wilayah itu terfilter atau terlewati fenomena MJO dan CCEW, maka semakin kuat intensitas dari gangguannya, dan ini juga memberikan pengaruh terhadap banyaknya penambahan hujan di wilayah tersebut. Kemudian ini adalah dampak diurnal dari CCEW di 7 stasiun di wilayah Indonesia. Jadi kami mencoba menghitung anomali hujan di 7 stasiun pada saat masing-masing gelombang ekuator tadi. Contohnya saja ini Kelvin wave. Jadi pada saat Kelvin wave berada pada posisi puncak atau pada saat amplitudenya signifikan, kami mengamati bagaimana anomali hujannya pada saat musim hujan di sebelah kiri dan pada saat musim kemarau. Dan dari sini kita perhatikan bahwa pada saat untuk Kelvin wave sendiri, pada saat musim hujan, anomali hujannya memberikan anomali hujan positif yang lebih signifikan dibandingkan pada saat musim kemarau. Dan namun demikian untuk diurnalnya, pola diurnalnya tidak teramati untuk Kelvin wave karena masing-masing stasiun menunjukkan pola yang berbeda. Selanjutnya
Bisa dipercepat, Mbak.
Iya, ya baik-baik. Selanjutnya untuk equatorial Rossby ini juga menunjukkan dampak. Kalau ini menunjukkan pola yang berbeda baik pada saat musim hujan maupun pada saat musim kemarau. Kemudian dari sini juga tidak teramati adanya pola diurnal yang signifikan. Namun ternyata pada mixed Rossby gravity wave untuk beberapa stasiun pengamatan teramati adanya anomali positif di waktu-waktu tertentu khususnya pada siang dan sampai dengan malam hari, dan ini juga sangat dipengaruhi kuat oleh kondisi geografis seperti topografi dan orografinya. Jadi masing-masing wilayah memang memiliki pola yang berbeda karena di Indonesia sendiri saya rasa dampak atau kondisi topografi, geografi dan kondisi orografinya juga berbeda. Kemudian kami juga mencoba melakukan forecast MJO dan CCW menggunakan menggunakan metode yang paling sederhana. Mungkin tadi kalau Pak Karsek sudah melakukan atau bermain di dinamisnya, dan juga Pak Sandro juga bermain di dinamisnya, kami mencoba menggunakan data metode yang paling sederhana, metode statistik yang paling sederhana, yaitu AR2 atau autoregressive ordo 2. Kenapa ordo 2? Karena kalau dilihat dari data ini, maka dia 2 hari sebelumnya itu ternyata memberikan peran terhadap hari-hari berikutnya. Dan ini adalah metodenya. Kemudian selain dengan metode AR2, kami juga melakukan forecast atau forecast MJO dan CCEW dengan memfilter data NWP. Dan untuk penelitian kami masih menggunakan data era interim. Mungkin apabila ada penelitian selanjutnya bisa menggunakan data IFS atau dan lain sebagainya. Dan kami juga menggunakan data historis untuk memfilternya. Ini adalah contoh forecast-nya. Kami baru melakukan forecast selama 7 hari, dan ini adalah hasilnya. Dari sini terlihat bahwa MJO memiliki forecast akurasi yang lebih tinggi, korelasi yang lebih tinggi. Jadi kami menghitung korelasinya saja, korelasi yang lebih tinggi, ya ini tentu saja karena dia memiliki siklus atau periodiknya hanya 40, 30, atau 40 sampai dengan 50 atau 60 hari. Dan yang paling tidak ideal adalah untuk Kelvin. Dan ini adalah untuk metode forecast dengan filter data era interim. Di sini juga menunjukkan kondisi yang berbeda karena ada satu kondisi tertentu di mana ternyata data era interim itu untuk forecast di hari ini dengan start waktu yang berbeda atau initial time yang berbeda, maka dia lokasi hujannya itu hampir sama, meskipun intensitasnya berbeda, tapi ternyata kalau misalnya hari ini memforecast 2 hari ke depan atau kemarin memforecast 3 hari ke depan, maka lokasinya hanya di situ-situ saja. Maka sebab itu korelasinya linear dari D1 sampai dengan D7. Dan ini adalah kesimpulannya bahwa MJO memberikan dampak yang lebih dominan terhadap wilayah Indonesia dibandingkan dengan CCEW. Kemudian MJO dan CCEW variasi distribusinya lebih dominan di wilayah utara pada saat monsun Australia dan terdistribusi lebih merata pada saat monsun Asia, baik itu ke arah utara maupun selatan, meskipun agak sedikit bergeser ke arah selatan. Dan dengan metode SMD tadi, Simplified Mode Dynamic, fenomena MJO dapat digunakan untuk memprediksi dan mengidentifikasi wilayah yang terdampak oleh fenomena MJO. Dan pola diurnal masih belum dapat terlihat untuk CCEW, meskipun untuk MRG, untuk gelombang MRG sendiri sudah terlihat lebih jelas di beberapa wilayah. Dan ini juga karena pengaruh ketidakjelasan ini karena pengaruh kondisi geografi yang berbeda di masing-masing wilayah. Kemudian perakiraan MGO dan CCEW dapat dilakukan secara simpel dengan menggunakan metode statistik dan melakukan filter pada model NWP. Demikian Pak Sis, mohon maaf atas
terima kasih.
molornya waktu.
Terima kasih Mbak Ida. Teman-teman, kita berikan apresiasi dan aplaus kepada speaker kita yang pertama dengan memberikan emoticon atau reaction di Zoom. Silahkan memberikan tepuk tangan kepada Bu Dr. Ida Pramuwardani ya. Silahkan bagi teman-teman yang punya pertanyaan ataupun hal-hal yang ingin dikonfirmasi dari apa tadi yang disampaikan oleh Bu Ida, dapat menuliskan pertanyaannya. Mungkin nanti sebelum termin dibuka, saya persilakan untuk menuliskannya di chat, gitu ya. Baik, untuk menyingkat waktu, tadi Bu Ida sudah diberikan waktu fleksibel 11 menit ya. Mudah-mudahan nanti pembicara berikutnya, Pak Dr. Ahmad Hidayat, mungkin bisa lebih presisi waktunya. Pak Dr. Ahmad Hidayat, pembicara kedua kita, beliau adalah dosen di IPB University di Bogor, di Departemen Geofisika dan Meteorologi, menyelesaikan program doktoratnya di Tohoku University, kemudian S2-nya diselesaikan juga di tempat yang sama, dan pernah juga menyelesaikan postdoc ya, Pak Rahmat, dulu di Jamstek, dan juga di Tohoku University. Saat ini beliau adalah ketua program studi atau ketua departemen dari Departemen JM atau Geofisika Meteorologi di IPB. Pak Rahmat, waktunya nanti sampai sekarang 13, berarti sampai 14.33 ya, 14.33. Mudah-mudahan bisa termanage. Beliau akan menyampaikan impact dari MGO terhadap varietas hujan di Indonesia. Jadi meneruskan tadi yang sudah disampaikan oleh Bu Ida. Pak Rahmat, waktu kami sampaikan kepada Pak Rahmat.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat siang, Bapak Ibu semuanya. Salam sejahtera untuk kita semua. Mungkin tadi sampaikan oleh Mas Sis, saya suka kopiannya Mas. Bahwa memang sekarang weekend, sore ya, tapi mudah-mudahan karena ini adalah sesi terakhir, dan kita bisa semangat untuk tetap menyelesaikannya sampai di pembicara ketiga nanti dan diskusi. Saya ingin menyampaikan slide saya, apakah dimungkinkan ya?
Mungkin Pak, monggo silakan.
Oke, apakah sudah terlihat?
Sudah, sip.
Oke.
Ya.
Oke, terima kasih. Seperti yang sudah tadi disampaikan oleh Mas Siswanto, ini ada sedikit perubahan karena dari 3 hari ini memang MGO ini banyak dibahas ya, mulai dari hari pertama, hari kedua, dan sampai hari ini. Saya mencoba untuk melihat bagaimana interaksinya dengan CallCert. Kalau yang hari pertama Pak Donaldi yang memberikan bagaimana diurnal. Kemudian tadi Bu Ida terkait dengan lebih pendek lagi ya, kalau dengan gelombang atmosfer. Saya coba untuk mengambil sisinya untuk yang culture. Jadi apa yang saya sampaikan ini adalah semacam summary dari beberapa studi yang dilakukan terkait dengan interaksi dari culture dengan MGO, khususnya dampaknya di Indonesia atau secara umum di maritime kontinen. Saya berterima kasih sudah diundang juga untuk kegiatan ini. Ini adalah latar belakang kenapa banyak sekali belakangan ini melakukan riset atau penelitian terkait dengan interaksi culture dengan di NGO. Waktu saya di Tohoku University, memang riset saya purely NGO dengan curah hujan Indonesia. Kemudian belakangan ini semakin banyak riset terkait NGO dan juga interaksinya, apakah itu diurnal, apakah itu seasonal, bahkan interannual variability-nya terhadap curah hujan di Indonesia. Nah, riset terkait dengan MGO dengan Notary Call Search ini, salah satu teman saya dulu di Jamstek, Miki Hattori, juga bukan pertama kali barangkali, tetapi mendokumentasikan lebih baik bagaimana peran daripada Notary Call Search ini, dan juga ada NGO terjadi pada saat yang waktu yang bersamaan. Sehingga ada banyak sekali studi sebelumnya yang melakukan riset terkait bagaimana sih interaksi antara tropical dengan extratropical. Kalau kita tropical ini MGO, kemudian sebenarnya NCS ini kan kita bisa anggap dia sebagai extratropical forcing, karena dia berasal dari Siberian height, jadi dari utara. Kemudian mencoba untuk melihat interaksinya dan bagaimana hubungannya atau dampaknya terhadap climate and weather system, khususnya kepada daerah-daerah di tropis, dalam hal ini maritime continent, dan juga sebagian di utara seperti Filipina, Jepang, dan seterusnya. Kemudian NGO juga ini menjadi salah satu riset yang sudah sangat lama. Kalau kita tahu bahwa Maden Julian ini mulai memperkenalkannya di tahun 70-an, 71, 72, berarti mungkin sudah 50 tahunan riset ini terus berjalan dan makin banyak sekali finding-finding yang ditemukan. Ini adalah salah satu riset yang dilakukan oleh PANG 2018, bagaimana interaksi antara kejadian MGO yang berasal dari Equatorial Indian Ocean, kemudian ada NCS dari utara, lalu akan memberikan satu gangguan pada sistem cuaca dan iklim yang ada di daerah yang dilaluinya. Dalam hal ini kita akan mencoba untuk melihat maritime continent. Ini dilakukan oleh PANG 2018, masih cukup baru, melihat apakah si NCS ini punya peran dalam memodulasi atau meningkatkan curah hujan. Nah, dalam risetnya dia mengatakan bahwa MGO ini kan sebenarnya dari barat bergerak ke timur, kemudian melewati maritime continent Pulau Sumatera dan mendapatkan blocking akibat pegunungan yang ada di sana, dan kompleksitas antara daratan dan lautan, yang mana bahan bakar dari si MGO ini akan terputus pada saat dia melewati kontinen, dalam hal ini Pulau Sumatera, kemudian masuk lagi di Selat Karimata, kemudian terbentuk lagi energi yang besar, masuk lagi di Kalimantan, kemudian mulai menghilang lagi. Kemudian ada hipotesis bahwa NCS ini mencoba untuk memperkuat lagi energi yang ada, yang sudah dihamburkan pada saat melewati kontinen. MGO kita tahu bahwa dia adalah propagasi convective activity, dan memang masih sangat debatable apakah dia gelombang atau bukan, tetapi riset ataupun teoritis bahwa MGO ini kan ada bagian mix dari Rossby dan Kelvin, di mana kalau kita melihat Matsuno-Gill pattern, pola dari Matsuno-Gill ini bisa menjelaskan secara dinamis pembentukan MGO. Tetapi karena ini ada modulasi dari SST permukaan, sehingga menyebabkan konveksi. Sehingga kalau dibandingkan dengan tropical waves yang lain, MGO ini cukup lebih lambat pergerakannya atau phase-nya, atau kecepatan fasenya dibandingkan dengan Kelvin misalnya. Kemudian juga beberapa studi bahwa MGO ini terblok kekuatannya oleh kontinen, khususnya di Pulau Sumatera, dan juga beberapa penelitian menyampaikan bahwa seperti 2013 mungkin nanti juga Mas Fadil akan menyampaikan bagaimana impact dari NGO ini terhadap responnya curah hujan di Indonesia, khususnya kepada yang dilihat oleh Bu ini adalah banjir tahun 2013, dan nanti mungkin juga Mas Fadil akan memberikan bagaimana ekstrim ini dipengaruhi oleh si NGO. Nah, ini adalah studi yang saya lakukan waktu PhD, memperlihatkan dari 8 fase yang disampaikan, yang kita kenal selama ini ada 8 fase. Kenapa 8? Sebenarnya ini ingin menyederhanakan. Kalau kita menganggap bahwa MGO itu periodisitasnya 20 sampai 90 hari, rata-ratanya 40 sampai 60 hari. Nah, kalau kita ambil misalnya 8, sekitar 5 harian, kemudian ke fase berikutnya 5 hari lagi. Jadi kalau kita totalkan mungkin sekitar ada 8 kali 5, sekitar 40 harian lah ya, untuk menyederhanakan. Sehingga dari fase ini banyak sekali paper yang sudah menjelaskan, terutama dengan RMM index dari Wheeler and Hendon, menjelaskan, kemudian dibuatlah 8 fase. Ini adalah gambar dari vertical profile atau angin vertikal pada saat 8 fase dari NGO. Terlihat segitiga ini adalah gunung, dianggap bahwa dia di Sumatera, di mana dia melakukan blocking daripada energi atau propagasi dari dari si NGO. Sehingga kalau kita lihat profil NGO terhadap respon curah hujan di Indonesia dari 8 fase, itu umumnya di daratan itu terjadi sangat lemah dibandingkan dengan di lautan. Ini mungkin salah satu penyebab tadi. Dan masuknya NCS ini akan mencoba untuk melakukan fueling atau menguatkan lagi flux yang masuk sampai ke sana. Jadi intraseasonal rainfall variability ini ya dia akan melakukan controlling pada decompaction, sehingga kenapa hampir semua riset yang melakukan ini dia mengambil proksinya adalah OLR karena dia adalah proksi dari konvektif, sementara curah hujan itu kan adalah respon dari curah hujan itu adalah respon dan sampai ke permukaan, sehingga OLR ini adalah salah satu proksi yang cukup membantu atau melihat bagaimana si konveksi ini bergerak. Kemudian yang kedua adalah cold surge. Ini cold surge juga didefinisikan oleh banyak peneliti. Awalnya cold surge ini garis merah garis hitam ini apabila angin lebih dari 8 meter per second pada hari itu, kemudian dia dianggap sebagai cold surge. Lalu muncul lagi Hattori dan beberapa yang lain juga itu adalah chance cross equatorial, lalu mengambil daerah ini sebagai indikator sebagai si NCS-nya, Northern cross equatorial surge. Sehingga dan 2020 ini menurut saya satu finding yang sangat bagus dari Mas Abdillah, ini ada dosen dari ITB, melakukan riset untuk melihat apakah sebenarnya si cold surge ini hanya satu gitu. Nah, dari hasil yang dilakukan ini adalah CAO itu adalah cold air outbreak ya. Jadi sebenarnya itu adalah cold surge, cold air outbreak. Ternyata menurut penelitian Mas Abdillah ini si CAO ini dibagi dua, pathnya, jalurnya, yaitu satu northerly source, satu lagi western source yang bergerak ke arah barat, dan satu yang northerly source ini yang kita kenal selama ini cold surge sense, kemudian apalagi istilahnya ini adalah yang masuk ke daerah melalui masuk ke selatan ya. Ternyata dibagi lagi menjadi 3, ada SCS South China Sea type, ada Philippine type, dan ini lebih lengkapnya bisa dibaca di sini. Terlihat bahwa untuk untuk jalur yang masuk ke Indonesia ini adalah yang kuat itu adalah yang boat type. Boat type itu adalah salah satu dari 3 indikasi dari PET dari NS ini adalah curah hujan dan juga moisture transport terlihat bahwa ini akan sangat kuat untuk masuk melakukan intrusi ke ke maritime kontinen Indonesia. Dan ini adalah cukup lama riset mahasiswa saya juga melakukan hal yang sama, yang sangat sederhana, di mana gambar ini memperlihatkan yang A itu adalah tanpa adanya call search, yang B adalah ada call search, dan yang C itu adalah klimatologinya. Terlihat bahwa angin pada saat call search ini memang sangat kuat. Kalau kita lihat lagi bahwa call search ini kan penetrate atau masuk ke ke tropical area, kemudian melakukan mempengaruhi konveksi dan curah hujan. Lalu call search ini diakibatkan oleh kuatnya kekuatan dari utara akibat adanya perbedaan antara Siberian Height dengan daerah-daerah sekitarnya. Jadi semakin besar perbedaan tekanan yang ada di atas, ini juga akan menyebabkan gerakan atau angin juga akan semakin kuat. Jadi makin cepat angin dan seterusnya, intrusinya juga akan cepat bisa mempenetrasi sampai ke daerah tropikal. Hal yang masih sama terlihat bahwa ini adalah kejadian sebelum call search, kemudian ini tanpa adanya call search, dan ini adalah call search, dan ini adalah MGO. Untuk melihat bagaimana sih interplay antara si MGO dengan si call search ini. Memang apa yang dilakukan oleh FOSI ini belum terlalu clear memperlihatkan karena mix masih sangat mix, tapi terlihat bahwa call search dan no call search dan MGO ini terlihat perbedaan curah hujannya antara satu event dengan event lainnya. Di mana pada saat terjadi MGO ini cukup besar curah hujan yang terjadi, sementara yang call search. Lalu dilihat juga call search dan MGO terjadi secara bersamaan, terlihat bahwa memang cukup signifikan dampaknya terhadap curah hujan yang ada di Indonesia. Ini ada juga dilakukan oleh LIM 2017, lebih clear untuk memperlihatkan bagaimana interplay antara MGO dengan call search. Ini adalah call search event, ini adalah MGO event, dan ini adalah MGO dengan CS, dan memperlihatkan bagaimana rainfall curah hujan anomali terlihat bahwa pada saat terjadinya CS itu memang lebih banyak terjadi di daerah South China Sea, kemudian dia masuk ke Laut Jawa. Kemudian kalau MGO dia lebih banyak di Indian Ocean, tapi kalau kita perhatikan di daratan ini hampir sangat lemah. Lalu bagaimana kalau misalnya MGO dan CS ini terjadi bersuperimpose atau terjadi bersamaan, terlihat tadinya di daerah sini sangat sedikit, kemudian pada saat adanya MGO dan CS ini terlihat rainfall anomali ini cukup menyebar ke beberapa bagian daerah. Ini menyebabkan adanya peran dari CS ini apabila dia terjadi bersamaan dengan MGO. Begitupun dengan extreme rainfall. Lagi-lagi ini mungkin masih perlu kita penjelasan, hampir di daerah di daerah Jawa, daerah daratan, kecuali yang Jawa barangkali ini tidak begitu terlihat dampaknya. Kalau kita bicara dengan ekstrim ini bisa dibaca lebih detail karena ekstrim itu didefinisikan sebagai 95 persentil dari curah hujan yang ada. Nah, salah satu yang bisa menjelaskan kenapa curah hujan lebih banyak pada saat kejadian MGO dan CS ini adalah bagaimana pola dari moisture transport atau transport uap air. Yang ini memperlihatkan tanpa adanya call search, dan ini adanya call search, kemudian ini adalah MGO, dan ini terjadi MGO dengan call search. Terlihat bahwa suplai uap air dari utara, dari barat utara, kemudian dari timur ke barat, dia dia memberikan suplai yang lebih besar dengan menghitung transportnya. Dengan persamaan ini kita dapat mendapatkan bagaimana si transport itu bisa transport uap air di atmosfer itu akan terdeteksi lebih banyak, atau sumbernya bisa dari coal dan juga dari si MGO. Karena cross equatorial source ini akan melakukan transport moisture, kemudian akan menginduce konveksi, lalu akan responnya adalah curah hujan yang lebih tinggi. Lalu begitu juga dengan kehadiran MGO ini akan memberikan dampak yang lebih signifikan. Nah, pertanyaannya adalah apakah ini adalah positive feedback atau sebenarnya dia dua-duanya berinteraksi. Ini juga masih belum terlalu clear, tapi banyak di paper Abdillah 2020 ini ada banyak ada banyak mekanisme yang bisa menjelaskan hal tersebut. Lalu ingin saya menyampaikan juga, ini baru saja terbit mahasiswa S2, teman dari BMKG juga, Vivi, baru saja menyelesaikan S2-nya, melihat bagaimana interplay atau respon curah hujan pada saat kejadian ENSO dan MGO. Kenapa ini saya menarik menurut saya? Karena selama ini riset-riset terkait ini menggunakan data-data satelit, data TRMM, data even itu Aprodite ya, Aprodite, bahwa ini menggunakan data lapangan atau data ground station, yang mana teman-teman BMKG mestinya punya banyak koleksi, dan ini dimanfaatkan oleh saudari Vivi untuk melihat ini. Kenapa? Karena kalau kita lihat ternyata dari 8 fase yang ada, curah hujan ini dari 4.300 station, kemudian kita lakukan quality control, itu hanya ada 303 station yang memenuhi syarat dengan di atas 70% ketersediaan data dan kontinu. Sehingga hanya dari 4.300 kita hanya menggunakan 300 saja untuk melakukan riset terkait bagaimana sih respon curah hujan. Ternyata dari fase 1 sampai fase 8 ini, walaupun dia sama-sama di Pulau Jawa, sama-sama di Pulau Sumatera, terlihat ada yang misalnya negatif, ada yang positif pada waktu yang sama. Artinya impact MGO terhadap daratan, khususnya di Pulau Jawa, Sumatera, dan Kalimantan, ini tidak memberikan yang sama. Lalu pertanyaannya, apa yang membuat itu tidak sama? Nah, salah satu riset yang dilakukan oleh, saya lupa, yang kemarin juga dipresentasikan oleh Mas Donaldi, itu faktor diurnal itu mendominasi di sini, sehingga seolah-olah si MGO-nya ini terhide gitu ya dari total variansi yang ada. Dan kita perhatikan juga kalau MGO ini kan, kalau kita lakukan filtering itu variansinya hanya sekitar 7,5%. Kalau kita lakukan IOF1 dan IOF2, variansinya sangat kecil. Tetapi variasi sangat kecil ini punya dampak. Tetapi dampak itu ternyata kalau kita menggunakan data station lebih hati-hati lagi, ternyata dampaknya itu tidak seragam. Artinya ada yang memiliki dampak positif, negatif, atau mungkin tidak berdampak. Sebenarnya apa yang dilakukan oleh VIV ini ingin memberikan kepada kita bahwa melihat lebih detail lagi, apalagi teman-teman BMKG punya cukup banyak data station untuk melihat melihat lebih detail struktur dari spatial structure daripada respon curah hujan terkait dengan MGO ini. Kemudian dari fase 4, kalau lihat dari sini adalah fase 4 salah satu yang banyak positif curah hujannya, karena banyak yang berwarna biru. Kemudian fase 4 ini dibuat seperti tadi Bu Ida juga melakukan seperti lag regression, kemudian H-3 sampai dengan H+3, terlihat bahwa event itu ada perbedaan antara masing-masing lag. Sehingga kalau kita perhatikan ini adalah data curah hujan, terlihat bahwa background dari gambar ini adalah porositas. Jadi terlihat bahwa pada saat porositasnya positif juga diikuti oleh respon curah hujan yang positif. Artinya dinamika dari atmosfer ini punya peran di dalam respon curah hujan yang sampai ke permukaan. Lalu ini gambarnya memang sangat banyak, tetapi sebenarnya inti dari gambar ini bagaimana observational rainfall response terhadap MGO untuk masing-masing fase 2, 3, 4, 5, sampai dengan 7. Lalu yang bawah ini adalah pada hari H+1, H+2, H+3, apa yang didapatkan sama mirip dengan penelitian-penelitian sebelumnya bahwa pada saat kejadian MGO dengan CS ini meningkatkan curah hujan di beberapa tempat sampai dengan 4 kali dari normalnya. Artinya sekitar ada yang mulai dari 50%, 60%, tapi yang paling tinggi di beberapa tempat ditemukan ada kenaikan curah hujan di beberapa tempat itu 4 kali dari kondisi klimatologinya. Kemudian yang disimpulkan sebagai concluding remark bahwa tropical large scale low pressure ini memberikan impact terhadap curah hujan khususnya di maritime continent, di mana fase aktif MGO, kemudian MGO ini menginduce unstable environment untuk menciptakan yang kita sebut sebagai favorable condition untuk terjadinya convective activity. Satu riset yang dilakukan oleh 2018 itu dia juga melakukan spekulasi bahwa salah satu yang meningkatkan curah hujan itu karena adanya wind terrain mechanism, artinya pada saat si cold surge dan MGO ini masuk MGO masuk ke maritime continent, dia terblocking oleh topografi, kemudian datang si cold surge ini akan menyebabkan curah hujan ini akan semakin tinggi. Lalu interplay atau kejadian yang bersamaan antara intraseasonal variation, extratropical dan tropical ini memberikan kontribusi yang signifikan terhadap presipitasi. Namun kita mungkin sudah banyak sekali riset yang sampai di sini kita sudah sangat memahami bahwa akan meningkatkan. Sebenarnya ada beberapa pertanyaan-pertanyaan riset yang bisa dilanjutkan. Misalnya adalah kenapa misalnya respon curah hujan di setiap daerah stasiun itu bisa sangat berbeda-beda. Kemudian bagaimana apakah yang menginjus itu adalah si cold surge atau kasih MGO atau ada proses interaksi keduanya, sehingga yang dilakukan oleh saudari Vivi ini sebenarnya ada dua bagian. Yang bagian kedua belum saya sampaikan karena bagian kedua ini adalah memanfaatkan data S2S yang ada saat ini, luaran S2S, untuk melihat hal yang sama. Kalau yang tadi adalah data observasi, kemudian bagian kedua dari riset S2 ini adalah menggunakan data S2S untuk melihat apakah keluaran dari data S2S ini cukup promising atau confidence untuk memberikan hasil yang mirip. Kalau yang dilihat dari kemarin ternyata masih banyak yang overestimate ataupun underestimate, artinya masih perlu untuk dilihat lagi, entah itu apakah metodologinya masih yang perlu diperbaiki atau memang kualitas datanya memang seperti itu menjadi PR untuk selanjutnya. Mungkin itu dari saya, Pak Siswanto. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Rahmat. Teman-teman berikan aplaus kepada pembicara kedua kita, Pak Rahmat Hidayat dari IPB, yang telah dengan sangat baik menyampaikan impact atau pengaruh dari MGO dan juga cold surge atau interplay keduanya terhadap curah hujan di wilayah Indonesia. Mungkin kalau ada pertanyaan silahkan juga disiapkan melalui chat box di Zoom. Lebihan waktunya 5 menit, Pak.
Sorry.
Kita lanjut langsung ke Mas Fadlil. Mas Fadlil, apakah sudah monitor? Sudah ada, saya lihat dari di sana ya, Mas Fadlil ya. Baik, pembicara ketiga kita, Mas Fadlil, nanti akan menyampaikan, kalau tadi Mbak Ida tentang lebih spesifik gelombangnya, walaupun juga diidentifikasi dari data hujan satelit gitu ya. Dan tadi juga ditambahkan Pak Rahmat terkait dengan dampak MGO dan juga plus konsep terhadap curah hujan di Indonesia. Nah nanti ini Mas Fadlil lebih meneruskan apa yang tadi sudah disampaikan oleh Mbak Ida dan Pak Rahmat terkait efeknya kepada ekstrim. Mas Fadlil ini S1-nya di IPB, wah ini lulusan terbaik ya tahun 2018, dan saat ini sedang menyelesaikan S2-nya di University of Melbourne ya. Dengan Profesor siapa, Mas?
Saya dengan Claire Vincent dan Andrew King dari
ya,
Flex.
dengan profesornya Mbak Sofia ya.
Iya,
Oke.
betul.
Apa namanya, Mas Fadlil nanti waktunya sampai karena sudah molor ya berarti Pak. Oke. Sekarang 30. Kita usahakan sampai jam itu ya, 15 ya. Bisa itu ya. Ya.
Oke, siap.
Mas Fadlil silahkan lanjut.
Oke, terima kasih Pak Siswanto dan terima kasih teman-teman BMKG sudah mengundang saya di sini. Kayaknya saya paling muda ya. Tapi terima kasih.
Gitu ya sama dosennya ya.
Junior, saya masih junior ya. Terima kasih juga untuk Pak Rahmat atas presentasinya, sangat menarik ya tentang dampak cold surge dan MJO terhadap curah hujan ekstrim di Indonesia. Kebetulan saya S2-nya juga lagi mengerjakan cross equatorial surge ya, yang lepas ke ekuatorial juga terhadap ekstrim juga. Jadi ekstrim terus dari bachelor sampai sekarang. Oke, jadi pertama ini saya akan presentasi ya tentang pengaruh Median Julian Oscillation terhadap extreme precipitation di Indonesia. Ini pekerjaan saya dengan Pak Sandro dan Pak Sony Setiawan. Ya sekarang saya student ya di University of Melbourne di Arc Center of Excellence for Climate Extremes. Kemudian ini Pak Sandro dari RISE, kemudian ada Pak Sony dari IPB. Ini untuk papernya. Di sini mungkin kalau misalnya ada yang berminat, tapi itu kan karena belum nggak open source ya. Jadi bisa visit ResearchGate saya, silakan yang mau di screenshot. Ini bisa nanti visit ResearchGate web ini, ResearchGate nanti minta private full text, nanti saya kasih langsung, atau email ke sini ya, nanti bisa saya kasih. Kemudian di sini ada juga upcoming conference paper ya, bisa dicek di ResearchGate saya, ada Boreal Summer, ya, saya ngerjain Boreal Winter, Boreal Summer-nya saya masukin ke conference paper. Kemudian ini ada upcoming paper juga, lagi on progress, Impacts of Boreal Summer Intraseasonal Oscillation on Precipitation Extreme in Indonesia. Kita sebutnya BESISO ya, BESISO. Jadi ini lagi progress, kira-kira udah hampir selesai sih sebenarnya. Jadi ditunggu aja, nanti kalau sudah saya akan bagikan ke teman-teman juga. Jadi pertama-tama mungkin kita akan ke pendahuluan dulu. Untuk pendahuluannya simple aja, pertama MJO itu kan terbagi dalam dua fase ya, ada aktif dan suppress ya, fase tertekan gitu ya, kalau kita nyebutnya fase aktif dan fase tertekan. Nah MJO itu sebenarnya kan hanya ini aja ya, awan, klaster awan yang berpropagasi ke timur gitu dengan periodenya mungkin 30 sampai 60 hari. Periodenya beda-beda juga sih, ada kadang 40 sampai 50, mungkin bisa juga 20 sampai 90 gitu. Jadi itu bandwidth-nya dia luas ya, untuk periodenya dia luas. Untuk di sini kita ikut dari MJO Clivar ya. MJO Clivar itu dia pakai filter 20 sampai 100 hari. Jadi kita filternya itu dari 20 sampai 100 hari untuk anomalinya. Nah, impact dari MJO ini dia bisa meningkatkan atau menurunkan kemungkinan dari extreme rainfall. Kemudian bisa juga mempengaruhi curah hujan di Indonesia ya. Dari papernya Pak Rahmat, kemudian ada juga total precipitable water di tropik. Nah, ini perbedaannya antara Boreal Winter MJO dengan Boreal Summer MJO, ini dari web NCL. Nah, kalau Boreal Winter itu biasanya dia lebih southward propagation gitu ya. Dia lebih ke southward propagation, southeastward propagation, kemudian dia akan ke selatan, mungkin dia akan ke timur. Sedangkan untuk Boreal Summer dia lebih ke utara, kemudian ke timur. Nah, di sini di presentasi ini saya akan bahas yang Boreal Winter. Untuk Boreal Summer ada di YouTube sih, saya ada di YouTube, mungkin bisa dicek kemarin upload untuk ER ya, conference ER, jadi di situ ada juga saya bahas Boreal Summer. Bisa dicek di YouTube bagi yang tertarik. Nah, di sini memang kan untuk ekstrim ini udah beberapa ada ya untuk MGO tapi dia sebagai global gitu ya, di efek global dia baru lihat Indonesianya ya kecil aja gitu, nggak kurang mendetil gitu. Nah di sini kita coba mendetilkan lagi dengan menggunakan data uploaded ya di sini, dan ada juga data stasiun dari stasiun-stasiun yang BMKG untuk daily datanya. Di sini kita akan melihat efek regional efeknya untuk presipitasinya dan dinamikanya itu gimana gitu. Kenapa dia bisa terjadi peningkatan penurunan curah hujan ekstrim. Nah, di sini adalah anomali ya, anomali curah hujan yang telah difilter 20 sampai 100 hari. Di sini kita lihat ada peningkatan ya untuk curah hujannya. Dan di sini kita tahu gitu kalau misalnya MJ ini memang tidak misal katakanlah MGO di maritim kontinen kalau sesuai indeks itu kan fase 4 gitu ya, fase 4, 5. Tapi efeknya itu ya bisa di fase 2 gitu ya, di fase 2, fase 3, fase 4, fase 5 juga, bahkan mungkin fase 1 gitu. Walaupun fase 1 ini variatif ya, mungkin bisa dicek di paper saya gitu ya, di ini ada yang pakai station juga, di sini saya nggak tampilkan untuk mempersingkat waktu. Di sini jadi bisa terlihat ya, ini ada Vanguard of Precipitation di sini ya, kalau papernya Pittman 2014 itu fase 1 kenapa dia ada efek MGO itu dia meningkatkan diurnal rainfall gitu katanya dari Pittman itu. Nah, tapi di sini summary-nya kita bisa lihat bahwa ada peningkatan di fase 2 sampai 4 over Sumatera dan di Papua itu during fase 1 sampai 5 gitu ya. Nah, kemudian ada juga decrease of daily rainfall during fase 6 sampai 8 gitu ya. Yang fase 6 sampai 8 itu dia lebih smooth gitu ya penurunan curah hujannya, dan ada juga transisi di fase 1 dan 5 yang dia mungkin terbagi 2 gitu antara di west dengan di east. Nah, bagaimana kita mengetahui gitu kemungkinan perubahan di extreme likelihood-nya gitu, atau perubahan di peluang curah hujan ekstrim. Nah, di sini ada caranya, yaitu kita pakai threshold untuk 95 persentil untuk curah hujan di atas 95 persentil itu kita sebut sebagai ekstrim, dan di bawah itu ya biasa gitu. Jadi kita ambil yang lebih dari 95 persentil. Dan ini rumusnya. Dan di sini adalah areal average untuk perubahan peluang curah hujan ekstrim. Nah, di sini bisa kita lihat bahwa ada peningkatan curah hujan ekstrim di bagian barat, west ya, dia 1 sampai 4 ya, smooth gitu ya, bagus ya. Bentuk grafiknya di 10%, 50%. Jadi 10% itu dia meningkat 10% lebih kemungkinannya meningkat 10% gitu ya. Kalau 50% kemungkinannya meningkat 50%, 70% kemungkinannya meningkat 70% gitu. Nah, jadi di sini fase 3 yang memang pengaruhnya cukup besar ya, 3 dan 4 ya terutama ya, 3 dan 4 pengaruhnya kalau kita rata-ratakan itu bisa 70%, 50 sampai 70% gitu. Jadi untuk hampir seluruh daerah untuk fase 3 dan 4 itu cukup kuat gitu ya, cukup kuat untuk di semua daerah. Dan kemudian untuk pengurangan atau decrease extreme rainfall, penurunan peluangnya itu kira-kira ya mungkin sekitar 20 sampai 40% di fase 5 sampai 8. Nah, tapi untuk fase 1 dan 2 ini ada pengurangan juga di bagian timur dan selatan, tapi untuk west, nah ini tidak ada pengurangan ya. Jadi semua bagian kecuali di daerah barat. Nah, di sini kita akan coba mendetilkan lagi dari yang tadi kita average-kan. Nah, ini kita detilkan lagi. Di sini mungkin lebih tadi kan average ya, ini mungkin kita bisa lihat yang berapa sih peluangnya itu meningkat paling tinggi itu berapa gitu. Dan di sini kita bisa lihat bahwa peningkatannya itu hampir 100%, artinya hampir 2 kali. Jadi peluangnya 2 kali lipat lebih besar gitu. Di Sumatera untuk fase 3 dan sekitar 60% untuk di fase 2-nya gitu. Dan ada juga hampir 70% sampai 80% gitu di fase di Jawa dan Papua, dan ada juga 80% di Sulawesi di fase 3 ini ya. Ada sedikit gitu ya. Dan untuk pengurangan peluangnya itu ya mungkin hanya enggak hanya juga ya, sekitar 60 sampai 80% di fase 1 sampai 2 dan 5 sampai 7. Jadi di fase 1 sampai 2 dia ada pengurangan peluang curah hujan ekstrim. Kemudian fase 5 sampai 7 juga ada pengurangan peluang curah hujan ekstrim. Nah, ini untuk dengan data stasiunnya ya, saya ambil 2 gambar gitu ya biar nggak terlalu riuh. Ini kan banyak ya, mungkin detailnya bisa dilihat di paper, bisa minta nanti. Nah, ini untuk data stasiunnya memang secara garis besar dia serupa ya, sama gitu ya hasilnya. Untuk perbedaan-perbedaannya itu mungkin kita belum cek untuk perbedaannya detailnya itu kenapa, tapi kita bisa bilang kalau mungkin ada efek lokal ya di situ ya untuk di stasiun-stasiun tersebut yang mungkin berbeda dari nilai graded-nya. Nah, di sini kenapa gitu ya? Kenapa kok bisa ada peningkatan curah hujan ekstrim, ada penurunan curah hujan ekstrim, itu kenapa gitu? Why gitu ya? Nah, di sini kita akan bahas dinamikanya dengan menggunakan vertically integrated moisture flux convergence atau konvergensi flux moisture horizontal yang kita integrasikan untuk tiap level sampai atas. Nah, di sini kita bisa lihat, oh ya, dan OLR juga. Nah, yang konturnya ini adalah VIMFC ini adalah kelembaban ya, moisture flux convergence. OLR-nya ini adalah yang shaded, yang warna, sedangkan moisture flux-nya ini adalah yang kontur. Dan di sini kita bisa lihat bahwa memang kalau fase 1, 2, 3, dan 4 itu moisture flux convergence-nya itu ada peningkatan di wilayah-wilayah yang tadi disebutkan gitu. Fase 1 dia ada peningkatan di sekitar Sumatera, kemudian fase 2 dia mulai membesar gitu ya, fase 3 dia mulai keseluruhan Indonesia, kemudian fase 4 ya sudah agak meninggalkan Indonesia. Dan begitu juga dengan pengurangannya gitu ya. Dia ada divergensi kelembaban di sini warna merah dan suppressed OLR. Nah, di sini juga berarti pesan yang bisa kita dapat di sini adalah peningkatan moisture convergence plus negatif OLR itu akan menyebabkan peningkatan extreme rainfall probability atau peningkatan peluang curah hujan ekstrim. Sedangkan divergensi kelembaban dengan suppressed OLR akan mengurangi peluang curah hujan ekstrim. Nah, asosiasi ini juga ada di Boreal Summer MGO yang di paper saya yang satu lagi. Kemudian di sini saya juga akan melihat ya vertical cross section untuk vertical moisture advection, artinya adveksi kelembaban yang ke atas itu. Nah, di sini di plot ini kita akan lihat bahwa vertical moisture advection-nya itu warna hijau ya. Untuk warna hijau dia ada peningkatan upward moisture, sedangkan warna kuning dia ada penurunan upward moisture. Dia mungkin ke bawah gitu. Dan blok hitam ini adalah pulau ya, pulau di Indonesia. Untuk yang paling kiri ini Sumatera, kemudian yang tengah ini Jawa dan Kalimantan gitu ya. Kalau yang ini adalah east-nya itu Papua gitu. Jadi ini simpelnya aja gitu ya, simpelnya. Untuk memberikan gambaran terhadap wilayah Indonesia. Nah, di sini mungkin tadi Pak Rahmat ada menyebutkan ada blocking. Ya, di sini kita juga bisa lihat ya seperti ada blocking juga ya di fase 3 ini di wilayah Sumatera ini ya untuk ininya. Mungkin karena itu juga kita melihat bahwa di Sumatera itu paling besar gitu dampaknya, hampir 100, mungkin lebih dari 100% gitu untuk peningkatan curah hujan di beberapa daerah tersebut gitu. Karena di sini ada kombinasi antara upward moisture advection dengan moisture convergence gitu. Jadi seperti itu. Dan untuk fase 3 ada fase 4 yang dia semuanya dia ini upward moisture advection ini berasosiasi dengan peningkatan peluang curah hujan. Sedangkan untuk penurunan downward moisture advection itu berasosiasi dengan penurunan peluang curah hujan. Nah, jadi simpulannya adalah MJO itu meningkatkan kemungkinan peluang curah hujan ekstrim lebih dari 50% hampir di seluruh wilayah Indonesia ketika fase 3 dan 4. Dan yang untuk dry MJO phase-nya itu, dry MJO maksudnya adalah fase tertekannya itu mengurangi sekitar 40-70% di Sulawesi dan Papua ketika fase 1 dan 2, dan Java, Sumatera, Borneo ketika fase 5 dan 6. Dan pengaruh MJO itu paling kuat di wilayah barat ya, wilayah barat yaitu di Sumatera, sekitar Sumatera, dan kemudian pengaruh di wilayah selatan itu di Jawa mungkin agak sedikit lemah karena lokal efek atau mungkin juga efek dengan cold surge ya, ada yang cold surge itu mungkin itu juga mempengaruhi gitu. Ya, mungkin itu juga bisa mempengaruhi juga gitu kan. Mungkin kita harus bisa itu menarik ya untuk selanjutnya gitu. Kemudian perubahan dari extreme event ini, peluang perubahan frekuensi dari extreme event ini, dia berasosiasi dengan lower level circulation karena MJO. Yang kalau misalnya ada peningkatan curah hujan ekstrim, itu dia dikarenakan upward motion dari kelembaban gitu ya, dari convective sistemnya itu ada peningkatan upward moisture advection, kelembabannya itu meningkat ke atas, terus ada konvergensi. Nah, itu adalah sebab dari peningkatan peluang curah hujan ekstrim. Dan sebaliknya, kalau ada downward motion disertai dengan divergence dari kelembaban itu sendiri, maka itu akan menyebabkan penurunan peluang curah hujan. Dan itu aja sampai di sini. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih Mas Fadlil. Tepuk tangan untuk pembicara yang ketiga kita. Silakan teman-teman memberikan reaksi di emoticon reaction. Baik, ini tepat waktu sekali, bahkan saving time ini kalau tidak salah. Oke, Mas Fadlil, you have 2 minutes saving time. Ya, bagus. Kita langsung lanjut diskusi. Silakan teman-teman yang akan mengajukan pertanyaan bisa raise hand kalau ingin mengajukan pertanyaan secara langsung. Dan bagi yang misalnya teman-teman yang menuliskan mengetik di chatroom juga akan saya bacakan. Ini sudah ada satu pertanyaan karena belum ada yang raise hand, jadi saya membaca dulu pertanyaan yang ada di kolom chat dari Nabila Khairana. Dan Nabila Khairana ini sebenarnya Pak Sasmita, ini barusan beliau WhatsApp ke saya. Pak Sis titip didengarkan jawabannya karena beliau lagi sholat, malah yang tanya lagi sholat. Ya, untuk Mbak Ida, pertanyaannya, jika melihat di atmosfer di level 850 milibar dan 500 milibar akan lebih baik karena mesin cuaca ada pada level 2 level tersebut. Nanti silakan dikomentari Mbak Ida. Barangkali Pak Sasmito ingin mendengarkan konfirmasinya kira-kira kalau dari penelitian Mbak Ida yang semua dari gelombang atmosfer yang ada di sekitar ekuator tadi, mulai dari MGO, Kelvin, equatorial Rossby, kemudian mix Rossby gravity, kemudian juga dengan westward internal gravity, gitu seperti apa? Apakah di level ini lebih jelas atau bagaimana? Itu mungkin pertanyaan yang disampaikan oleh Pak Saswat. Kemudian untuk Pak Rahmat ini, untuk Pak Rahmat, data CH yang berjumlah 4.000-an yang layak dianalisis hanya 350. Nah, ini harusnya pertanyaannya kepada BMKG ya. Mungkin nanti juga, tapi memang Pak Sasmita sering mempertanyakan ini juga. Kemudian dari T90 yang berada di dekat pantai dan di tengah daratan ada berapa? Nah, kok tanyanya Pak Rahmat ya? Mungkin tanya ke BMKG ya Pak Rahmat ya. Nah,
boleh nanti saya komentari, Mas.
Ya, nanti silakan dikomentari oleh Pak Rahmat. Mungkin ini yang adakah pengaruh mungkin sirkulasi darat dan laut atau juga topografi terhadap MGO dan pulsat yang tadi sudah dijelaskan oleh Pak Rahmat. Mungkin itu yang nanti berkaitan dengan apa yang tadi disampaikan oleh Pak Rahmat ya. Kemudian juga ada pertanyaan dari YouTube dari Dek Mini untuk Pak Fadlil. Kalau kita ingin melihat faktor apa yang paling berpengaruh terhadap curah hujan di suatu area, bagaimana cara membedakan jika curah hujan tersebut disebabkan oleh MGO atau faktor lainnya. Nah, itu ya. Kalau misalnya ini juga sebenarnya pertanyaan yang saya ajukan juga untuk Mbak Ida terkait dengan studinya ya. Kan Mbak Ida menggunakan TRMM, estimasi curah hujan dari TRMM untuk menganalisis gelombang atmosfer sekitar ekuator gitu ya. Nah, yang ingin saya tanyakan adalah ini kan sebenarnya hujan itu adalah produk dari dinamika cuaca atau faktor fisika di atmosfer begitu ya. Nah, ketika kita misalkan apakah sama nanti ketika kita menganalisis parameter fisik di atmosfer dengan produk hujannya, karena hujan ini bisa juga seperti yang dijelaskan oleh Pak Rahmat tadi, dia bisa merupakan interplay dari beberapa faktor gitu ya. Ketika kita menganalisis frekuensinya, itu apakah sama antara yang produk, end produk, dengan yang parameter asalnya. Misalkan kalau gelombang atmosfer kita dekati dengan ya gelombangnya gitu, misalkan entah dengan menggunakan OLR, entah menggunakan parameter lain, fisik lainnya. Nah, apakah kemudian ketika kita menggunakan hujan sebagai basis analisis kita, itu sama nanti ketika interpretasinya, begitu mungkin. Juga mungkin juga pertanyaan dari yang tadi Mbak Dek Mimin tadi ya kepada Mas Fadlil nanti, membedakannya MGO atau faktor lainnya ketika yang kita gunakan adalah analisis hujan. Ada juga sekalian dikomentari untuk Pak Rahmat. Jadi sekalian satu pertanyaan lagi, apakah cold surge juga berdampak kuat untuk daerah Sulawesi seperti pada daerah Sumatera, Jawa dan Kalimantan? Baik, ketika narasumber sudah mendapatkan feedback dari peserta, saya persilahkan dulu mungkin Mbak Ida. Silakan Mbak Ida.
Ya, baik. Terima kasih, Pak Sis. Jadi, untuk pertanyaan pertama tadi dari Pak Sasmita ya. Untuk level ketinggian 850 sampai dengan 500 milibar ini khususnya untuk MGO mungkin ya. Kalau dari penelitian yang pernah ada, yang pernah saya baca, terutama dari Pak Zhang Xidong, beliau juga pernah presentasi di BMKG, beliau mengatakan bahwa level yang paling mudah untuk mengidentifikasi fenomena MGO itu adalah di level bawah dan atas, karena di level bawah dan atas itu terlihat perbedaan konvergensi dan divergensinya. Tapi kalau untuk melihat di kolomnya tadi mungkin itu bisa ke hasil penelitian dari Mas Fadil tadi, melihat apakah ada downward dan upward-nya tadi. Jadi barangkali itu kalau dari hasil penelitian saya sendiri, saya hanya menggunakan data 850 untuk melihat rata-rata anginnya seperti apa. Jadi memang sampai sekarang untuk yang saya olah belum fokus ke angin ya. Jadi masih ke hujannya. Barangkali di kemudian hari bisa lebih mendalami terutama di bagian anginnya. Kemudian tadi untuk pertanyaan tentang outputnya berupa hujan tadi, kalau kita ini berdasarkan pengalaman saya sebagai forecaster juga ya, kalau background teorinya ini saya mungkin nanti bisa dijawab oleh Mas Fadil ya, tapi kalau yang selama ini kami lakukan itu kan memfilter berdasarkan periodisitasnya, terutama kalau saya dengan memfilter berdasarkan bilangan gelombang dan frekuensi, termasuk tadi include periodenya. Dan dari situ baru menunjukkan hasil, oh di sini akan terfilter karena secara karakteristik dia termasuk ke dalam periode itu atau termasuk ke dalam bilangan gelombang tersebut gitu. Karena saya menggunakan filter tadi, meskipun beberapa penelitian juga mengatakan bahwa MGO ini tidak bisa dikatakan sebagai gelombang karena masih banyak faktor lain seperti tadi dikatakan Pak Hidayat, faktor moisture-nya, kemudian dari SST-nya dan sebagainya. Tapi kalau dari pengalaman sebagai forecaster ini agak dan diskusi kami sebagai forecaster ini agak susah kalau kita menjudge misalnya hujan di suatu wilayah itu betul-betul karena MGO, karena untuk faktor pembentuk hujan sendiri itu sangat kompleks, tapi ya salah satu caranya ya dengan melihat hasil filternya tadi dan juga dengan data-data dinamika atmosfer lainnya, misalnya saja data labilitas di atmosfer, baik itu misalnya dari indeks labilitas, dari CAPE, SI, LI, dan lain sebagainya. Mungkin juga dari indeks-indeks yang lain, misalnya ENSO-nya seperti apa, kemudian IOD-nya seperti apa, mungkin itu Fasis.
Ya, baik, lanjut ke Pak Rahmat, silakan.
Terima kasih pertanyaan dari Bu Nabila ya. Saya boleh share screen nggak sebentar, Mas?
Boleh, boleh Pak.
Biar saya nggak salah, saya khawatirnya salah memberikan ini judgement. Karena, oh ini ya. Oke, mudah-mudahan terlihat ya. Nah, ini adalah data yang digunakan oleh Mbak Pivi. Jadi data itu data stasiun dan data pos hujan, mungkin beda ya. Pokoknya totalnya itu sekitar 4.329. Tadi kan ditanyakan dari 4.300 kok hanya sekitar 303. Nah, bukan masalah kualitas data ini, kita lihatnya dari density datanya, artinya record datanya. Jadi pada satu stasiun atau pos hujan itu apabila dia datanya tidak melebihi dari 70%, walaupun dia tidak beraturan tapi lebih dari 70% ketersediaan data dari 89 sampai 2018 itu otomatis akan dieliminasi ya dari total data yang digunakan, sehingga dengan menggunakan hanya kriteria panjang ketersediaan data 70% dari total yang ada itu tersisalah 303. Kemudian bagaimana dengan posisinya? Untuk yang di Sumatera dan Kalimantan ini bisa kita lihat ya, itu banyak yang di pinggir ya, di sebelah barat gitu. Kemudian begitupun di Kalimantan, tapi untuk Jawa rasanya sangat dense, walaupun ini tercluster di beberapa tempat. Sehingga menurut saya kalau data ini akan semakin banyak yang kita pakai, akan sangat bisa melihat masing-masing daerah ini responnya terhadap si MJOK atau tadi gelombang tropical wave atau misalnya closer atau mungkin interaksi antara keduanya. Nah, intinya adalah kalau kita punya data sebanyak ini dan sebagus ini akan semakin mudah karena semua orang bisa melakukan riset kalau menggunakan data satelit. Karena rata-rata yang tadi saya sampaikan penelitiannya adalah orang-orang luar, kecuali Mas Abdillah yang memang menggunakan data-data KTRMM dan seterusnya. Tetapi salah satu kelebihan daripada risetnya Mbak Vivi ini adalah menggunakan data station yang sangat banyak dan tadinya 4.000 itu bisa sampai ke Papua, tetapi ternyata hanya 303 ini ya kita harus cukup puas ya dengan 303, tetapi kita bisa melihat impact daripada si MJO. Kemudian pertanyaan kedua, apakah tadi di Sulawesi ya kalau nggak salah pengaruh closer-nya. Oke, saya memperlihatkan yang ini kalau dari gambar yang ada, yang ini ini adalah dampak daripada ini curah hujan dan juga moisture factor, sehingga kalau kita lihat ini sebenarnya hampir punya impact gitu ya, punya impact terhadap si MJO dan juga closer. Cuman memang kalau menggunakan data yang digunakan oleh Lim et al. Ini seolah-olah ini ada beberapa tempat yang seperti Sulawesi ini tidak begitu terdampak oleh interaksi antara MJO dan closer. Ini menggunakan apa yang dilakukan oleh LIM ini menggunakan kriteria yang change hanya satu. Tetapi saya mungkin men-challenge, nanti mungkin ada teman-teman yang ingin melakukan riset, coba untuk melakukan apa yang di finding oleh Mas Afdillah, di mana ini dibagi lagi yang change-nya. Jadi masing-masing tipe daripada CNS Water Resource ini, mana yang punya dampak terhadap masing-masing daerah. Kalau yang saya tampilkan ini adalah dampak daripada bot type. Ini kalau menggunakan definisi cold search yang ini akan Sulawesi pun akan terdampak apa namanya. Tapi kalau hanya menggunakan satu yang seperti yang dilakukan oleh Hattori dan beberapa yang lainnya, ini hanya memberikan dampak seperti ini kira-kira. Jadi sangat bergantung pada definisi. Kami, kalau saya pun berspekulasi ini punya dampak tidak hanya Jawa dan Sumatera, tapi mungkin Jawa iya banyak. Sulawesi kenapa? Karena tadi ada tipe dari Filipina. Kolset yang dibagi 3, satunya Filipina ini bisa punya dampak ke Sulawesi mestinya. Tapi kan harus diolah menggunakan data untuk memastikan itu. Tapi saya sih melihat spekulasi bahwa ini punya dampak kalau kita lebih detail atau lebih hati-hati mengambil definisi daripada si kolsetnya tadi. Ini sudah sangat baik. Dan ingin mungkin teman-teman yang ingin melakukan riset, Mas Abdillah ini kan sudah mengkonstruk indeks masing-masing ini, lalu bisa dilihat bagaimana dampak menggunakan indeks ini, bagaimana masing-masing indeks tersebut punya peran atau dampak menggunakan data stasiun itu akan sangat bagus menurut saya dan memberikan pencerahan baru buat kita. Mungkin itu Pak Sis.
Siap. Mungkin juga kalau sedikit bisa dijawab singkat gitu Pak. Tadi kan di presentasi dari Pak Rahmat menyebutkan, dan itu sudah banyak diteliti oleh peneliti juga ya, bahwa pengaruh dari MGO itu lebih nyata di wilayah laut dan pesisir dibandingkan dengan wilayah daratan. Nah, apakah dengan penelitian Mbak Vivi tadi yang menggunakan data stasiun yang juga di situ ada stasiun pesisir, itu juga mengkonfirmasi hal yang sama? Walaupun tadi kalau saya lihat sekilas itu intensitasnya masih yang dari satelit itu sangat underestimate sekali ya Pak, dibandingkan dengan stasiun.
Betul Pak, kalau kita lihat dari Mbak Vivi, hasil Mbak Vivi tadi, justru ada beberapa stasiun justru punya peran respon yang sangat positif. Artinya anomali curah hujan itu meningkat pesat yang tidak terlihat oleh data satelit. Nah, yang dilakukan oleh Mas Fadil ini kan sebenarnya tengah-tengah ya, karena uprodate itu kan merger antara banyak data stasiun, cuman pertanyaannya adalah apakah di Indonesia supply data stasiun untuk uprodate ini density-nya bagus atau tidak. Tapi apapun itu bahwa uprodate ini bisa diambil sebagai proxy dari data stasiun. Tetapi kan kalau misalnya data stasiun semakin banyak data seperti misalnya di Jepang, di beberapa tempat itu kan datanya sangat dense sehingga uprodate-nya akan sangat bagus. Kemudian kalau menggunakan data TRMM kemudian yang lain ini ya itu tetap aproksimasi, tetapi paling tidak konsisten. Saya sebenarnya ingin men-challenge apakah kalau kita menggunakan data ground station-nya dan teman-teman yang ada di BMKG ini akan terlihat lebih jelas lagi ininya responnya, mana yang punya dampak, yang mana yang enggak gitu.
Oke. Terima kasih Pak Rahmat. Selanjutnya ke Mas Fadlil. Ke Mas Fadlil sekalian tadi Mas Fadlil kan menggunakan uprodate ya. Barangkali nanti kita tawarkan lanjutan dari studinya untuk menggunakan SAOPS. SAOPS ini adalah graded dataset juga seperti uprodate yang diproduce oleh BMKG berdasarkan kalau dari sisi density data saya yakin lebih bagus daripada uprodate dan pernah sudah dibandingkan ada di jurnal AMS ya, Journal of Climate. Nanti silakan dicek tulis paper di sana. Kemudian juga di SAOPS ini itu kalau uprodate yang kalau nggak salah 2017 ya terakhir ya Mas Fadlil ya.
2015.
Nah, kalau SAOPS ini kalau tidak salah nanti sekarang sedang kalau yang versi yang sudah dipublish di web itu kalau nggak salah sampai 2017. Kalau yang sekarang sedang di develop sih sampai 2020 sepertinya ya. Nanti akan kita lihat versi berikutnya. Tapi sudah ada itu sudah bisa di-share. Silakan Mas Fadil untuk komentari pertanyaan-pertanyaan tadi.
Ya, makasih Pak Siswanto. Nanti saya coba cek untuk SAOPS-nya ya. Mungkin bisa dipakai kalau misalnya nanti MGO-nya dapat ya, untuk variabilitasnya dapat, mungkin kita bisa pakai di yang SISO ya. SISO. Kemudian untuk pertanyaannya tadi tuh, ini. Faktor apa yang paling berpengaruh terhadap CH di suatu area dan bagaimana jika CH tersebut disebabkan oleh MGO dan faktor lainnya? Oke. Ini sebenarnya lumayan kompleks ya, tapi coba saya menjelaskan dengan sederhana gitu. Jadi pertama gini, kalau kita mau contoh kita ingin melihat apakah MJO, jadi jangan CH terhadap sesuatu gitu. Kita coba MJO terhadap sesuatu gitu ya. MJO atau wave terhadap curah hujan gitu. Nah, ini biasanya kalau untuk anomali ini cukup dengan menggunakan bisa mungkin daily anomaly gitu, presipitasi daily anomaly, kemudian difilter untuk bilangan sama seperti Mbak Ida, filter untuk bilangan gelombang tertentu atau frekuensi tertentu. Kemudian bisa juga menggunakan indeks ya, kalau bisa kayak RMM index. Kemudian dari RMM index itu kita ambil data-datanya, kita ambil tanggal-tanggalnya untuk fase 1, fase 2, fase 3, kemudian kita gunakan itu untuk gunakan komposit gitu, sebagai komposit di anomali yang sudah kita filter gitu. Nah, ini salah satu caranya gitu untuk MJO terhadap suatu. Tapi kalau untuk misal untuk ekstrim, katakanlah ekstrim, kita ingin melihat suatu ekstrim, kita nggak bisa filter. Nah, caranya tuh gimana untuk kita menentukan apakah itu dipengaruhi oleh sesuatu? Ya kita harus balik ke dinamiknya. Balik ke dinamiknya itu ya kita harus cek apakah yang pengaruhi curah hujan di daerah tersebut. Dinamika apa yang pengaruhi? Katakanlah MJO tadi saya udah coba, MJO itu dipengaruhi oleh VIMFC dan vertical moisture advection. Berarti kita cek dua itu, kita filter apakah ada di daerah situ gitu. Nah, kalau itu ada, berarti kita bisa bilang, oh itu karena MJO. Kemudian kita mau cek apakah ada pengaruh ER wave gitu. Ya kita pakai VIMFC tersebut, kita filter, ada nggak di situ gitu. Kalau ada, oh ya ini juga dipengaruhi oleh ER wave. Berapa persen gitu ya, berapa persen. Nah ini kita bisa bandingkan dari hasil anomalinya ini, kita bandingkan besaran mana gitu. Nah itu kita bisa tahu untuk kuantitatifnya itu berapa. Mungkin detailnya nanti ada juga coming paper nanti ada ya nanti mungkin untuk case study gitu ya mungkin yang untuk CH itu ya. Dan kemudian apa lagi nih? Bagaimana jika membedakan jika CH tersebut oleh MJO dan faktor lainnya. Nah ini juga tricky kalau ini mungkin saya asumsi case study ya. Kalau case study itu ya berarti kita harus cek apakah ada MJO di situ, apakah ada ER wave di situ, apakah ada Kelvin wave di situ, apakah sedang ada ENSO, apakah sedang ada IOD. Nah, itu bisa digunakan mungkin dengan filtering gitu, filtering dari data anomali OLR atau anomali VMFC atau anomali angin gitu ya, yang terkait dengan curah hujan gitu. Jadi kita harus punya general study-nya dulu. Kayak tadi saya udah menggunakan general study untuk MJO, dipengaruhi oleh apa saja yang mempengaruhi curah hujan tersebut. Nah, itu kita bisa gunakan untuk case study. Seperti itu. Kemudian ini ada juga pengaruh spesifik MJO terhadap pola hujan ekuatorial dan monsunal. Oke, jadi mungkin maksudnya perubahan pola atau sesuatu ya. Mungkin perubahan pola saya nggak tahu ya, nggak pernah cek juga. Dan mungkin bukan poinnya mungkin bukan lebih ke perubahan pola, tapi apakah ada peningkatan curah hujan di musim-musim terkait. Jadi katakanlah gini, katakanlah Sumatera itu kan pola hujan ekuatorial gitu ya, dampak MJO-nya tinggi. Berarti kita bisa ekspektasi kalau saat musim hujan dan ada MJO di fase 3, 4, itu akan meningkat, curah hujannya akan meningkat dari biasanya gitu. Kita bisa expect seperti itu gitu. Nah, kalau misalnya katakanlah untuk Jawa gitu ya, Jawa. Nah, Jawa itu kan kalau nggak salah fase 3 aja gitu ya misal. Nah, Jawa ya fase 3 di NDJFM, baru dia bisa ada ekspektasi untuk meningkat gitu. Kalau untuk di lain mungkin enggak gitu kayak gitu. Jadi mungkin itu Pak Siswanto, mungkin kalau ada pertanyaan lain.
Oke. Ada pertanyaan lain? Silahkan, saya masih beri kesempatan apabila ada yang ingin menanyakan baik secara langsung menggunakan raise hand atau menuliskan di chat box.
Langsung aja Pak, gimana Pak?
Ya, silahkan Pak Sas.
Ini Pak Rahmat, saya hanya sedikit komentar aja Pak Rahmat. Tadi kalau data yang 4.000 tadi diplot langsung tanpa difilter dulu tuh bisa ditunjukkan Pak, kalau dipakai semuanya yang 4.000 itu diplot aja apa adanya. Terus yang kedua yang 350 itu, kalau itu bisa ditunjukkan itu akan lebih baik, kira-kira seperti itu Pak.
Oke, baik Pak.
Tadi udah ya Pak ya?
Untuk yang 300 memang tadi sudah, karena ini adalah waktu itu final decision bahwa kita pakai data itu. 4.000-nya ada, saya nanti mungkin bisa kontak Mbak Vivi-nya, karena yang 4.000 itu memang akhirnya kita nggak jadi pakai karena yang 300 itu yang kita akan pakai. Makanya apa yang ditampilkan tadi itu ada yang 300 saja. Tetapi kalau nanti memerlukan, mungkin Mbak Vivi, saya lupa di divisi apa ya beliau ya di BMKG-nya. Nah itu nanti sudah diplotkan 4.000 sekian stasiun itu sampai ke daerah Papua kalau nggak salah. Begitu Pak, kira-kira saya nggak ingat persis ininya. Soalnya itu adalah waktu awal-awal proposal Mbak Vivi-nya mengajukan itu.
Ya mungkin kalau diplot semuanya mungkin bisa ada gambaran yang lebih bisa dinamisnya, mungkin gitu hanya ada Pak. Terima kasih Pak.
Sama-sama Pak.
Baik, ada lagi pertanyaan yang lain? Dan kita sebenarnya sudah melewati 21 menit dari jadwal yang diberikan oleh panitia. Tapi saya sebenarnya karena suka berdiskusi juga ya, masih memberikan kesempatan. Ya, menarik tadi kalau di penelitiannya Pak Donaldi yang disampaikan pada hari pertama itu kan ada itu ya pengaruh MGO terhadap sirkulasi diurnal ya, atau terhadap variasi diurnal yang dari timing begitu ya. Nah, tadi sebenarnya ada pertanyaan yang dari Pak Sus yang belum terjawab tadi. Apakah itu berkaitan juga dengan siklus darat laut gitu? Siapa nih yang pengen memberikan komentar?
Siklus darat laut.
Angin darat, angin laut, Pak.
Oke. Saya nggak ini kemarin sih nggak melihat bahwa apakah itu siklus darat dan laut ya. Kalau kita bicara diurnal, salah satu porsi yang besarnya adalah siklus darat dan laut memang. Tetapi bagaimana dia menginjus ini secara mekanisme, ada paper yang kemarin juga yang disampaikan oleh Mas Donaldi 2014 kalau nggak salah, itu memperlihatkan bagaimana diurnal variability ini bisa berubah pada saat ada kejadian. Berubahnya itu intensitinya, bukan polanya tapi intensity. Tadi juga mungkin berhubungan dengan pertanyaan yang apakah memiliki pola. Kalau pola rasanya agak spekulatif kalau kita, karena selama ini memang dilakukan adalah seperti ekstrim, dampak curah hujan itu lebih kepada intensitas curah hujan. Kalau untuk angin darat, angin laut ya, kalau forcing kuatnya untuk diurnal itu di daerah laut, sehingga itu adalah salah satu sebenarnya mekanisme yang bisa untuk digali lebih lanjut bagaimana dia bisa punya interplay dengan si MGO. Nah, MGO ini kan misalnya kalau dia cold surge, dia kan sebenarnya interaksinya dengan intraseasonal dengan seasonal, karena cold surge ini kan adalah part dari monsoon. Kemudian interaksinya atau interplaynya dengan diurnal variability, kemudian yang mungkin agak tidak banyak dilakukan itu adalah MGO misalnya dengan interannual variability, say ENSO, IOD, atau mungkin lebih panjang lagi gitu ya, karena memang pasti akan ada punya interaksi dari masing-masing fenomena ini. Ada banyak sekali sebenarnya spektrum yang bisa untuk digali, apalagi menggunakan data-data yang ada saat ini yang sangat cukup lengkap menurut saya, sehingga akan sangat menarik menjadi finding untuk kita belajar dari hasil-hasil penelitian tersebut.
Oke, baik, terima kasih Mbak Ida, Bu Dr. Ida, Pak Dr. Ahmad Hidayat, dan Mas Fadlil. Saya pikir sudah cukup ya. Mungkin terakhir dari saya, kebetulan baru saja paper saya di-accept di JMSJ. Itu saya menyinggung sedikit, karena sebenarnya saya tidak membahas MGO ya, tetapi saya menyinggung faktor dinamik selain termodinamik yang menjadi stressing dari paper itu, yang dinamiknya case-nya adalah menggunakan MGO. Nah, yang menarik nanti itu juga jadi bahan diskusi, tapi tidak sekarang kali ya, adalah di saya itu terhadap hujan Jakarta saja ya, itu tidak menemukan konektivitas yang kuat antara MGO fase 3, 4 dan 5. Saya juga membuat terhadap semua fase gitu, tetapi yang fase 3, 4, 5 itu memiliki pengaruh yang nyata terhadap frekuensi hujannya. hujan harian, frekuensinya meningkat. Tetapi tidak begitu nyata pada intensitas subhariannya. Jadi saya bedakan hujan dari pagi hari, siang hari, malam hari, dan dini hari. Itu nggak begitu nyata, gitu. Nah ini mungkin nanti bisa menjadi bahan juga bagi yang teman-teman yang lain untuk melanjutkan penelitian terkait dengan MGO yang sepertinya masih banyak yang belum kita ketahui dan belum kita pahami secara baik, walaupun ada hal-hal yang sifatnya umum dari MGO sudah kita ketahui bersama. Dia seperti juga disampaikan oleh ketiga pembicara kita yang hebat saat ini, pada saat fasenya berada di sekitar Indonesia, maka dia akan meningkatkan peluang hujan lebih, kalau tadi bahasanya Mas Fadil adalah likelihood gitu ya, artinya peluang hujan ekstrimnya jauh lebih besar dibandingkan bila tidak ada MGO. Barangkali itu closing statement dari saya, sekaligus juga menutup pertemuan session terakhir dari workshop kita. Mudah-mudahan workshop ini memberikan pengaruh secara ilmiah dan juga kehidupan akademis kita secara lebih baik terhadap pemahaman kita terhadap cuaca dan iklim di wilayah benua maritim kontinen Indonesia. Terima kasih, tepuk tangan yang sebenarnya kembali kepada tiga panelis kita, tiga pembicara kita. Silahkan memberikan reaksinya. Boleh juga tidak hanya tepuk tangan, ya, tapi diberi reaksi yang lain juga. Baik, terima kasih. Saya mohon maaf apabila ada salahnya. Sebagai moderator, saya kembalikan lagi kepada MC. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih semuanya.
Terima kasih semuanya.
Terima kasih semuanya. Silahkan Mbak Lika.
Terima kasih kepada Bapak Siswanto selaku moderator dan para pemateri serta para peserta yang telah berpartisipasi aktif dalam kegiatan paparan dan diskusi pada sesi kali ini. Hadirin yang kami hormati, dengan demikian berakhirlah rangkaian kegiatan workshop internasional kemitraan BMKG-NOAA 2021. Terima kasih atas kehadiran dan partisipasi dari Bapak Ibu sekalian. Saya mewakili panitia yang bertugas memohon maaf apabila terdapat kekurangan dan kesalahan selama acara berlangsung. Akhir kata, sampai jumpa dalam kegiatan workshop internasional kemitraan BMKG-NOAA tahun 2022. Wassalamualaikum warahmatullahi wabarakatuh dan selamat siang.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Siswanto, Pak
Terima kasih.
Sarif, terima kasih Fadil.
Ya.
Ida.
Mudah-mudahan ketemu lagi diskusi selanjutnya, Pak.
Ini tidak sabar membaca papernya ya, Pak.
Masih proses.
Masih proses. Mudah-mudahan lah kita bisa belajar lagi nih.
Siap, siap, Pak. Terima kasih, Pak. Mohon izin leave, Bapak Ibu.
Oke, terima kasih.